and to open this 2025 workshop on the relationship between ship energy efficiency and underwater radiated noise. I also wish to welcome the remote participants online and those who might be watching the event live via the IMO's YouTube channel. I do appreciate everyone's time. I know how valuable it is, and I appreciate you being here to share your expertise, to listen and to learn from each other. I am informed that 2 years ago, many of you met here for the first workshop exploring the link between underwater radiated noise, or URN as we like to call it, and ship energy efficiency. That meeting highlighted how the technologies and operational measures aimed at improving ship efficiency can also significantly and sometimes in complex ways affect underwater noise. This 2025 workshop builds directly on that foundation, guided by new research, additional data, and the continued implementation of the revised guidelines for the reduction of underwater radiated noise from shipping to address adverse impacts on marine life. Sometimes at the IMO we have terrible names for our guidelines, that's perhaps one of them, a mouthful, but it tells us what's in there. The revised guidelines for the reduction of underwater radiated noise from shipping to address adverse impacts on marine life. These revised guidelines expand on earlier guidance regarding the interactions between URN reduction and other objectives, such as energy efficiency, biofouling control, and ship safety. And they call on naval architects, shipbuilders, operators, classification societies, and administrations alike to integrate URN management planning from the earliest stage of ship design. In parallel, the IMO's regulatory framework on greenhouse gas emissions and energy efficiency has been in place since 2013 and steadily continues to evolve to fulfill the vision of the 2023 IMO Greenhouse Gas Strategy. Measures such as the Energy Efficiency Design Index, the Energy Efficiency Existing Ships Index, and the Carbon Intensity Indicator continue to drive innovation in hull design, propulsion technologies, and operational practices. Many of these same developments can also help to quiet the oceans, whereas some of them may have unintended consequences that we should aim to understand better. The number and diversity of presentations scheduled for today and tomorrow demonstrate that the momentum for exploring these synergies is strong. The insights from this meeting will also directly inform capacity building efforts under the GEF UNDP IMO Glow Noise Partnership Project, through which the IMO and our partners are assisting developing countries to build up their capacity to measure, manage and mitigate underwater noise from commercial shipping. I want to stress we want this workshop to be a conversation, not just a series of presentations. Please utilise the time as best you can. Ask questions, use the time in the margins over the coffee breaks and receptions to quiz each other, to learn from each other. I encourage all participants to engage openly and to share your findings and experiences, both successes and challenges. Collaboration between experts working on ship energy efficiency and underwater acoustics is becoming stronger and presents opportunities to advance two environmental priorities together: improving energy efficiency of ships and reducing underwater radiated noise. Let me just finish these opening remarks by expressing our appreciation to our moderators, Mr. Eric Bourdin, Ms. Layla Hatch, Ms. Michelle Sanders, and Mr. Jesse Spence. Thank you for agreeing to facilitate these technical discussions. I also mentioned Michael earlier, also Michael Kingston. He'll be guiding us through the program over the next 2 days. And I wish to thank the GEF UNDP IMO Glow Noise Partnership and the Government of Belgium for their generous sponsorship of the coffee breaks and this evening's reception. I want to especially express thanks to the IMO staff, both in my division, the Marine Environment Division, and the Maritime Safety Division for their efforts in preparing this, and the external experts who have helped to organise this workshop. And last of all, thank you to all the speakers and participants for your time, expertise, and let me stress this last word, enthusiasm. I'm looking forward to a really interesting discussion and a number of informing and engaging presentations. The only thing left for me to do now is to wish you all a very successful workshop. Thank you very much.
Thank you very much, David. The objective of this workshop, and it's deliberately named a workshop because, as David says, it's to promote interaction between you, the audience, and the presenters and the moderators. The aim is to continue to improve collaboration among industry, ship owners and operators, government, civil society and academia to address the challenges of improving energy efficiency and reducing underwater radiated noise from vessels. Results from the 2023 workshop were reported to the 10th meeting of the IMO's Ship Design and Construction Subcommittee, and the following needs were expressed at that workshop. The need to continue to update findings on the interrelationships between energy efficiency and underwater radiated noise to allow ship owners and operators to select measures that match performance goals and requirements for specific ship types and operational modes. Baseline measurements conducted by appropriate and practical methods were further noted as essential to providing validated benchmarks for demonstrating the efficacy of new operational technology and design approaches that reduce energy efficiency and underwater radiated noise. The need for more incentive schemes and other mechanisms to de-risk and encourage early adoption of integrated energy efficiency and underwater radiated noise reduction technologies and measures for ships. The need to further explore the most promising opportunities for optimizing energy efficiency gains and achieving underwater radiated noise reductions in the early ship design stage using an intentional systems approach and considering more holistic reconception of propulsion and novel technologies, many of which are also suitable as retrofits. The need for tools available to support prediction of both energy efficiency and underwater radiated noise baseline and scenario results for fleet, routes, regions, and countries to continue to be empirically validated in order to accurately reflect the results of changes in ship designs and operations. The organisers of this second meeting focused on these needs in identifying 4 themes. The first 2 themes we will explore today. Theme 1 includes updates on energy efficiency and underwater radiated noise technical advances. Our second theme for today focuses on integration of energy efficiency and underwater radiated noise management, including cost evaluations and the development of incentivization indicators. You will hear about case studies from industry and other maritime stakeholders who are supporting underwater radiated noise and energy efficiency planning, evaluating costs and developing the technical basis for incentives. You will see that there are several question and answer time periods throughout the day, and we are looking forward to very interactive engagement from all of you. Here in the room, you have microphones and you can raise your hand, and online you can also raise your virtual hand, and our moderators will provide you the opportunity to ask your question. And can I remind you that in the room, when you speak, you press the button for the microphone and make sure that you turn it off when you've finished speaking because the camera follows the speaker. We remind you to please remember to state your name and organisation when you ask your question, and if there is a particular panellist to whom you are directing your question, please also make that clear. Tomorrow, we resume our meeting to address the last 2 themes. First, the development of design standards or best practices for integrating energy efficiency and underwater radiated noise in new builds or more comprehensive retrofits. And our last theme will welcome speakers to share their experiences building models to predict both energy efficiency and underwater radiated noise as tools to evaluate the potential to realize co-benefits both for shipping today and under different scenarios for future shipping. David highlighted the workshop's co-sponsor, the Glow Noise Partnership, which is a project involving the Global Environment Facility, the United Nations Environment Programme, and the International Maritime Organization. You will hear more about what Glow Noise is up to during a presentation tomorrow, and we thank Glow Noise again for their sponsorship. So without further ado, I now hand you over to the moderators today, Ms. Michelle Sanders of Transport Canada and Mr. Eric Baudin of Bureau Veritas, and I wish you a very fruitful workshop. We have almost 300 physical attendees and 150 joining online, so there are a lot of people here, and it makes for a very productive meeting. So thank you, Michelle and Eric. Over to you.
Excellent. Thank you very much, Michael, and good morning, everybody. It's lovely to see such a full room for the second workshop, having been here for the first, and remembering the excitement in the room and the desire to have a second. It's really great to see everybody here and engaged and ready to be engaged, I should say. We have a very full agenda, so we're not going to spend a lot of time listening to me, but I did want to just kind of pull from Michael said earlier about the themes for today. So we're going to be focusing on the first two themes, the updates on technical energy and URN reduction advances, and integrated energy efficiency and URN management, cost evaluation, and incentivization. And as you will see throughout the day, the panels they're mixed. So the themes kind of are covered within each grouping. You will have presentations on both themes. This was done purposely. For the Q&A, what we're going to do is focus more on the specific presentation. So if you have questions of clarification or more information on the outcomes or anything like that, or the methodology, please use those Q&A sessions to ask those questions to the panelists. And then you'll see at the end of the day, we have a bit of a plenary session where we get to kind of explore a little bit more fully the kind of integration of kind of the presentations across the themes. And kind of what that means more broadly for addressing the relationship between the two issues. So if you have kind of more high-level questions, kind of think about them in the context of the plenary discussion, because appreciate that, you know, there might be a presentation in the morning and a presentation in the afternoon that might relate to each other. So save those questions for the panelists for the plenary, because they will all be involved in that discussion as well. Anything you wanted to add at this point? No? Excellent. Well, we're going to start with our first panel then. So get into the details. But so for our first presentations, we have 4 esteemed panelists. We have Roel Hoenders, who's going to be speaking the update on IMO energy efficiency work. Marie-Lucie Susini will be speaking about the update on IMO underwater radiated noise work, so we kind of understand where IMO is in those 2 areas. Then we have Mr. Daniel Alvarez, who will speak about energy-saving devices, market uptake, and URN-EE case studies. And finally, Mr. Ben, I really should have asked your pronunciation before we started, Kirschmeier, who will be speaking about URN measurement results from electric fast charge tugs, ferries under the US Maritime Administration META program. So without further ado, Mr. Hoenders, the floor is yours. And it's up to you if you want to stay at your seat or take the podium. It's your preference.
Thank you. Let me stay here because I can have a better view in my slides rather than from the distance. So very good morning, everyone. Thank you very much, Michelle, for introducing me, and very good to see you back in this building. Always a pleasure. I was here 2 years ago for the first URN workshop as well, and I actually think that there were less participants back then. So it's good to keep this momentum, or actually build on the momentum back in 2023, and have more people on the house today than we had back in 2023. I'm going to build on a little bit of what the director of the Marine Environment Division just introduced in relation to the 2023 IMO greenhouse gas strategy, and in particular the energy efficiency measures that have been adopted under the strategy in MARPO Annex 6, and how these measures can actually have a co-benefit or are functioning in synergy with some of the objectives in relation to reducing underwater radiated noise. So very quickly, back in 2023, that was not only the year of the first URN workshop, it was also the year that the 2023 IMO greenhouse gas strategy was adopted here in July in the MEPC, the Marine Environment Protection Committee of the IMO. And that strategy really paves the way for the shipping industry towards a net zero future to be achieved by and around 2050. And you can see here on the slide the reduction curves in terms of absolute greenhouse gas emissions that were also agreed back in 2023, and as well as some of the targets for 2030. And I think in the presentation today, I'm going to highlight particularly some of the work that has been ongoing within the IMO in relation to the 2030 target, notably the 40% carbon intensity improvement target that was agreed back in 2023. Very important, the strategy is a strategy. It doesn't contain binding obligations. It's a strategic document, but as you probably are aware of within the IMO, we work on the development and the implementation of binding regulations in the various conventions that we have at our disposal. So MARPOL, particularly MARPOL Annex 6, being the main instrument of the IMO to regulate atmospheric emissions from ships. And you see here on the slide, it has been in place for quite a while now, since 1997. More than 100 parties, 108, covering almost 100% of the world tonnage. There are various chapters in MARPOL Annex 6. Chapter 3 focuses primarily on air pollutants, sulfur, nitrogen oxides, so the global sulfur cap, as well as the emission control areas that are in place in different parts of the world, have been adopted under Chapter 3. Today, I'll focus primarily on Chapter 4. And Chapter 4 of MARPOL Annex 6 contains a range of energy efficiency requirements, and I'll get back to those in a minute. What's important to keep in mind, though, is Chapter 4 applies to ships of 400 gross tonnage and above. Chapter 4 does not apply to ships solely operating in national waters. However, parties are encouraged to ensure that also these ships that operate in domestic waters are compliant with the MARPOL Annex 6 regulations as far as reasonably and predictable. And I think today, tomorrow, some of the examples that will be brought forward in the discussions are of ships operating in domestic waters. And I think there is obviously, whilst MARPOL Annex 6, the requirements in Chapter 4 do not apply to these ships, I think there is a lot of, as we have seen also in other domains, there's a lot of experience making pilots in relation to technologies that can be experimented on board of these smaller ships and can hopefully later be transposed into ocean-going vessels, so ships over 400 GT and above. So, Chapter 4, there's quite a comprehensive framework already in place in relation to energy efficiency requirements. As the director mentioned this morning, these requirements have been in place for well over a decade. First regulations came into force in 2013, the EEDI, and have been progressively expanded, including with the short-term measure, the IMO greenhouse gas short-term measure, which was agreed in 2021, and which put in place the so-called EEXI and CII, talking about nice acronyms. In addition, in MARPOL Annex 6, there are requirements in relation to mandatory fuel consumption reporting under the so-called IMO data collection system. This applies to ships of 5,000 gross tonnage above, and there are approximately 38,000 ships that annually report their fuel consumption to the IMO. And this fuel consumption, I'll come back to that in a minute as well, is driving a lot of kind of the policy making and having knowledge about what are the actual emissions of ships today. There's also a requirement in Annex 6 for ships to have a so-called Ship Energy Efficiency Management Plan, the SEMP, which focuses really on ships to get a better understanding of their energy performance, their fuel use, and it can be used to continuously audit the performance of the ship and thereby taking additional measures. Now, what's important for all of these measures, and I'll start with the EEDI in a little bit more detail, is that they're goal-based. So you won't find back in MARPOL Annex 6 any of the technologies that we're going to discuss today and tomorrow in great detail. It's left to the operator, to the owner, to decide on how it wishes to achieve the targets set out in MARPOL Annex 6. Of course, we know that there's quite a range of technologies, devices, operational measures available that can help improving energy efficiency and have positive impacts on noise reduction. But as I said, these won't be spelled out in MARPOL Annex 6. So MARPOL Annex 6 being fuel and technology agnostic. EEDI in place since 2013, and there are almost, we're now moving towards 11,000 ships that have been EEDI certified. All ships are now compliant or have to be compliant with phase 3. And unlike some of the other measures in MARPOL Annex 6, the EEDI applies to new builds. So these are basically requirements for ships coming out of yards worldwide. We're now in phase 3, as I mentioned, and the different phases for different ships have gradually become more stringent in terms of energy efficiency requirements. And now for some of the ship types, the bench line for, or the baseline, or the reduction, the improvement of energy efficiency compared to the baseline is 50%, and this is mostly for the large container ships. So under the EEDI, we have seen various propulsion, energy-saving devices, innovative technologies coming into place or having been taken up. And you can see that those technologies range from in front of propeller technology, after propeller, including around the slipstream, rudder bulb fins, stators, conventional propeller types, boss cap fins, contra-rotating propellers, and I think some of the people here on the panel will go into all these in much more detail. What is interesting is that quite recently the MEPC adopted a specific guidance, you can see it here on the bottom of the slide, on the treatment of innovative energy efficiency technologies for the calculation and the verification of the attained EEDI and EEXI. So IMO has continuously been working also on how to integrate some of these technologies in the calculations for compliance with the EEDI and the EEXI. Very briefly, EEXI in essence is similar to the EEDI, but when it came into force in 2022, it actually put in place requirements for existing ships. So whereas the EEDI put in place requirements for new builds, the EEXI also extended that scope to existing ships. And by now we have actually seen that most of the ships that report to the IMO data collection system, so around 30,000, have also reported their EEXI compliance certificate. The certificate had to be done at the first renewal survey under the International Energy Efficiency Certificate after entry into force. And again, we see that under the most stringent requirements, EEXI requirements, energy efficiency, the reduction factor is up to 50%. The most prominent technology that has been used for compliance under the EEXI is so-called engine power limitation and shaft power limitation. So these are really the main devices or technologies that we have seen being taken up since the EEXI has come into place. CII, contrary to the EEDI and the EEXI, applies only to ships of 5,000 gross tonnage and above, and as such is aligned with fuel consumption reporting. And the CII is an interesting one. It's not a one-off certification like the EEDI and the EEXI, but it actually involves an annual improvement or an annual operational requirement. And that annual operational requirement is monitored based on the fuel consumption of the ship, and then the ship is rated against its peers. So peers in the same ship type and in the same ship size for its annual energy efficiency performance. As this is operational energy efficiency, we have seen more implementation of more operational measures, such as speed optimization, including just-in-time operations in ports that play an important role in the fuel consumption and thereby the rating of the ship. We've also seen quite an interest in the uptake of biofouling and hull coating, and I'm sure that's a topic that will be addressed in great detail in these 2 days. Weather routing and trim optimization are also measures that have been seen an uptake under the compliance cycles for ships with the CII. The CII, the annual operational requirement, has been recently, so in MEPC 83, have been further strengthened and has now been, for the 2030 target, is a 21.5 improvement compared to the 29 baseline. So that is the requirement in place now for ships over 5,000 gross tonnage and above. Now, wrapping up, I think what's interesting to see is that IMO's energy efficiency framework has actually led to quite a substantial improvement in carbon intensity. In the Secretariat, we monitor annually what are the improvements of carbon intensity, and you can find on IMO Docs our annual report to the MEPC on the improvements of carbon intensity. Depending on the metric that's being used, the carbon intensity improvement is now somewhere between 31% and 38% compared to the 2008 baseline. And as I said on my first slide, we're thus nearing the 40% improvement target set out in the greenhouse gas strategy for 2030. So I think we can say that carbon intensity, energy efficiency of the global fleet is moving in the right direction. Unfortunately, the absolute emissions of ships are not going down yet. We see that there are more ships coming into place, operating worldwide. We also know that distance traveled is increasing because of a certain number of effects, but the operational energy efficiency of ships is definitely improving. Last point on the IMO greenhouse gas study. I think there's some interest in that as well in terms of using some of the data of the greenhouse gas study for purposes in relation to underwater radiated noise. The fourth IMO greenhouse gas study, you're probably familiar with that. It's already dating back to 2020, and the latest data that the greenhouse gas study contains is 2018. MEPC is now working on terms of reference for the fifth IMO greenhouse gas study, and these terms of reference should be agreed by the upcoming MEPC in April next year. The greenhouse gas study includes inventories, estimates of carbon intensity, as well as emission projections, and the plan is provisionally that the final report is to be submitted to MEPC 87 in spring 2028. So that's it for me, and I'll hand over now to my colleague, Laura, who will just give you a bit of an overview of the Future Fuel project. Thank you very much.
Hello, good morning. I will present the Future Fuels and Technology project, which is an initiative to support IMO's regulatory work in the area of greenhouse gas reduction and energy efficiency. Launched in 2022, the project was designed to provide IMO delegates with technical analysis and the latest data to support evidence-based decision-making. The project provides comprehensive information on alternative marine fuels and technologies to reduce GHG emissions from shipping. But how does the project do that? First, the project conducts global studies and research to support regulatory decision-making at the MEPC. So far, 2 major studies have been completed, and you can access them by using the QR codes displayed on the screen. Sorry. Second, the project has developed the Future Fuels and Technology online information portal, which is a dedicated website offering free and easy access to relevant information and the latest data on alternative marine fuels and technologies. The portal has been created in collaboration with over 22 data providers, and you can explore it using the QR code displayed in the middle of the screen. The portal is always looking for new collaborations, so if your organization would like to contribute, please contact us at futurefuels@imo.org. Under the third work stream, the project organizes technical seminars The next technical seminar that will be held at IMO headquarters will be the seminar on biofuels on the 12th of February 2026, and more information can be found in Circular Letter 5065. Finally, the project promotes the 2023 IMO GSG strategy. You can watch the promotional video developed under the project using the last QR code. The project is also supporting the work on underwater radiated noise by disseminating the information presented on the workshop. For instance, the workshop is currently being live streamed in the Future Fuels online information portal, and the recording and presentations will be available on the website for future use. I will finish my presentation with a question to you. If during the workshop you see any scope for using the Future Fuels website in relation to underwater radiated noise, please reach out to us. Thank you very much.
Thank you very much, Roel. And oh my God, I'm sorry, Laura, I forgot to introduce you in the beginning. Laura, I was about to say Louise. I'm like, that's not right. For the overview. And just for those who maybe weren't here the first time, and I think this is something to keep in mind as we go through, especially the presentations on that relationship of technologies. During the first technical workshop, we had a report done by Vard Marine that compared technology that are being used for EEDI and EEXI, and looking at what are the URN benefits. Like, the whole goal here is to understand we have these mandatory requirements for EEDI and EEXI. How do we leverage that to address what the co-benefits could be, understanding that in some cases there is a trade-off. And so how do we prioritize those where we actually see the co-benefit? And that's a little bit under theme one, what we're hoping to kind of get at during this next 2 days is, you know, we kind of, there's a yes versus no, like it's yes there is or no there isn't. I think we're beyond that. It's a much more nuanced understanding of what that relationship is, and yet that's what you'll see kind of coming out of some of the presentations today. So to kind of help lay the groundwork on the URN side, and I should say the Vard Marine, if you haven't seen it, it is on the IMO website under their underwater noise page. There's a link to the Vard Marine report. I was remiss, again, we had two presenters in this next one. So Ricardo Batista from the Maritime Safety Division of the IMO Secretariat will kick off, and then over to Marie-Lucie. Ricardo?
Thank you, good morning. My mission is to, in 5 minutes, give you a quick overview of the main blocks of IMO work on URN. And the URN guidelines were first approved in 2014, and only 10 years after those, the revised guidelines come into place as a substantially more complex document with substantial more information, and including relevant technical provisions, the URN management planning, and a key focus in Section 7 to the interrelation between URN reduction and greenhouse gas energy efficiency. Associated to the implementation of the URN revised guidelines, the URN action plan comes into place with 9 areas of work with several work streams to be accomplished, all invariably short-term and high priority. So here, the URN action plan is a substantial tool to support the implementation of the revised URN guidelines. The experience building phase, defined as a period of 3 years and started at MEPC 80 just in 2023. So as you can see, we're approaching the end of the experience building phase. An important a period where experience is communicated, processed, and where future initiatives are developed and designed based on this feedback approach. The experience building phase includes this relevant input stream into the IMO work on URN, and it's currently being further developed and processed with the in-kind support from the United States and Canada, to who we are grateful to have this support in-kind consultancy expert support. We look at the future policy initiatives here and what can come after the experience building phase. And we look into that crystal ball and we see that we can either revise further the URN guidelines and make it an even more helpful document. We can introduce specific provisions on ship design designed to mitigate URN. A possible conclusion on this assessment between the interrelation of greenhouse gas, energy efficiency, and URN reduction, and definition of URN targets. So this may be, after the experience building phase, the outputs that may need to be further assessed. In the revised URN guidelines, we have technology spotlights, which are the URN reduction approaches. And here, invariably, a large number of them are also energy efficiency approaches, and measures such as hull form optimization, a number of techniques and approaches to mitigate cavitation, machinery installation, vibration damping, and so on. So these are important spotlights from a technology perspective, remarkably related to ship design, that are in the revised URN guidelines. As regards the URN management planning, here different stakeholders are identified in the revised URN guidelines as having an opportunity to contribute to URN management planning. And the URN management planning basic concept is definition of a baseline, definition of measures to improve URN towards specific targets. And these all established on a voluntary basis, so that the processing and the analysis can be done at ship level by ship owners and by other stakeholders. And here ship owners defined having the opportunity to contribute to the planning by establishing the URN management plan, specifying in specific ship designs URN requirements, designers designing accordingly, shipbuilders building accordingly, suppliers, manufacturers with equipment supplied with specific URN specifications, class societies with important silent ship notations, maritime authorities as supporting stakeholders to support this management planning, and operators to operate and meet these URN targets. This is an important concept of the revised URN guidelines, but a voluntary instrument. The URN action plan includes 9 areas. You have these areas here. They go from the establishment of the experience building phase to standardization of measurement of URN and other areas, all of them with several work streams under each area. And you have here a link to further explore information on the action plan. And the final slide, as we look ahead, we have essentially the experience building phase now being implemented with a possible decision of extension to take place next year. Currently 3 years plus possible 2 years of extension. It's a key element to receive experience and input from application of the guidelines. The continuous exploration of this interrelation between energy efficiency and URN, a correspondence group on which Dr. Marie-Lucie will further highlight you on its development, possible inclusion of reference into the Polar Code, and availability and continuous dissemination of information. And here I pass the floor to my colleague, Dr. Marie-Lucie. Thank you very much, and enjoy the workshop.
Thank you very much, Ricardo. Good morning, everybody. My name is Marie-Lucie Susini. I work for the Belgian Ministry of Transport, and I will present some of the results of the SDC 11 Correspondence Group on underwater radiated noise. So a little bit of background, even though Ricardo did it just before. Since MEPC 82, the organization has developed a lot of efforts to reduce underwater radiated noise from ships. At the moment, we are in the experience building phase, which aims at collecting information on lessons learned and best practices in the application and the uptake of the revised guidelines. As Ricardo said, the target completion year is 2026. So the work of the correspondence group, we produced 4 deliverables. First, the EBP framework to assess the revised guidelines implementation and effectiveness. Second, a review of the technical objectives of the URN action plan. Third, an inventory of all URN emission studies available. And fourth, we drafted terms of reference for a URN modeling study addressing identified gaps. The correspondence group also considered the need to establish a working group at the forthcoming SDC session, session 12, and we prepared draft tours. First, the EBP framework. It is, for the moment, an Excel-based tool to compile IMO submissions in order to support uptake of the revised guidelines through implementing the URN action plan. It derives summary statistics on submissions content across various topic areas. It tracks progress on implementing the revised guidelines and action plan. A link to access the EBP framework on a read-only version is available in the report, paragraph 21. Of course, the tool is not finalized yet. It's a work in progress, and the correspondence group reflected on how to improve the EBP framework. For the moment, it's an Excel-based tool. It would be great to transition to a dedicated platform in order to improve accessibility and organization of submissions. We must also ensure that the EBP framework is accessible, either publicly or through controlled access. We should encourage anonymized data sharing, include relevant documents submitted outside the URN agenda, and also clarify the Secretariat's role in hosting the platform and managing the review process. Alors, in the second part of our work, we reviewed the technical objectives of the URN action plan and next steps. All of our work is not reflected here. You can access the report for other suggestions, but the group reflected on priority areas for IMO to advance before the end of the EBP, and we ranked the priority areas. So the first one was to encourage sharing of energy efficiency URN co-benefit case studies. Second, promote a voluntary URN baselining submission template. Third, enable controlled sharing of the EBP framework. Fourth, facilitate peer exchange on noise management plan development. And fifth, issue a circular updating needs for EBP reporting. Another reflection was on actions for prioritization by parties, not the IMO this time, and useful products. 5 priority deliverables were identified. Develop a URN sensitive area framework and global dataset. Comparative analysis of port-based URN incentive schemes, best practices web hub for URN mitigation, validated comparison report on board versus in-water URN measurement approaches, and a review of ultrasonic anti-fouling devices. As for the inventory of the studies, a total of 18 URN modeling studies is available in the EBP framework. Some key findings, the full info is available in the CG report, of course. International efforts have generated best practices and common terminology for the analysis parameters of large-scale and longer-term URN prediction studies. Studies projecting URN from larger-scale and longer-term distribution of vessel traffic are being conducted around the world, and modeling studies differ in their inclusivity of vessel types and operational states depending on their applications. Regarding the URN modeling study, again, Annex 6 of the report gives the draft tour. Alors, baseline vessel URN for international shipping will be generated for the year 2008. Results will be compared and discussed with the aim of identifying an estimate for vessel URN from international shipping on an annual basis from 2018 to 2025. Additional URN-directed vessel intervention will be explored in future scenarios, and resulting estimates of URN trends and future projections will be considered relative to a variety of vessel-specific, regionally specific, or global targets or objectives for URN reduction. Working group at SDC 12, so we propose some tours. I don't have time to develop, but you can find them as well in the reports. Good news, it was confirmed yesterday that it will be an expert group at SDC 12 in January next year. The full report will be available soon on IMO Docs as SDC 12/8. And I would like to thank you for your attention, thank all the members of the CG, and my special thanks to Canada and the US for funding the work of those two amazing consultants, Dr. Aurélie and Dr. Leila. Thank you.
Excellent. Merci, Marie-Lucie. So next up, we have Mr. Daniel Alvarez from Lloyd's Register. Over to you.
Thank you very much. Good morning, everyone. Thanks for the opportunity to present some of our work. For those of us who work in acoustics for a long time, we started to learn about energy-saving devices because we have always been taking care of noise. But so I thought when I got invited here to have a chat, I thought I'll give you an update of what's going on the uptake regarding technologies that have been installed and those that probably will affect our particular topic in the URN. We advocate in Lloyd's that in a way we need to take a holistic approach for URN. So here we are talking about efficiency, but obviously people is super important. There's tons of people getting deaf still for many years on board. And yes, it's not outside in the water, but actually there's some connections to the people. There's some connection to material. And I think that we have a bigger a better speech when we go holistically for URN. Obviously, mammals are exposed, persons are exposed. So you don't want to think what the mammals are feeling when we still have deaf people out there. If you look at the cruise shipping industry, which is one of the subjects on my case study later, there's about 21% of on the new order book that are taking some kind of EST. As opposed to 12% on the existing fleet. The numbers down there show you that as 1,300 opposed to 125 ships being ordered. That is a massive increase, but at the same time it also shows you, and I'm not here to evaluate those efficient in URN, but I just want to highlight those that are actually or may be doing some difference in URN. So you can clearly see that air lubrication systems here and rudder bulbs and so on are actually being implemented and may have some benefits. So I would encourage to, in a way, focus efforts to understand what those devices are doing for URN. If you look at what it is in terms of the size of shipping, or this 125 I mentioned, the majority of them are actually for ships that are above 100,000 GTs, where there's a lot of air lubrication being ordered. The rest of shippings aren't doing too much that may be relevant. Perhaps there's some on boss cap fins that are being installed, but otherwise all the others are not really considering anything that may have a benefit for URN. If you look at others, which have a much larger amount of ship orders, so 1,300 on the order book for bulk carriers, tankers, and so on, there's a big uptake of solutions. Yet probably not many of them are actually doing a difference in terms of URN. Container ships, 992, LNG carriers 341, are taking all the types of solutions which I would just encourage everyone to focus for URN, because URN will not just jump by itself without synergies with other areas. So I have here the pleasure to present a case study together with Princess Cruises and Silver Stream. It's a work we've been doing through the last 6 months, I'd say, to understand their fleet. And I'll just present you through what's happened is in the last, I'd say, 5 to 10 years, we went from doing URN measurements to designing URN measurements, simply because right now we cannot have implications to the operations of the vessel. So you may understand that schedules are fully booked. You don't want to stop a container vessel that is going full speed somewhere to do your testing. So in a way, we went to preparation one day for URN measurements on a ship on a research vessel to actually spending weeks to plan something that actually makes sense. The right location has to be there. So obviously background noise avoidance out in Asia is just impossible to do low noise background. And we have to choose the good season, of course, because otherwise we don't get good data. We focus on having a notation for a specific operating condition. So we do not, you are absolutely sure that making a silent vessel, as it's called, in all the speeds is not possible or is absolutely expensive. We encourage the use of permanent arrays. So wherever we've been trying to approach any permanent array that is happening is a defense or any type of research, in order for us to get data in an easier way. And obviously, we're trying to be realistic on what is possible to the ship owner. You can't do a silent vessel right easy on an existing vessel. So it's a lot of work, and we have to be very cautious in what is possible for URN. So this is the vessel we had a pleasure to visit and measure. It's a vessel called Enchanted Princess that was operating in the coast in Canada, on the east coast of Canada. And it's a 333 vessel, 333 meters vessel with a draft approximately 8.3, diesel electric and 5.67 diameter propeller. There are 4 Wärtsilä engines that are generating the power, that is driving the motors on the standard propeller shaft. And they had installed an ALS system, which is activated the moment that there is some energy saving. That is a very important topic that I'll go through. After the discussions, what we agreed is to go for what we call the underwater noise limited curve at a transit speed of 15 knots. The system of Silverstream, you probably have heard this slide. This is basically the system that injects air from air compressors into the air and generates some kind of boundary layer below the hull through some air release units. As I said before, we at Lloyd's, we believe that this has to do related to particular operating speed. Ships that are using bow thruster, for instance, very frequent or infrequently, would have to be considered differently. So in a way, our notation refers to the X distance there. It follows which curve you're following, transit, quiet, research, or stationary, and then indicates the speed at what the data was taking. So we actually link it to a particular condition. And vessels may consider multiple notations as we do it, depending on what is possible. So the measurement campaign was set up in a way such that it was done, as I said, in the East Coast in Halifax in October 2024. We had a standard hydrophone array being hanging out offshore, and what we call the R method, which is close to what it is in ISO 17208-3. And in order to avoid the vessel to return, we obviously took measurements as well in the hydrophone array that is just as you enter into Halifax Port, which is owned by the Defense, the Royal Defense in Canada. This is a different setup, but it's a setup that we've been working for many years, so we definitely understand the reflections on the seabed and how it's behaving, or what it's behaving. So the vessel, in principle, came in and came out without being stopped, and we got the data what we wanted. That's basically what it is. We have a vessel full of passengers that cannot be waiting for you to take your URN data. Data was taken with both ALS on and off, which was part of the targets. And obviously, as I said, we know the characteristics. These are the results on decidated octave bands. What you see in the blue curves is our reference curves. The gray one is with ALS off, and the orange is with ALS on. So what you see is a significant difference, which is beyond what we were expecting in this particular ship. There's corrections, obviously, at low frequencies because we're talking about some shallow waters that we've implemented, where we're certainly happy. And remember, this is decidated band, so we're not seeing here what is happening at the peaks. But we normally would expect is that this boundary layer of bubbles are just simply mitigating the whole radiation. But when we looked at on the narrowband spectrum, we actually were impressed on some of the blade pass frequency that were actually also somehow shadowed or reduced. So our interpretation is that there exists some interaction with the cavitation that may be causing some improvement. But what you can see is the significant improvement in what was achieved. I took this data for you to compare. This is actually not our data, but it's from the ECHO program, and I just took the mean value, MSL, so monopole source levels for the mean value at 15 knots. And that's interesting to see that, you know, and I would just raise a question to everyone. Why do you think the cruise is actually much lower below 150 hertz? So is this to do with POTS? Is this to do with the amount of work the cruise industry put to control, obviously, noise inside so passengers have a pleasant time on board? I think there are several things that add on here. Obviously, they are gensets that are mounted on AVMs, as opposed to what you see in a two-stroke standard carrier. So there are a number of other things there, but I mean this is very interesting. Another point is the high-frequency peak coming up there, which may have to do with anti-fouling systems or high-frequency ultrasonics that are actually being used much more in the cruise industry, and they actually are affecting some mammals out there. So yeah, if I took that data that we measured and presented against the 10%, 10% percentile, 50% percentile, and 90%, so the achievement of this went into more or less going from 50 to around 10%, meaning that Enchanted, the moment that is running with ALS on, you're within the 10% range of vessels, the lowest in terms of radiation. So for my conclusions, we achieved significant reduction. The vessel achieved what we call a quiet notation, that is at 15 knots. And actually is the largest cruise ship that we have currently in books. This vessel, it's very important to indicate the ALS on is only on the moment that you have savings, you have net savings. If for some reason you have to reduce the speed, then you're actually not going to turn it on, and then you're actually generating more noise. So if you look at the slowdown areas in the west part of America, just to give an example, you impose on a slowdown area, this vessel is pushed to go slower, and they generate more noise. It's just another example of, in our opinion, the fact that we slow down, we generate lower levels in a certain area as an average, but actually the vessel stays longer within the space, and it may generate more noise. Yeah, ALS is installed to save energy and may not be applicable to all ships due to financial return on investment and assessment. And obviously, we are in the baseline phase, and if you take this example of Enchanted being having 5 sister vessels, and the fleet handled by this reaching the 20 vessels, and we do this exercise, will take us about 10 years more to get data. So we are actually pushed to do something different than just doing measurements and calculations. Measurements are expensive. Calculations are also expensive. So if we really want an uptake of this to the right level, we need to take alternative options. There's some further work ongoing. Obviously, we want to understand what else we have to do with ALS. So, you know, the bubble size, air volumes, propulsion type, ship draw, and things that we're basically exploring to see what can be done. So currently it's LNGs and cruise ships that are the ones using the most of this system. And obviously, as I said before, we need to find an alternative if we really want to understand what's going on. Yes, that's basically it. Thank you.
Thank you very much, Daniel. And our final presentation for this group is Ben from Noise Control Engineering. Over to you.
Thank you. Hi, I'm Ben. We're going to be talking about some URN measurements that we've taken from electric fast charge tugs, and some other work that we've done for the US Maritime Administration's META program. So the background for this study was we had the potential to understand any URN benefits from battery electric compared to diesel propulsion vessels under various operating conditions. I wanted to identify what those causes of the URN were and any potential mitigation strategies. So the study that we did, we looked at 3 different tugs, all owned and operated by Crowley. The first vessel was the E-Wolf, which was Z-drive and battery electric. The E-Wolf goal was to reduce the use of 350,000 gallons of gas in its first 10 years, comparatively. The next vessel was the Tioga, which was also Z-drives, but had hard-mounted diesel engines, and then the Leader, which had void propulsion units and also had hard-mounted diesel engines. We performed this test in the San Diego Harbor. This was done to minimize disruptions. The depth was only 46 feet, so it was shallow water measurements, and we placed a hydrophone on the bottom of the channel. So for our test methodology, we wanted to assess 2 different conditions. The first one being transit. So we had the tugs transit at 2, 6, 4, 8, and 10 knots as they would go over, and the measurement window that we used was plus minus 30 degrees as they were going over. The next one that we wanted to look at was a simulated tug assist. So they pulled a rope that was attached to the shore, and we tried to line up the vessel as best it could so that the propellers were over the hydrophone. And we looked at this at 20, 40, 60, 80, and 100% power. From this, we calculated acoustic source levels, and we made them to equivalent 1 meter URN using ANSI S1264. So to first look at what the overall levels were between the 3 different vessels. So during the transit condition, the E-Wolf had the lowest overall at all speeds. So at least 6 dB lower. The Tioga and the Leader had very similar noise levels for all their conditions. During the simulated tug assist, and the bottom axis is thrust, not power, the E-Wolf also had the lowest noise at all of the thrust conditions. Was that, again, 6 dB lower than most. The Tioga, which is the Z-drives and hard-mounted engines, also had similar noise trends to the E-Wolf, but the Leader, even though it was the loudest, except at the full power condition. So now to look at what the actual noise sources were and what was driving those overall levels. So we see during the transit conditions, the E-Wolf, the noise rises with increasing speed, going from 2 to 10 knots. And we see that the rise in noise is greatest at the higher frequencies. The Tioga, which is again the hard-mounted Z-drive, it also had noise rising with increasing speed, but the rise occurred at pretty much all frequencies, both the low to mid and high frequencies. The Leader, it also had noise rises with increasing speed. However, the rise at high frequency was much less significant compared to the other levels. So then if we look at the narrow band and try to pick out what was driving these increases, we see that what was driving the noise for the E-Wolf was a lot of propeller cavitation and broadband noise. We are able to pick out Z-drive and some gear mesh tones and also some motor tones. For the Tioga, we see that the engine noise is very prominent in that kind of mid-frequency range. We also see that the propeller cavitation is also driving that high-frequency noise. For the Leader, even though it had the hard-mounted diesel engines in the 4th unit, the engine noise is actually the dominant noise source. And while cavitation is present, it was much less significant compared to the other vessels. So from the kind of some of these key takeaways from these measurements was that the E-Wolf had reduced overall noise levels. It had reduced machinery noise compared to the Tioga and the Leader. However, it still had significant cavitation noise, and you can see that on the plot on the right there. The E-Wolf did have lower cavitation noise compared to the Tioga. They both had Z drives. This E-Wolf had a larger diameter and a slower rotation rate, and this tends to reduce cavitation and yield a lower noise. And also in this case, the hard-mounted engines are dominating the overall noise spectrum, and during the simulated tug assist, those noise levels are kind of dominated by propeller cavitation. We also noticed that the Voith units can change the cavitation behavior, in this case significantly reducing the cavitation noise. So while none of these vessels were specifically designed to meet any underwater noise criteria, we wanted to compare how the, during transit conditions and during simulated tug assist, how they compare to an underwater noise standard. So for the transit condition, we compare them to the ABS UWN transit. All of the vessels are very close to the criterion, and the leader, which is the Voith unit with the hard-mounted diesel engines, actually met the limit, even though it was had the loudest overall level. The E-Wolf, which is the battery electric, had a excess due to cavitation at higher frequencies. So based on the measurements that we had taken, it was relatively easy for these vessels, whether through minor adaptations in their design, that they can achieve this ABS URN notation. Part of the reason for that is that during transit conditions, they're operating well below the kind of 85% MCR condition. And so that's why, when we go look at the simulated tug assist, we see very clear excesses compared to the ABS URN transit. The Tioga has clear excesses from the propulsion engine and the propeller cavitation. We see the E-Wolf's propeller cavitation increase quite a lot, and whereas for the leader actually does not have any real cavitation excesses, and many of them are driven by the engine noise. So based on these tug measurements, the URN from these tugs is a combination of cavitation and machinery noise, and this is very common against all commercial vessels. Tugs are quite unique in this sense because, they have a potential prominence for machinery noise compared to just dominating at cavitation noise. And the battery technology that was used can reduce the tug overall level and URN. However, conventional noise control approaches can still reduce some of those noise levels. So if they were resiliently mounted rather than hard-mounted diesel engines, some of those engine noise would have been lower. And then, sorry. You can also design the propellers for having reduced cavitation and mitigating some of that higher frequency noise. And in this case, what we found was that the Voith units and Zikloader propulsion had significantly reduced noise levels comparatively to the Z drives. We are doing a similar study for the META program, and this will take place with Ferries, and it's currently scheduled for 2026. One of the other things that we worked on for the META program was developing a white paper to look at both underwater noise and energy efficiency, and looking at how technologies can combine together and different design strategies. So, one of the examples based off of this tug study was, does the battery electric propulsion reduce URN? And yes, it does, compared to the machinery noise, but also it does not influence the propeller cavitation. It's not surprising. So to reduce underwater noise is going to be, understanding what the sources are, the paths of the noise, and choosing technologies that are going to be able to mitigate that underwater noise. So again, this has been mentioned a number of times, but taking a holistic approach, looking at the underwater noise at early design stages in vessel design can significantly increase the chances of meeting any underwater noise goals and energy efficiency goals. A number of the technologies that have been presented here and we are discussing have these energy efficiency benefits as well as underwater noise benefits. It is likely that a number of these technologies you'll likely need to use more than one of technologies to meet these goals. And if you want to see more, the link to our white paper is available. So, thank you.
Thank you very much, Ben, and thank you to all the presenters. We have now 20 minutes for questions. So first to the audience, if you have any question, please raise your hand. And yeah, Chanwoo.
Thank you, Eric. I have a question to Daniel about the
Yeah, everyone will have to put headphones on if you want to be able to hear.
didn't work.
Can we remember to state name and affiliation, please? Thank you.
Oh, okay. Yeah, thanks. Yeah, so I'm very interested in the technology of that ultrasonic fouling prevention system because Ferries is also considering using that system to mitigate marine growth. So could you explain a little bit in detail about how it works and where do you put and the noise level general? Thank you.
Yeah, thanks, Chanwoo. I'm not the right person to talk about that. I'm not a manufacturer of that device. I just know that it's meant to operate all the time, and it's also then therefore generating noise, right? It's an ultrasound source that has been well sold out in the market. Many owners are buying it, and it's actually polluting a lot. So, sorry I can't answer your question, but we should get that question to manufacturer of anti-fouling systems.
Thank you. Anyone? Tom?
Can you hear me? Okay. My name is Tom Akamatsu, Osaka University from Tokyo. And I'm the first time to join the IMO meeting, so my question may be stupid. And for the Ricardo and Marie, according to the action plan D, you are targeting for some targeting value. But how we can know the targeting value is my question. Is the targeting value maybe depending on the URN from the individual ship, or maybe noise exposure level of a specific area targeting a specific species. So what kind of effort we want to need to establish the target value? Thank you.
Thank you very much for your question. I must say it's a work in progress. You are invited to join the correspondence group and the expert group that will take place in January next year, but we are currently working on it. It would be complicated to give an answer here, but please first have a look at the EBP framework because it lists all the studies that have been submitted to the IMO since SDC 10, I think. You can find the link in the report, but we can discuss this later.
Yes.
Thank you very much. My name is Dmitry. I am from Siemens. I have one question for two persons in the panel. So I can see Daniel and Eric, so you both representing the classification societies. So it's question to both of you. Daniel, you mentioned that obviously the trials on your vessel will perform according to Lloyd's register rules. So I'm just wondering, because last time it was a discussion to combine those, make like the setup for the water radiated noise measurements be kind of similar across the different class societies. I'm just wondering about the status of this work. So if both of you could comment on that.
Yeah, I can comment. We have an ongoing project team in IX, and a first recommendation has been issued last year. And this recommendation was not 100% finalized because it was waiting for the finalization of the ISO shallow water one, the 17208-3, which has been released in October. So the team has resumed its work since a few days, a few weeks, since the ISO has come out, and we'll integrate this ISO in an update of the recommendation for the next year.
I can comment. Yes, so just supporting what Eric just mentioned, I mean, we obviously are coming with methodologies to do this kind of thing, but in a way we're also being practical in what is possible, right? We definitely know what is the right method to do, but we actually have to find ways how to make this financially viable for everyone. So there's different approaches that we're taking, yet managing the uncertainty and the data.
Thank you very much. It was just a challenge that depending on the class, the setup would be different and it would be very confusing for the owners. But yeah, thank you very much for the clarification.
Reagan?
Hi, Reagan Nelson with NRDC. My question is for Daniel. Daniel, I was really interested in your findings on the air lubrication system, and you noted that the ALS typically comes on at higher speeds, and so there may be implications, right, for vessels operating at lower speeds and perhaps participating in slowdowns. Did you look at, because when a vessel slows down, you typically do see reductions in underwater noise as well as energy efficiency. So I was curious, did you look at comparisons? So for a vessel of that size, slowing down, say, to 10 or 12 knots, right, sort of the typical slowdown speed, would you have a comparative reduction in underwater noise as you would see with the ALS operating?
No, unfortunately, we don't have for different types of vessels. We are in the means of testing that for other applications, but we at this point of time we have nothing to share on this. Sorry for that.
And just a follow-up question. And so on the energy efficiency side, would there be, I don't know that much about ALS, but I guess my assumption is that the ALS kicks on at higher speeds because that's when you need to see an increased efficiency outcome. Is that the case? So do you see you only need the ALS sort of above a speed because that's when you see increases in efficiency, is that correct?
Yeah, so you're bringing air compressors inside for this particular technology, right? You have several technologies out there that are trying to make their systems work for this. But you have an energy consumption for the air compressors that you're bringing into your vessel. And first of all, you obviously have to pay for that. And then the savings that you're actually making have to pay the investment you have. So it's a significant investment for a ship owner to put an ALS system. So in a way, it's applicable to each type of vessel. So we can't continue talking about shipping or commercial shipping. We have to really be specific on what type of shipping, what's the service of this vessel, where does it make sense for this vessel to install ALS or any type of solution.
Thank you, Daniel. If I may add, I seize the opportunity to announce that during the poster session there is a poster on low noiser EC-funded research project, which will include ALS investigations, both model and full scale, and that will be very insightful. Lloyd and BV are involved as well, and other people in the room that you will be able to discuss with about this particular solution.
Thanks. David Williams, FedNav in Canada. I have a question for Daniel. You showed a graph comparing underwater radiated noise for different ship types, and you baselined them by scaling, all at the same speed of 15 knots. I'm struggling to understand the background behind that, because there is no bulk carrier with EDI and EXI that does transit anywhere at 15 knots.
Yeah.
So why would you choose a specific speed when many of the IMO metrics talk about transport work or some other alternative? Why try and compare ships at the same speed when those ships never operate at the same speed in reality?
Yeah, that's the right point. Well, this is a piece of work that is published in many locations, ECHO program that have gathered data in Canada for many years, right? So the only thing that I did is there's this JASCO papers on what they've published on this, into how do you scale this according to speed drop and size of the vessel. So my only target on that was to, you basically have some equations that determine how this curve flips up and down based on the statistical distribution of this data. So obviously for bulker, you don't see a bulker at 15, but I wanted to compare just to see where I was for, as opposed to cruise ship going at that speed. Not sure if I answer your question. Probably it's not applicable, right? But it probably is for container ships, LNGs, and so on.
Yeah, I mean, it doesn't seem very applicable. And on the scaling issue, so it's a statistical scaling as a result of a JASCO study.
Yes. So there's several locations in Canada that have been measured for more than 5 years. So all the ships, and they don't distinguish if it's a vessel of the different kinds of propulsion. It's just all are booked into. These are the boxes that you have for bulkers, vehicle carriers, and so on.
It is statistical scaling on a very complex naval architectural and noise and vibration matter. Is statistical scaling appropriate and internationally accepted, especially when taking vessels to speeds which they don't actually operate at?
Well, it depends on what is it you're using for. We're not going to measure all the vessels. The European Union has also been statistically assessing the noise in the continent, because each vessel has got a lot of details, and obviously we working the design of ships, we don't definitely understand that's the case, but there isn't any other way how to easily compare unless you measure it, which comes with a bill along. So it's a trade-off in a way. We have to do something that serves at least the purpose in a way.
Thank you. Yes, please.
Hi, Kenneth Svan from Maersk, Copenhagen. Question and comment to Daniel. Thank you for highlighting some of the challenges in this respect, also now with comparison data across vessels and vessel types. So it's reflecting very much the complications in all this. I had a comment to the different curves and the noise. Maybe some of the reasons could be the difference in size of the vessels. Larger vessels have more power installed and thereby also more noise probably. So maybe that is reflected. Also the configuration, the propulsion, the propeller design and the main engine design configuration can play a role in this when comparing this. I wanted to ask one question. You compare the noise, but having the ALS on, did you also see and monitor some impacts on the energy side, not only on the URN reduction, but do you know? Do you have any experience whether the air bubbles from the air curtain actually could have a negative impact on the inflow to the propeller, and thereby the efficiency of the propeller, meanwhile reducing the noise? So again, the benefits, potential benefits or not?
Yeah.
Thanks.
Thanks, Kenneth. No, actually, I don't have much information on that. There's some people in the room that can certainly have. Obviously, we're looking at the noise aspects, but on the energy efficiency side, I don't have any information as such. Right now, the system in the ship is just, it goes on the moment that you reach 15 knots. That's basically it. If you are 14, it's off. So we can have a chat later on that.
Yeah, but just if I may intervene, the core purpose, the first purpose of ALS, as you know, is to reduce the drag and for a same speed to have less power. So for sure, it's aiming first at reducing the drag and so improving the efficiency. And then co-benefits are full scale evaluated, which was not even the case 2 years ago. So appreciate that. Chris?
Thank you, Chair, and many thanks to IMO for this workshop and for the excellent presentations. And full marks to Lloyd's. Really useful data on the ALS. That's the first hard trials data we've seen for the URN performance of air lubrication. And from the graph you presented, it seems to me that you got more or less a consistent 10 decibel reduction in URN from low frequency up to high frequency, and that's great. Another point I'd like to make, and this refers to Roel's presentation and Marie-Lucie's, where you were referring to the great synergy between energy efficiency and underwater radiated noise, and we recognise that, and we understand it's a great opportunity to get URN reduction off the back of energy efficiency. But we can see another synergy on the horizon now, another regulatory synergy, and I refer to one of the outcomes of MEPC 83, which committed to initiating the development of a legally binding framework on biofouling. So what that is likely to do is to maintain cleaner ship's hulls, smoother ship's hulls, which will need less power to drive them through the water. So the pressure differential across the propellers will reduce slightly. So the cavitation will reduce slightly. So the URN will reduce slightly. I think it'll be relatively small in terms of benefit relative to the URN benefit we get from the energy efficiency drive, but it'll be tangible. You know, it's something. So I think we should recognize that as well. Thank you.
Yeah, thanks for that, Chris. And just to jump in on that, you know, and I think it's been said a couple of times, I think Ben or Daniel mentioned it, that, you know, there's no one size fits all, and it's a number, I think, looking at different measures that can actually help reduce the noise, and hull cleaning is one that is identified in the revised guidelines, and kind of proper maintenance, regular maintenance to ensure, kind of to address that, and it does have the co-benefit with biofouling as well. And I think that's where, and again, this has kind of come up both in the 2023 workshop as well as I think today, is that holistic approach of, you know, we have an opportunity to actually address these things as a whole, looking at the energy efficiency, reduced GHG, reduced underwater noise, biofouling, and looking at the entire environmental footprint of the ship as we're kind of taking advantage of these opportunities. So, very good point. Yep, absolutely.
Sorry to interrupt you, Michelle, but maybe just in response to the comment by ICS, because it's a very important one, and I think we'll be coming back on biofouling later in the workshop. But just, and I didn't mention that in the presentation because I focused primarily on MARPA Annex 6, but you're correct, and maybe for everyone in the room as well, as a reminder that the upcoming session of the PPR, so the Subcommittee on Pollution Prevention and Response that will take place in February, has this topic on its agenda. And so we are actually very much looking forward to any proposals, concrete proposals from member states, international organizations to the PPR on the development of these guidelines, or the actual title on the agenda is the development of a legally binding framework. So we're looking forward to that.
Fabulous. Thank you. And that brings us right to coffee break. That was like perfect timing. I did want to quickly jump back on the comment about targets, though. This has been a question. This is your first meeting. It's a question that always comes up, is, you know, how quiet are we trying to make it? And I think, you know, at the very first 2019 workshop that we had on underwater noise overall, there was a recognition that, you know, they're coming up with one biologically relevant target is difficult depending on the species and, you know, the environment in which we're operating. But I think there was this general recognition of, you know, at least embracing for the time being the Okeanos targets around 3 dB over 10 years and 10 dB over 30 years was kind of that general frame. But also a recognition that every vessel, it's not going to be a one-size-fits-all again. You know, different vessel classes have different ranges within which we can be looking, and that will get a little bit at some of the work that we've been doing in Canada on underwater noise management planning that you'll hear from Aurélie tomorrow. So, just it's an ongoing conversation, but I think there's a recognition of looking at the source noise and where we can find those reductions across different vessel classes. So, more work to come for sure. But so with that, enjoy coffee, sponsored kindly by our Glow Noise partnership. Is it just outside here, or is it downstairs?
No, the Delegates Lounge on the first floor.
Fabulous. So Delegates Lounge on the first floor, 11 to 11:30. So back here at 11:30. Thank you. Thank you.
Seen with the mic.
So let's start again, the second session. Very pleased to welcome on the stage Professor Giorgio Tani, Ms. Jessica Morton, Associate Professor Masahiro Sakai, and Mr. Chanwoo Bae. And we will start first with Giorgio Tani from UNIJ in Genoa, presenting a propeller design by optimization. Giorgio, the floor is yours.
So thank you, Eric, for the introduction. So I will speak about design of by optimization to find an optimal trade-off between efficiency and noise, since in many cases these two targets are conflictual. So shortly, what is design by optimization? It's a procedure requiring a reference case in order to initialize the procedure. Then you need a parametric description of the geometry in order to generate many geometries modifying these parameters. You need an assessment of the quantities of interest, and we use a boundary element method for that, since it is fast and reliable. And then, of course, you have your design constraints to be verified, and the geometries satisfying these constraints can be used to generate new better geometries in a further iteration. It is an iterative procedure. At some point, you should find convergence, and you have a set of optimal propellers among which you can search the one that you prefer. Usually, at that point, we use higher fidelities method like CFD to assess the performances of the geometries that we identified as the best ones. So in this presentation, I will show the application of this procedure to two test cases. The first one comes from the project Piaco and is a small ferry boat. It was already shown 2 years ago. So quickly, the design goals for this boat was the reduction of URN for all the functioning conditions of the vessel, keeping constant the efficiency, which means not reducing it, if possible. And then we had to shift the functioning shaft rate of the propeller to better match with the characteristics of the engine. And shortly on the results, here we see the results of sea trials. In terms of power requirements, the two propellers were equivalent, so okay with the constant efficiency, and the shift in shaft rate was achieved as required. Moving shortly to noise, these are results. The red line was the ship equipped with the original propeller. The black one is the optimized one, so it's a retrofit scenario. And we see that we had a consistent reduction of noise on most of the frequency, especially in the medium frequency case. So the next case, more challenging one, will be a cruise ship. But before presenting it, my colleague Marino will introduce the practice of Fincantieri to design silent ships.
Thank you, Giorgio. So I will just briefly describe the procedure we adopt at Fincantieri in order to design efficient and silent ships and propellers. So with our main aim being maintaining a high efficiency in order to reduce as far as possible CO2 emissions, while keeping also the noise emissions as low as possible. In order to achieve these, we have internal procedures, of course, and I will just summarize the key points we follow. So first of all, we have to optimize the hull shape in order to have a favorable wake at the propeller disc. And the key point here, so maybe the first one we try to start from, is to place the center of buoyancy as far as possible forward. Then we have to choose an appropriate number of propeller blades. We found that 6 for cruise vessels is a good compromise, because this allows to unload the blades and have a better load distribution. And at that point, of course, we have to properly design those blades with a proper pitch and camber distribution in order to achieve the scope of having a cavitation distribution which is as tiny as possible, and we try to reduce it to only tip vortex cavitation. You can see here an example of one of our propellers during model test, and in this case we actually achieved the aim of having of almost deleting even the tip vortex cavitation, which is a good result, I would say, at model tests. Together with that, we have our CFD procedure that lets us predict the performance of the propeller in a behind hull condition, and we compare that to the regulatory requirements. And here we have the examples of 2 classification societies, and for your reference, also the emission levels expected for a research vessel, so a very quiet one. And here are the results of both our tank tests and numerical predictions for a specific ship, which actually match very well not just cruise ships, but actually research vessels. And those results were basically met by the sea trial measurements on the very same ship. And thank you very much, Giorgio. Back to you.
Then in the second propeller that was optimized in the framework of... Second test case was optimized in the framework of a next generation Europe project. The ship is a cruise ship, and the targets were postponing tip vortex cavitation, increasing the margin against other cavitation typologies, keeping constant efficiency as in the previous case, and reducing the underwater radiated noise. This is an example of the outcome of the optimization. Look especially to the left plot. You may see there different geometries and their efficiency on the horizontal axis against the strength of tip vortex, which is an indirect measurement of noise. The red dot was the reference propeller, the starting case, while the black circle is the one that we selected for the further analysis. But as you can see, there were also other alternatives that one could investigate and verify. So we did model tests shortly that the open water performances were equivalent, so same efficiency at transit and silent speed. For what concerns cavitation, we did the model test, and we found that the inception of tip vortex was postponed of approximately 1 knot, which is quite a good result because it means that your cavitation inception speed of the ship is increased of 1 knot. It's quite important for silent ships. Note that for all model test activities, we had to take into account of scale effects on tip vortex, since this phenomenon is always quite challenging from that point of view. Here you may see the model scale cavitation. On the right side, you have the original propeller, the reference one. On the left side, you have instead the optimized one. For the silent speed, the optimized one has no cavitation. Here instead is transit speed, and we see that both propellers cavitate, but the optimized one shows a very tiny tip vortex, just in correspondence of inception, while a developed tip vortex was present for the other propeller. So finally, let's come to noise. Here we have results for 2 velocities. These are model tests, scaled to full scale. These are not sea trials, of course. The blue line is the reference propeller. The red one is the optimized one. And we have to look only to the solid lines, that is, the frequencies for which the signal-to-noise ratio was sufficient. Along with the levels of noise, we have also the uncertainty bands estimated on repeated measurements. So this is okay for estimating the random error, not the bias error. This is important. But for comparing 2 geometries, the random error is more important. So what we can see is that for the silent speed, we have a consistent reduction of noise of about 10 decibel, but probably even more because there are ranges for which the optimized propeller was simply not captured, not perceived in our facilities. And then for the transit speed, it is less easy to conclude because levels seem similar on a wide range of frequencies, but these measurements were more likely influenced by measurement issues which are a bit long to explain. So in case I will further clarify this, but let's say there were background noise issues and also some water quality issues. If we look to the low frequency, however, we can see quite a reduction of noise also in this case. And these frequencies are quite important because here we find the typical hump due to tip vortex cavitation. So the reduction of those frequencies is quite an evidence of the reduction of tip vortex. So coming to the conclusion, these two propellers were designed for very different applications by the design by optimization techniques, and these results demonstrate, at least for these two cases, that this procedure allows to obtain a significant reduction of radiated noise while keeping a good efficiency, constant efficiency, possibly even improved. Then we observed some differences between the two test cases. One case was an in-service ship, the other one was a new building. So for the in-service ship, one of the main difficulty was obtaining data because quite often for in-service vessels, you may speak with a ship owner, which has not the complete design data as a shipyard. So that can be a problem for setting the design procedure. The core of the procedure itself doesn't change in that case. For a new building, you have instead the advantage of possibly exploiting an holistic design of the ship, so optimizing the hull and propeller together, as an example, by using the procedure and the practices explained by my colleague. In terms of type of ships, we have effects as well, because for the small ferry boat, the most challenging aspect was the largely variable loading condition of the vessel, because any run is with a different displacement, a different trim, and so you need to optimize the propeller in order to widen the limits against cavitation for different operational conditions. While for the cruise ship, the most challenging aspect was the reference point, because it was a propeller designed for already very low cavitation and low noise. So the result obtained further stressed the power of this kind of design methods, since we were able to improve a very good propeller. Finally, a comment about costs. Costs of design are limited compared to typical costs for the building or the operation of a ship. This makes the adoption of this kind of procedure feasible, especially for retrofit, because it's not a huge cost to start for this kind of redesign of the propeller. And from that point of view, the optimization approach has the advantage of allowing you to maintain the layout of the vessel. You don't need to completely change the propulsion system of the ship. You can just focus on the propeller, and if cavitation noise is the largest contribution on the acoustic signature of the ship, that approach is still quite effective. Of course, also for new buildings, using this kind of procedure within the design of the hull and propeller does not change that much the cost. So it's something that can be reasonably done. Just one comment. In this work, we presented examples of application of the design by optimization procedure to conventional propellers. But, of course, you can apply it also to unconventional propellers. And this is something that we did in the past. There is literature on this. So you may apply this also to solutions with energy-saving devices or propellers suitably designed to postpone cavitation, like ducted propellers, etc. And in general, these allow you to further move close to the optimum that you can achieve with that design solution. So thank you for your attention.
Thank you very much to both of you. I have the pleasure now to welcome Ms. Jessica Martin to present to us a collaborative partnership which is protecting blue whales and blue skies. Jessica, over to you.
Thank you. I'm Jess Morton. I'm with the California Marine Sanctuary Foundation, and I'm going to switch gears a little bit and share some findings and lessons learned from a case study that we've been implementing for the last 10 years off of the California coast called the Protecting Blue Whales and Blue Skies program. And so first, very short overview of what it is. It's a voluntary vessel speed reduction, verification, and public recognition-based incentive program. So I'm going to focus more on the incentives for this talk. And our goals are to reduce ship strike risk to whales, reduce underwater noise, and also reduce emissions, both greenhouse gas emissions and then also air pollutants for coastal communities in California. Oh, thank you. And so to give you some context first on why we do this in California. Many of you may know on the issue of ship strikes that where shipping traffic overlaps with where migratory whales travel, there is often the unfortunate case of collisions, which can result in fatalities to these whale populations, whale species, but also can cause injuries to humans too. And on the west coast of the United States, it's estimated that 80 endangered whales are hit and killed each year by ships. And then, as I mentioned, we also focus on air emissions. That's the other motivating factor for why we implement this program off of California. We work really closely with some of the county air district agencies in California to implement these vessel speed reduction measures because we're committed to reducing greenhouse gas emissions, but also NOx emissions. In California, across the state, as you'll see on the slide, over 20% of the NOx emissions in California come from ocean-going vessel traffic. And in some areas like Santa Barbara County, it's actually over 50%, which can have adverse impacts to our coastal communities. And then also finally on the noise front, we know that shipping traffic obviously also introduces underwater noise, which can have adverse impacts on sound-sensitive species and also ecosystems off of the California coast. And so how do we do this? Well, I'll take you through it. It's basically a three-step process where we first do a lot of work to pull the AIS data from all the vessels traveling in these areas that you'll see in green on the map on the screen. And we verify the cooperation levels of every vessel that passes through. We also verify the performance of every shipping line, so we aggregate that vessel data up to each fleet for the shipping operators that choose to participate in this program. And then we report to them very regularly. We report to them on a monthly basis so that they can adjust as needed, improve performance, and then at the end of the season, they get a report card that looks similar to what you see on the right that lets them know if their performance qualifies them for an award level in this program. And so the second step that's also really important is we spend a lot of time not just verifying their performance levels, but also what the environmental benefits of these slowdowns have amounted to. And I'll go into more detail on this in a bit, but we look at the ship strike risk reduction, we look at the underwater noise reduction, and we look at the emission reduction levels. And then the incentive angle that I noted is positive recognition. It's public recognition to actually give credit to the vessel operators who choose to perform at a high level and achieve those award levels that I mentioned. And I'll note years ago in this program when we first started out, we used financial incentives. We obtained grant funds to actually give out small awards, financial awards to vessel operators to incentivize them to slow down in these areas. And then we learned along the way from the shipping lines that the positive press and recognition was much more meaningful. And so that's what we shifted to doing several years ago and haven't looked back since. And then one other note in terms of providing recognition is relatively recently we also incorporated an element called the Ambassador Program in this effort, where we also work to engage the companies that work with the shipping lines. And in a lot of cases, it's the cargo-owning customers of these shipping lines to make them aware of how these shipping lines are performing, get their help in providing recognition, and also getting their help in encouraging more vessel operators to prioritize participating in this effort. And so now to share how successful it's been, I'm happy to say that in the 10 years I've been working on this program, every year we see more engagement and more involvement from the shipping industry on this program. And so in 2014, it really was an experiment to see if something like this could work off of California in just a small geographic area. 7 shipping lines in Southern California reduced 30 transits. In 2024, if you fast forward, we had 49 of the global shipping lines, most of the container and car carrier operators that come to our California ports. Together, they reduced speeds for over 425,000 nautical miles in our expanded zones that now exist off of San Francisco, Monterey, and Southern California. And then in terms of the results on the environmental benefits side, we work closely with partners at the University of Washington and also Point Blue Conservation Science, and we estimate the reduction in risk associated with that change in speed. And so you'll see on the screen that in 2024, we estimated that participating vessels posed a 50% lower ship strike risk to whales than non-participating vessels. And then in terms of air emission benefits, we similarly work with great folks at Starcrest Consulting. Dr. Lee Keinberg is in the room today, and we estimate the air emission reduction benefits of these speed reductions in the area. And with our partners, we estimated that there was a reduction in NOx of over 1,400 tons, reduction in SOx of over 33 tons, a reduction in diesel particulate matter of 8.4 tons, and then a reduction in regional greenhouse gas emissions of almost 50,000 metric tons. And this is all for the 2024 season alone. And then finally, on underwater noise, we partner with Dr. Vanessa Zobel at the Scripps Institution of Oceanography to measure and estimate the source level and noise level changes associated with these speed reductions. And in the 2024 season, you'll see across the participating transits that we have in this program, our mean URN levels were reduced by 5.4 decibels, 4.6 decibels, and 2.3 decibels in each region, for a statewide average of 4.1 decibels, equating to a 38% reduction in sound pressure. And so I'll end by focusing on some of the main takeaways of 10 years of implementing this effort. And some of the main things I want to highlight is that we have learned that this program format works and it continues to work. As I noted, we have expanded the zones geographically. We've actually made it more challenging to achieve the top award tiers for the shipping lines that participate, and every year they have risen to the occasion. They have stepped up and enrolled in higher numbers and reduced speeds for more of their distance. The second thing I'll highlight is that the environmental benefits analyses really prove that these very simple operational changes are resulting in meaningful reductions when it comes to URN emissions and ship strike risk. And then one of the main things I want to highlight is that this positive recognition as an incentive for these shipping lines really works. It's proving that it's a very powerful motivator for behavior change across the shipping industry. And then I think a lot of that is attributed to the fact that shipping lines are more eager than ever to demonstrate commitments to sustainability and to biodiversity protection. I can say 10 years ago when I looked at the sustainability reports for these shipping lines, I very rarely saw any mention of biodiversity protection, and every year more and more I see that change. And then lastly, I'll note that this program model is very flexible and scalable to new regions. Unlike regulations, as we all know, regulations take a while to implement typically. These are voluntary measures that can be implemented quickly on more dynamic timescales with dynamic environmental problems. And so we do see a lot of potential for this type of program to expand to other areas. And so I'll wrap up there, but I guess I'll leave one more takeaway as somebody representing whale conservation issues in the room, that as agencies like the IMO seek to address impacts associated with underwater noise and emissions associated with shipping, I really urge everyone to consider the opportunity that exists here to also address biodiversity impacts like ship strikes through very simple operational measures like slow steaming and vessel speed reduction. So thank you so much.
Thanks a lot, Jessica. Now I'd like to welcome Associate Professor Masahiro Sakai.
Thank you, Eric. Good afternoon, everyone. My name is Masahiro Sakai from the University of Osaka, Japan. Today, I'm pleased to make a presentation entitled Towards Win-Win Solutions for Harmonizing URN Reduction and Energy Efficiency in Marine Spatial Temporal Planning. And the key idea of our concept is spatial temporal planning and some operational control. Okay, to harmonize URN reduction and energy efficiency, we believe that regional operation control is the most immediate and efficient way. And in this concept, the ship can adapt some operational decision and depending on the location or time or season. Okay, and in this figure shows the ship is transiting the sensitive area under slow steaming operation to reduce the impact of the URN to the marine life. Okay, so here the important point is how we can define this kind of a sensitive area. And another point is what exactly is the sensitive area. Okay, and here I can demonstrate how do I say kind of an idea how to determine the sensitive area. Okay, and the left figure is a map of around Japan, and I choose the red hatched area to demonstration. And the right figure is, of course, a noise map, as it looks like, and but it's not a conventional one. And and this is a noise map with using anthropogenic noise and the auditory characteristics of marine species. So then we can say this noise map is biologically weighted. And overlay the habitat map of marine species, then we can distinguish the sensitive areas. And in this result, honestly speaking, the noise level is not so high. So then in all position, the noise level was less than the threshold. But so I mean that this noise map just states that there's no need to make some countermeasure. But if you have some overlapping with a very noisy area and the habitat, then we need to do something in that place. Okay, so this is our idea how to distinguish the sensitive area. Okay, let me move on to the more concrete explanation. And firstly, I will emphasize the importance of the ambient noise. And after that, I move on to some characteristics of shipping noise. And after that, I will make some explanation on the biological side. And finally, I will show some efficiency of the slow steaming. Okay, let me begin with the ambient noise. Okay, ambient noise defines how far sound can be heard. Okay, please look at the right figure. This is simple view of the transmission of the anthropogenic noise, and basically the anthropogenic noise decreases with distance. Okay, and at a certain distance, the received level of the anthropogenic noise becomes lower than the ambient noise level. Okay, so beyond this distance, the anthropogenic noise has no effect. Okay, so then this is reason why the ambient noise level is the most very important. And sorry. And but another question is, does ambient noise stay constant? And the answer is no. It changes with season, time, or regions. Okay, and this is this spectrum shows the example of an underwater monitoring record of Yuri Honjo, Akita, Japan. And this is a spectrum for almost 2 weeks and in summer. And here at this time, the ambient noise was relatively calm, except for the fish chorus. But at the same point, we had monitoring in winter. Then we can clearly see the very large low-frequency noise in the winter season. Okay, so then this kind of variation in ambient noise causes this kind of variation of audible range. Okay, so this is a point, and we need to care this kind of variation in ambient noise with time, season, and regions. Okay, let's move on to the shipping noise. Unlike chemical substances, underwater noise does not persist in the environment. Okay, this is an important point. So it vanishes as soon as possible. The source is turned off. So what I like to say is, we can manage the underwater related noise with, how do I say, if we control it efficiently. So let me skip these slides. And the next topic is the biological side. Okay, so according to NOR's technical guidance, for this kind of problem, we can use TTS, temporary threshold shift, as a threshold of the noise effect or noise impact. Okay, and here we need to use SCL24H, and this is the average of sound exposure level in 1 day. And in that case, the important point is the received level is weighted based on the auditory characteristics of marine life. And as I mentioned before, this sound map is not the same as the conventional one. And this is the visualized map of SCL24H. Of course, that is biologically weighted. And again, I need to say that we need to superpose the habitat map on this map. Then we can distinguish where is the sensitive area or where I need to do something to reduce underwater noise. Okay, so finally, I'll move to the slow steaming. We made a case study based on the calculation, and so maybe okay. So the result is already published in the SDC9 information paper 11 by the IMO in 2022. So if you have more interested in this result, please read that information paper or make a discussion with us later. And I will shortly explain about the result. And the result, so our case study was like, we compared the efficiency and with using some strategies. And one is course one, transiting a sensitive area with slow steaming operation. And another is detouring around the sensitive area while keeping its ship speed. And our scenario is we need to reduce the 5 decibel of underwater noise in the sensitive area. And in our case study, the sensitive area was set a kind of circle zone with a diameter of some 1,000 kilometers. Okay, and this is a result, and okay, I need a hurry up, okay. And please look at the upper figure, upper table. The first line is our reference design. And in this case, the efficiency is optimized and optimized. And in this case, we need 3 knots of slow steaming to reduce the 5 decibel underwater noise. Okay, and that should be compared with the third line. Third line is designed with more with larger blade area. So that means we just reduce the underwater noise by design, a propeller design alone. Okay, so then the efficiency decrease. Of course, decreases, as you know. It's just a trade-off. Okay, as a result of our scenario, the delta FOC is the increase in the GHG emission. And if you use some kind of a bad propeller, we can, of course, we can reduce the noise, but the GHG emission increases like 7% or 8%. This is a strong, this important point. So let me conclude with take-home messages. The first is a management principle. Ambient noise varies with season, time, and regions. So this is then the management should be spatial temporal. This is our message, our first message. And the second is the key information needed to create this kind of spatial temporal one. Ambient noise, anthropogenic noise map, of course, should be weighted biologically, and the exposure level and habitat distribution should be needed. And the final is we need to care the trade-off. Okay, and it's time to finish. Okay, so thank you for listening, and please feel free to have a contact with us. Thank you.
Thank you, Mr. Sakai. Now, please welcome Mr. Chanwoo Bae from BC Ferries, who will share with us a full-scale case study.
Hello, everybody. This is Chanwoo Bae, working at BC Ferry. Today, I would like to show the example of BC Ferry's effort toward a quieter fleet. And there are several outlines, but I would like to emphasize there are 3 main points in this presentation. The first one is that underwater noise measurement plan is being underdeveloped right now, so I would like to show how it works. And the second one is the island class measurement, real URN measurement data. And the last one is the benefit of VFD, variable frequency drive technology, on the double-ended ferries, and then the conclusions. And about the BC Ferries, we operate about 37 vessels in the West Coast Canada, connecting the mainland with Vancouver Island, and about 25 routes. And last year, the BC Ferry carries 22.6 million passengers and 9.6 million vehicles. So Canada population is just over 41 million, so you can imagine the capacity of this business. So right now, that while we are operating ferries, we faced very big 2 hurdles, environmental hurdles, which is the CO2 emission and also reduction of the underwater radio noise. And would like to show how we treat them. And especially that URN is the very important issue in the BC Ferry operation, because the operating route is overlapped with southern killer whales critical habitat, which is protected by the Canadian government considered as an endangered species. So whatever happens at whatever happened to the killer whales, people pointed out BC ferries. So we need to do something better. So we started URN measurement since 2014, and at the time, it's just the beginning, and baseline was around 185 decibel, but I can say some of the vessels is over 190 at the time. And since then, we realized that, oh, this is pretty not so good. So we implemented how can we reduce the URN over the long term. So right now we are passing by the 2025, and we set up the target of the URN 175 decibel by implementing the URN related considered propeller design and the hull design by putting those ships into the operation. So I think the 175 decibel is a quite challenging target, but let's see how it works in 2030. So in terms of a URN management plan for the ship owners, I would BC Ferry divided into new vessel and existing vessel. And for the existing vessel, we also divide it into operation side and retrofit side. So for the operation, we focus on the crew education and the hull fouling measurement. I think earlier today, someone mentioned about the hull fouling. So BC Ferry is also very interested in the relation between the hull fouling and URN. And I wrote here that quiet mode, which is some of our vessels start implementing the quiet mode button. So when the captain see the whales and the marine members, he pushed the button and ship decrease the power and the RPM to reduce the URN. So that is another operation measure. And in terms of retrofit, definitely is an expensive one, but as we all understand, we tackle down the propulsion system, hull modification, and also real-time monitoring system. BC Ferry really want to put the URN measurement, direct URN measurement number into this real-time monitoring system. And for the new vessels, I think this topic is quite going to be interesting to the ship owners because we want to put the URN requirement in the building, in the specification for the new building. So BC Ferry successfully did 3 times already. And definitely the shipyard is very resistant to that idea. But here's the key thing. So we provide them enough URN data, including numerical prediction and also baseline measurement from the similar classes. So shipyard people felt confidence that they can build a similar vessel with a similar noise characteristic. So that's why we could put the URN requirement in the building spec. So in terms of a measurement, I would like to share some of the example of we call it island class vessel, which is about 80 meter long, carrying 400 people. So the Black Sea measurement is done during the sea trial in the Black Sea for the six vessels. And the same vessel we also measured in Canadian water near the boundary pass. So the bottom graph shows the difference between the Black Sea measurement and the boundary pass. So it is clearly see that the pattern is pretty close, except the higher frequency range, and that is due to the cavitation noise because of some steering happen because of the strong current over there. But what I would like to tell you is that once we have the measurement, regardless the location and the method, it is going to be worthwhile in the future for many different purposes. So I strongly recommend whenever there is a chance to measure, please measure the URN. And also, I would like to share about the good example of retrofit with a VFD. So that the vessel which we retrofit is we call it coastal class. BC Ferry is operating 3 of them, and two vessels are already implemented, and then next one is waiting for the next year. So previously, this vessel is equipped with a fixed 11 megawatt RPM motor with a variable pitch, which had with a 5-meter diameter propeller. So this vessel speed is only controlled by that propeller pitch. So as we know that it works well in the surface speed area, but when this vessel goes to the slower area, slower speed region, and then all the bad thing happens, vibration, cavitation, and everything, and the URN. So we understand that issue. So during the retrofit, we put the so-called variable frequency drive for the 11 megawatt motor. So now we can control the RPM as well as the variable pitch, propeller pitch. So we call it combinator mode. So right now this vessel is operating in the combinator mode with a 4.7 meter, a little bit smaller diameter. And this is a quick overview of the propeller change before and after. And the important thing is that the blade area ratio is a little bit increased. And the important thing is the propeller design point speed is reduced from 21 knot to 19.5 knot. There are some further explanation, but I will skip that. It's too much time. Okay, so this is the very dramatic result after installing the VFD. So we can clearly see that the huge reduction of the underwater radio noise, like almost 16 decibel at 13.7, and as the speed increased, it meets it is same as the original propeller, but. I think ferry operators understand that operation of the ferry. This ferry is about 30% of the time spent out of the design condition, so which means the slower area. So now, by doing this kind of a retrofit, we can successfully achieve that quieter noise at the slower speed region. And also, regarding to the fuel and the power saving, we could also achieve some savings, as you can see here. So with the combinator mode, we can achieve the best. So right now, this vessel, these two vessels are operating mainly combinator mode. So the fuel saving and power saving is different by the speed, but generally, from the chief engineer, I've heard that they can save fuel from 5 to 7% overall. So, so this is a great story from the BC Ferry that from the retrofit, we can achieve lowering URN, also increase the fuel efficiency at the same time. Okay, so our work is not stopped there. There are some more things to do. So basically, we need to measure more URN values from the other vessels out of 37 vessels. And also, we try to understand the URN versus the fouling, which is the for the ship operator, this is the easy task, like a low-hanging fruit to increase the fuel efficiency and reduce the URN. So we want to quantify the relation between URN and the fouling. And also install the real-time URN level monitoring system, which will be the part of the real-time conditional monitoring system. These days, a lot of owners started putting and to understand based on by using the big data analysis tool. And I think the URN should be part of that big data analysis as well. And lastly, we developed the URN requirement for the new building project. Okay, so lastly, the key takeaway is again, baseline measurements are the first step toward the lowering URN and set up the URN measurement plan. And the first step and the most important key when we discussed the URN issue with the shipyard, potential shipyard, because without this measurement, there's nothing we can show, we can tell to the shipyard to build quieter vessels. So I really encourage the ship owners that please do more measurement and keep the record, regardless what kind of method or the area, it doesn't matter. As long as we have measurement data, it is going to be worth it in the future. And retrofit with a variable frequency drive and new propeller introduced the huge opportunities to reduce the URN and the fuel consumption at BC Ferries. And all those works are supported by the Transport Canada. So I really appreciate help from Transport Canada and Orly and Michelle, everybody. Without your help, I cannot present this presentation. Thank you so much.
Thank you, Chanwoo, and thank you to all the presenters. And now it's time for questions for this panel.
I just want to say this is, I think, what Chanwoo has presented as a really good example of the progress we've seen since 2023, where we were just talking about, how and, you just come up with the baseline and kind of figuring out how to optimize the propeller, and now we've actually have results of in situ measurements, and it's really great to see that progress, and 16 dB is just phenomenal. So, well done. All right, questions. We will jump right at front row.
Thank you. Thank you very much. My name is Ilko Lemmens. I'm representing the Clean Arctic Alliance. I've got a question for Mr. Sakai. Very interesting presentation. And one of the things you said is that shipping noise is temporary. You can switch it off again. I was wondering if that is maybe a bit too optimistic, because the impact of noise can be lasting, like, for instance, creating stress, failure to feed or reproduce. And so I was wondering if you could elaborate a bit on this. Thank you.
Thank you very much, and the very good question. And honestly, from somehow you're correct, but how do I say that depends on the noise stress level. I mean, if the stress level is super high, there's no recovery. But in the case of shipping noise, it's not so super harmful. In that case, if we turn off the underwater noise, then maybe some natural recovery will happen, and then the marine life feels like happy, I think.
Lindy in the back.
Thank you. Lindy Weilgart from Pacific Environment, also for Professor Sakai. I applaud the trying to reduce noise in local sensitive areas, but as we all know, noise travels large distances, and even areas that aren't denoted as super sensitive are still full of marine life, which is mostly sensitive to varying degrees. So I would like to know how these local areas address the problem of overall human-caused noise pollution. Thank you.
Thank you for your question. And actually, of course, the ocean noise travels very, very long, but the important point, again, is the ambient noise. And if, in the case ambient noise is relatively high, the actual effect, there's no effect, okay? So, and the also important point is the some kind of a threshold, by biological threshold. And I think, how do I say? This is true. The noise travels very long distance, but the effect is very different from this point of view. Thank you.
Okay, we're going to go first. Back of the room.
All right. Thank you, Michelle. Can you hear me? Yes. Thank you very much, and congratulations to all the speakers who have presented us with very informative information in here. And I have a simple question for Mr. Bae from BC Ferries. In one of your slides, you mentioned that you are including the URN requirements in the specifications for new building projects, which is also based on the existing ship measurements that you have. May I know how would those requirements be specified? Is it in terms of the percentage reduction compared to existing ship, or in terms of a specific how many decibels reductions, and how would those decisions be quantified? Thank you very much, Mr. Bae.
Thank you for your question. Yeah, so basically, as we all know that there's a building specification and that there's one section, URN section. We put the table based on the frequency level versus the noise level in the 3 different categories. Because basically, as I mentioned, BC Ferries, the noise reduction target is based on the protecting the marine mammals, the endangered species near the operating area. So we focused on the frequency level, not to disturb their life. So basically, based on that, we categorize 3 different categories, and each category has the different target. But overall broadband noise level is the 175 decibel.
Thank you. Thanks.
And look on this side of the room. Yeah.
Federica Pace from Jessica Applied Sciences. Jessica, it's really refreshing to hear that the press is a better incentive than money. And I have actually 2 questions. One is how you quantify the 50% reduction risk in ship strikes. And the other one is whether there is appetite for giving feedback in real time of how closely the shipping companies are hitting the targets that you're setting to them.
Thank you for the questions. I may need you to repeat the second one once I get there. Related to estimating ship strike risk reduction, so there are several models out there being used, not just in California, but other places around the world. They are basically encounter models that take into consideration the likelihood that a vessel will encounter a whale given what we know about species distribution and density. And then it also factors in vessel characteristics. So it thinks about the size and the speed and the draft of the vessels that are actually operating in that area. And then it also now relatively recently incorporates species-specific evasive capabilities. And so there's basically a lethality curve for different species of concern that we have in California. So it gives us an understanding of how likely it is they're going to evade or survive a ship strike should it occur. And so all of those factors put together creates this model that we then use to estimate the risk reduction associated with those speed changes.
Thanks, very interesting. Regarding the second question, I was wondering, I understood that you are doing the calculation for the shipping companies afterwards, right? And at the end of the year or the month, you tell them whether they've met the objectives or not. So I was wondering if there is appetite to move that to a kind of real-time monitoring tool where if they are reaching this target, after a day, then you can actually give them feedback and say, well, you are on the path to exceeding our threshold, so you may want to decrease your speeds more now.
Yeah, thank you. So we are thinking about that. This has evolved over time. It used to be that we just did calculations at the end of the season to confirm what performance looked like and do the environmental benefits calculations at the end of the season. Now, as I mentioned, we do monthly performance calculations. So we're on a monthly basis reporting back to every shipping line that participates in this program on how their fleet is operating, what performance level they are currently achieving, what award level they're on target to hit. And we're planning on incorporating what I think you're pointing to, environmental benefits calculations on a more dynamic basis so that they can understand if you were to slow down your ships to this degree, you would contribute to and successfully achieve these specific environmental benefits.
Excellent, thank you. I'm going to take one more in the room, and then we're going to take one from online. So, Publio?
Okay, good morning. This is Publio Beltran from TSI Spain. We are representing a company dedicated to the solving noise and vibration problem in the marine sector, and also we are belonging to the Spanish delegation. My question is for Mr. Chanwoo Bae. related to is very interesting presentation. But it's clear that this presentation is well aligned with the main target or the main challenge of the low noise share project related to the generation of one system that enables to monitoring, in continuous monitoring, real-time monitoring condition of the underwater radiated noise. In this concern, I invited to you to visit the poster of this project because it could be interesting to change opinion with you. My question to you is the following. You are talking about the continuous monitoring of the underwater radiated noise. In this concern, what do you think about the continuous monitoring of the cavitation condition of the propeller in this process? Thank you very much.
Yeah, thank you for the very interesting and futuristic question. And as I mentioned earlier, like right now, a lot of ship owners try implementing the conditional monitoring system to understand their vessel performance. And I think for right now, mostly focus on the fuel consumption and vessel optimization and the route optimization. And when we try to understand real-time monitoring system, it's about all the sensors are connected and the information is feeding to the captain. So I think definitely the URN should be the part of that monitoring system, and we understand that how can we measure the URN on board. So there is a direct method and indirect method, and as you pointed out, so far, BC Ferry actually tried the indirect method, which is to put the accelerometer just over the propeller blade inside of the hull and measure the pressure level and convert into the URN level. So that is an indirect way. But however, we are not so happy about that, and because of that, a lot of the operation issues and the cavitation issues. So I think it's definitely better to directly measure the URN number and feed to the captain. And another thing which I would like to mention is that whatever we monitor and measure, it is not working until captain knows what's going on in his or in her vessel. So monitoring is the first, but how to feed that information precisely and concisely to the operators, that could be another issue. So BC Ferry is working on to implement that idea. So I will visit your poster and let's make a good conversation between two organizations. Thank you.
Thank you. We're going to take is Japan online?
Thank you. Thank you very much for allowing the floor online. So I have a question for the Mr. Alessandro Marino from Fincantieri. I understand you optimize propeller at 11 knots of the 230-meter cruise vessel, but such 11 knots is much slower than the service speed of this kind of vessel. It normally, as far as I understand, from 17 knots to 22 knots. For example, the enchantment of the seas tested in the previous session, service speed is normally 22 knots. So 11 knots seems to be much slower than the normal service speed. This means you assume some kind of speed reduction at the sensitive area or whole speed reduction during the whole cruise navigation. Thank you very much.
Thank you very much. Your question is actually much broader than my slide. No, I just showed those values at 11 knots because 11 knots is the velocity required for measurements for class notation. Actually, I just wanted to save time for Giorgio's data, and I could have shown the transit speed as well for that specific vessel, but the results were pretty much the same as shown for that speed. It is true what you said, that that 11 knots is far a lower speed than the design one or the service one for that type of ships. And of course, the optimization processes go towards the service speeds. Although we have to take into account the regulatory requirements when we need to achieve when we have to meet the criteria for the class notation itself. I hope this answers your question.
Thank you very much.
Thank you.
Just turn off your microphone. Great, thanks. We have time for a couple more questions. Hand shot up right over there.
Hi, thank you. Chloe Malinka with SMER Consulting. Question for Chanwoo Bae. You mentioned a quiet button that could be implemented on the BC ferries. I was wondering how that works. Is this having anything to do with the retrofit that you presented, or does this have to do with the ultrasonic anti-fouling that someone else in the audience had asked about regarding BC ferries in the previous question? And what are the costs to not always having that on, considering that you're in critical habitat for endangered whales? Thank you.
Thank you for your question. We have to dig a little bit more detail about the retrofit. So that is actually the part of the retrofit of the installing VFD. So when we installed the new VFD, as I said before, it was a fixed RPM. Now, with the advancement of electric technology, we could install the VFD, 11 megawatt VFD in the vessel. And so it was about $7 million per ship. So putting the additional button is nothing. So basically what we did is a small button in the bridge. So whenever captain see the marine mammals and he pushed the button, and instantly the ship shed the speed and the RPM, the pitch is a little bit lowered. So there is definitely, we measured that during the ship trial, and there is about 2 knots of a speed reduction. And however, as I said, BC Ferries, the main focus is the protecting the endangered killer whale. So it is worth to go a little bit slower for about 3 minutes. After 3 minutes, it will automatically come back to the original settle. So basically, that's how it works. And yeah, so right now we installed 2 ships, and 1 more is coming next year.
Thank you.
Going to go to Denmark because they had their hand up before.
Yes, Kenneth Svend from Maersk in Denmark. Hi. To Mr. Bae, BC Ferries, very interesting to hear. Of course, being a ship owner, interesting to hear how you specify this into shipbuilding contracts and building specifications. So obviously you've taken the decision to implement this in your new buildings. I was wondering to what extent you also considered taking into consideration how these, let's say, I don't know, let's for the example, say 5 vessels that you have specified for URN reductions. How do you ensure that this really make a significant or just an impact on the total picture of noise emitted in this region here, which obviously is a sensitive area, but considering the total vessel traffic density in this area, I imagine there's many vessels there, and despite your good efforts to installing this on, let's say, 5 vessels, out of the total sum of vessels and noise emitted, how are you sure that this actually make a difference?
Thank you for the much larger viewpoint of the underwater noise, and actually it makes it has some impact because from that area which we are operating, actually BC Ferry fleet is occupying more than 50% of our total fleet in that region. So that's why I told in my presentation, everybody pointing at BC Ferries. So we have no choice. We have to do something. That's why we started the earlier measurement. We started a measurement campaign since 2014. And reduction of the URN is the second top design element after the fuel save, the efficient design. So I can say that by reducing by implementing the quieter vessel more into the fleet, definitely will I hope that will make the killer whales happy and everybody is happy in the region.
And I can expand on that. Before Chanwoo got the finger pointed at him, they all pointed the finger at me and said, what about BC Ferries? So, the approach we've taken actually looks at all vessels. And I think this is goes to that whole point of there's no, one silver bullet. It's ferries doing their part, it's container ships doing their part, it's tugs doing their part. It's because we've done in Canada and in this space a study that looks at the contribution of the different vessel types within the region to figure out where we need to kind of target. And so there are measures targeting all the different types of vessels. But ferries wasn't a particularly unique one because of the variable pitch propeller and the fact that slowing them down, as we do through the ECHO program with all the other vessels, didn't help. And given they were the largest contributor just because of the routes, we needed to find another solution. So it's been a great collaboration working with BC Ferries to figure out how do we actually look at design. And this is where that, it's not just operational measures. We need to be looking at design features because it lowers, because of the different operating conditions and types of vessels, finding those different solutions depending on the different types of vessels and how they operate and where they operate and how they react to different measures is kind of part of the challenge and the complexity of managing this issue across the soundscape globally. So I'm going to say we have time for one more. We'll take one more question, and I'm going to go way to the back of the room over there.
I think you're pointing at me, Michelle. Yeah, okay. Amy Nugent here from Oceans North in Canada and also part of the Clean Shipping Coalition today. Thanks for really such a fascinating panel to all the panelists, but I again have a question for BC Ferries and Chanwoo Bae. You mentioned the cost was about $7 million per ship for the retrofits for the coastal class vessels. You also said you realized a fuel savings of between 5 and 7%. I'm just wondering if you have run that ROI in a temporal way, or might just be able to share a little bit more about the fuel savings in comparison.
You hit my weak point here, so. But anyways, I wish that everybody forget what I'm just telling you. Okay, so as the Maersk said, as a ship owners, we are not spending money to save killer whale, right? Basically, first one is that fuel saving is the target, but as I said, second one is that the saving killer whale. So basically, I'm not saying just BC Ferry, but the entire shipping world, the entire ship owners, their main focus is the reducing the operating cost, which is the directly same language as the fuel saving. So, BC Ferry spent $20 million. If I go to the CEO, hey, Mr. CEO, can you give me the $20 million to save killer whale? Will he give them money? Maybe Transport Canada will give money, but not from BC Ferries. So yeah, that's the point. So, however, we have to consider. I think more and more researches are done. Increase the fuel efficiency at the same time reducing the URN. And when I presented the similar topic in early 2022 and 2019, I said, we cannot do it. But actually, based on a lot of new technology and the AI-driven design method, actually we can do it. So I think so based on that idea with a more advanced design technology, I think the fuel efficiency and reducing the URN in terms of a propeller design, it should go together to make the CEO happy and whale happy. I think that's my answer.
Thank you. Thank you, Chanwoo. Michael, you'd like to have the final word for the session?
Just a huge thank you to all the panelists and everyone for your active contribution.
Thank you very much, Michelle and Eric and all the speakers. That was a fascinating discussion, and it's great to see that there have been some significant results. And it's quite obvious that this is obviously a highly technical area, and a lot of expertise is required, but also political will to see Canada supporting BC Ferries and also Jessica's work and so on. So great work, everyone. Just to say that lunch is now served on the 4th floor in the cafeteria. It's beautiful food. That's the good news. But unfortunately, we have to pay for it ourselves, unless you have nice colleagues who are going to buy you lunch. And could I say that we're going to start at 2 p.m. sharp to keep everything on schedule. And those who are doing poster sessions this afternoon, please can you come with me now to the delegates lounge on the 1st floor with all your associated equipment, and we'll set everything up for later on. Thank you very much, everyone. Enjoy your lunch and see you at 2 p.m.
Pelagos est
Can everyone please take a seat? We're going to get started momentarily. Please.
Ranga being one.
Good afternoon, everybody, and welcome back. I hope you had an enjoyable lunch and were able to continue some of the conversations we started this morning. So we have a full afternoon with some fascinating presentations. Before we get started, I do want to flag that after this session, at the beginning of the coffee break, there will be a short, I'm going to say 5-minute presentation on a new initiative that Canada and Panama are leading. In June, we launched a high ambition coalition for a quiet ocean, which is an initiative globally to increase the awareness around underwater noise. And so we will be doing a short presentation on just what the initiative is and inviting other countries to reach out and join us. So if you can stick around for the first 5 minutes of the coffee break, that would be fabulous. So without further ado, we're going to jump into the afternoon session. We have 4 esteemed panelists with us. We have Mr. So Mehmet is unfortunately not with us, but we have Mr. Chatai, did I get that right? Kaksal from the University of Strathclyde. We have Mr. Christopher Stinkley from Stolt Tankers, Mr. Chris Waddington from the International Chamber of Shipping, and Ms. Antidia Satoris from Green Marine Europe. So we will start with you. Okay. You're first.
Thank you very much, dear sir. This one, I guess. This should be nice now. Hello, everybody again. I'm Çağatay Köksal from University of Strathclyde, and today I will talk about the EU project GATERS final results, along with some follow-up actions. And I prefer to begin with talking about the concept of this get-rudder system for those still not familiar with it. And in a conventional propulsion setup, we have a rudder behind a propeller. And in our case, we're just removing it. And either you can keep the propeller position as the same, or you can elongate it if you like to improve the flow quality acting along the propeller disc. And one even can change the aft end shape if you'd like to go further. And then we're also playing with the propeller design, because in a way, these 2 rudder blades aside the propeller this time, just unloading the propeller and bringing there some additional lift. So, and also we experience a good, favorable hull propeller rudder interaction based on our different type of ships, specifically in heavy weather or in wave conditions. And it was in a way our contribution to the previous workshop 2.5 years ago. And there we talk about again the concept, and there were 2 ships within this project. One is for the reference vessel. They were sister ships, Shigenobu and Sakura. And the other one was the target vessel. It was the ERGE. They're both almost 100 length, and the coastal vessels. And we also presented there some of our full-scale cavitation observation to understand the impact of the system on the full-scale sea trials. And this time, I'll present you the final outcome of this project that we have agreed within all of our consortium, and also we'll share some model test results and the numerical studies, because in a way, at least from our side, if you'd like to deal with this kind of underwater radiation noise mitigation techniques, you should deal with it at an early design stage, not putting the ship to water and take some measurement, instead just manage it from the beginning. And also, I will introduce a kind of NEE URN measurement technique, and I hope you'll like it. So these are the fully refined results of the sea trials comparison of the get-rudder setup with the previous conventional system. And there we considered our dry dock hull roughness survey results, as well as the sea conditions. And the results were satisfactory, the saving within the 2-digit, and also this concept mitigating the noise level up to 10 decibel and improving it almost the entire or across the frequency spectrum. And it's 97% improvement, and it is more than 36% for 5 decibel, and at some point even you can reach more than 10 decibel for 0.2%. And we are attributing this reduction into the this system's unloaded propeller configuration and also probably the beating the cavitation itself. And this is the testimony of the ship crew and the owner. We're regularly communicating with them, and if you like, once in a month, and every single time the feedback is the same. Ship is now sailing with 1 knot faster and 8% less fuel consumption compared to the previous configuration, even if they keep the propeller speed the same. And it is now 2.5 years, this gate-rudder retrofitted ship for the first time is sailing, and a few months ago it was dry docked, and we checked it, it was in healthy condition. And maybe one of these important points is that the previous configuration could not satisfy this EEXI criteria. And if you're not in a way changing the engine or power limitation, so-called this slow steaming, but in gate-rudder case, it's all good. And you see here the comparison for this famous admiralty coefficient versus the buffer scale and also the fuel oil consumption and also the nautical miles that we follow. And here, I will also talk about some of these model scale measurements. For the target vessel of this project in CNR, we have conducted some model tests and compared it with our full-scale sea trials. Within the sea trials, we followed the BV procedure, and 2 of these representatives, one in our target vessel and the other one is the support vessel, they observed the sea trials and accepted our procedure that we applied in there. And the results for the models tests were in good agreement with the full-scale trials. I mean, the URN level reduction was up to 10 decibels, specifically for the higher frequency region. And this was for the target vessel of this project. And as for the reference vessel, the Istanbul Technical University's large cavitation tunnel was used within the same respect, but this time taking the other ship. And you hear the right and top side of the screen, the sea trial results from the Japanese ships, the sister vessels. There, ISO standards were followed. And again, the results were really very similar. There were 2-digit saving for the energy efficiency, and also the URN reduction was up to 10 decibel again, which is specifically to the higher frequency region. And we also had a chance to compare the cavitation pattern with and without this concept, and it was obvious that this system is in a way mitigating or killing the noise. So these are our full-scale cavitation observation during the sea trials, and there, following the sea trials, we also introduced there some of our high-fidelity numerical simulation methods and overlaid or compare our findings with the full-scale results. And again, the results were in good agreement. And once we validated and verified our methodology, this time we decided to investigate this configuration in various rudder angles, because in a way, one may call this system as an open duck system. But you're omitting the bottom part and can individually control 2 rudder blades. And this data was important for the rudder designers. And these are the number of the ships up to date fitted with this system. It was 2.5 years ago limited to 4 to 5, but nowadays exceeds 10 if we consider the number of the sister ships as well. So recently, 2 of these car carriers have been launched in China for Grimaldi, and based on some gossip, the results are good. They have conducted the sea trials. And also in Turkey, now there are 2 of these container ships are under construction for A to B online. And within the next few months, we're also expecting to hear from their sea trials results. And based on our private communication with the patent holder of this idea, up to now, there are 55 of ships owners. They have demanded to have this design, and many of them has been tested in model scale, and few of them now under construction. It means that within the next few years, the number of the ships sailing with this concept will be increasing. And this is the new concept that I was referring to. In principle, there's a drone. It's an aerial drone, but can deal with the water. We're just taking it out from the hull and landing it to the water. And there's a hydrophane array underneath. And the advantage with this concept is that, the standard measurement techniques are based on all low buffer scales or the light weather condition, as you may appreciate. But in that case, we cannot fully represent the real life conditions. So at that scenario, either you should introduce that real-time URN monitoring system that you're going to fit into your own vessel, or you can use this kind of concept. And we were lucky to demonstrate its effectiveness based on conducting these measurements in 2 different weather conditions, higher and lower one. And as expected, this system, as it doesn't measure any additional voice coming from the support vessel's motion within this high buffer level, it also measured the noise level lower compared to the standard deployment, specifically for the low frequency region. In that case, we are not undermining the standard concept. In a way, our claim is that this is complementary. And this is extra. We are also investigating the interaction between different type of energy-saving device with this concept. And for the last, at the time, our, again, Japanese colleagues, they have tested this propeller boss cap fin with the get rudder system as, in a way, when you're omitting this rudder behind, you're changing the pressure distribution, so it worked good. And one of the most contribution probably will be from the get rudders combination with the wind-assisted propulsion systems, because, in a way, this concept like underwater sails. And when you have this wind-assisted propulsion system, you'll have this side force. But this system, in a way, mitigates this undesired consequences. And based on our numerical investigation, combination of these two can provide more than 30% for this heavy loaded weather conditions. So this brings me to the end of my presentation. Thank you.
Thank you very much. We'll now move on to Mr. Christopher Stinkney from Stolt Tankers. Over to you.
Sure. Great. Good day, everyone. My name is Christopher Stickney, and I serve as the business partner for sustainability and decarbonization. I'm currently leading our underwater rated noise initiative, which aligns with our SDG 14 Life Below Water strategy, aiming to minimize our environmental impact on marine ecosystems. Thank you for giving Stolt Tankers the opportunity to share insights on hull and propeller coatings, as well as installation of a propeller boss cap fin by comparing two similarly sized sister vessels with you today. I hope you find the presentation and information both insightful and informative. A brief overview of what we do at Stolt Tankers, being a leading operator of deep sea and regional chemical tankers, providing safe, high quality, and flexible global transportation services for bulk liquids. We have a fleet of 162 chemical tankers with 3.1 million tons of deadweight capacity and shipping over 600 products internationally. We currently hold an EcoVadis rating of gold in sustainability, being one of the top 5% of companies assessed, demonstrating our dedication to sustainability and reducing our environmental impact. This brings us to our next priority and our long-term commitment to providing to improving energy efficiency and reducing underwater rated noise. Here we showcase our commitment to energy efficiency, the importance of addressing underwater rated noise. Our commitment is to protect marine life by not degrading the marine environment through noise pollution, while also improving energy efficiency, reducing fuel consumptions, and lowering greenhouse gases. By sharing best practices, insights, and data, we aim to contribute meaningfully to this workshop and lead by example. With those insights in mind, let us now review the key results and conclusions from our study. While underwater rated noise levels showed minimal measurable difference between the two sister ships, the vessel equipped with energy efficiency upgrades, including a propeller boss cap fin, graphene propeller coating, and renewed anti-fouling system, demonstrated notable gains in fuel efficiency and hydrodynamic performance. For those unfamiliar, a propeller boss cap fin is a device fitted to the propeller's hub aimed at enhancing energy efficiency by reducing hub vortex, lowering fuel consumption, and improving energy efficiency overall. On the right, you can see an example of how the measurements were taken. The vessel completed controlled acoustic measurements by passing a hydrophone array at standardized distances and speeds. 4 runs were conducted at each test speed being 8, 10, and 12 knots to ensure consistency and reliable comparison of underwater noise performance. The expected results projected a 5 to 12 decibel range reduction and a 1.5% improvement in fuel efficiency. Actual findings showed a more favorable outcome in fuel savings, achieving 4 to 5%, while noise reduction remained modest at around 4 to 8 decibels at 12 knots and 2 to 4 decibels at 8 knots. Some of the challenges encountered during the measurement process included adverse weather conditions, ship schedules, delays in equipment clearance by customs and port authorities, and difficulties arranging offshore transportation services to the ship. I will now walk you through the measurement findings and compare the results between the ships before and after anti-fouling coatings. Acoustic measurements shown here are of the first vessel before and after the application of a graphene propeller coating and renewed anti-fouling system. The second vessel measured was following installation of a propeller boss cap fin in addition to the same coatings. Across both vessels, results showed promising reductions in underwater rated noise being 2 to 8 decibels. This falls between an expected margin of uncertainty in the data, but remains significant and should not be disregarded. Notably, the first vessel met the criteria for quiet class notation during its initial baseline measurements. As shown, ship speeds affect noise levels, showing at lower speeds reduction of ERN is possible within 130 to 180 decibel range. We will then look at the results comparing the two sister ships' frequencies after the modifications. The graphs indicate acoustic signatures consistent with ultrasonic anti-fouling systems installed on the box coolers of both vessels. These systems produce identifiable tonal peaks between 21 and 44 hertz, with a stronger noise contribution observed on vessels equipped with the Propeller cap fin. The peaks are circled in red on the graph and were observed at speeds of 12 knots. Although these systems are intended to reduce biofouling and enhance fuel efficiency, evidence suggests that they may generate additional underwater rated noise, contrary to some of their claims. In a market where every improvement is leveraged as a selling point, it's important to recognize that underwater rated noise reduction is sometimes proven more as a marketing tactic than a proven benefit, and should therefore be approached with careful consideration. Despite minimal change in frequency levels and a potential increase linked to the ultrasonic anti-fouling systems, we are actively pursuing additional solutions that deliver both energy efficiency gains and meaningful underwater noise reduction. Salt Tankers is actively exploring strategies to address underwater rated noise while simultaneously enhancing energy efficiency across our operations. Key initiatives include optimizing voyage planning and vessel routing, adopting advanced technologies such as graphene propeller coatings, and cutting-edge anti-fouling solutions to minimize hull fouling, and leveraging precise fuel efficiency monitoring tools. Additionally, we have implemented the ISO 50001 standard across our fleet to improve energy management. This involves setting baseline energy performance indicators, conducting comprehensive energy assessments, and establishing robust systems for ongoing monitoring, measurement, and reporting. Some of our ISO 50001 initiatives include assessing the fleet's annual efficiency ratio, alternate fuels, propeller retrofits, and in-transit hull cleaning. Looking ahead, we aim to implement a fleet-wide underwater rated noise management plan to further strengthen our commitment to marine life protection and noise reduction. These measures are integral to our broader decarbonization journey, driving us closer to achieving our ambition of net zero emissions by 2050 by reinforcing our commitment to operational efficiency and environmental responsibility. For Stolt Tankers, this journey began as a simple article drawing parallels between energy efficiency and the reduction of underwater rated noise. What started as a technical curiosity evolved into a broader mission to bridge the gap between energy engineering solutions and the environmental impacts of decarbonization. Our focus has grown beyond simply reducing emissions. It's about understanding the full picture of decarbonization both in the air and beneath the ocean surface. Reaching this point has taken countless phone calls, meetings, discussions, and presentations, and I firmly believe every effort has been worthwhile. While findings may not yet capture the full extent of noise reduction we aim to achieve, they represent meaningful progress in advancing our understanding of underwater rated noise and shaping data-driven mitigation strategies. We also learned that reducing low-frequency noise levels by 6 decibels could be expected to reduce the number of individuals of sensitive species exposed by around 75%. Together with these efforts, reflect what it truly means to move towards net zero by 2050. Achieving this vision requires us to step beyond our silos and embrace our broader ecosystem perspective, recognizing that every action, no matter how small, contributes to a greater collective impact. Over time, these deliberate changes will create a simple ripple effect, transforming today's challenges into meaningful progress towards a more sustainable future. Finally, I'd like to extend my gratitude to the IMO and Glow Noise for sponsoring and hosting this workshop, and to the International Chamber of Shipping, Ocean Care, and International Fund for Animal Welfare for their collaboration. Your continued engagement plays a vital role in advancing responsible and sustainable maritime operations as we work together to protect our marine environment. Thank you.
Thank you very much, Christopher. I think it is important to remember that 2 to 8 dB is actually a really good result in context. When you're saying a 75% decrease in kind of sound pressure, it's actually it's hard sometimes. We sit here and, we expect these big numbers like, 20 dB, but it's still, it makes a difference. It's still an important reduction, and I think we need to keep that in mind when thinking about the numbers. It doesn't have to be as big as we think it needs to be to achieve the reductions that are necessary to support marine life. So, but no,
thank you.
It's really interesting. Thank you. So Chris, over to you, International Chamber of Shipping.
Thank you, Chair. Presentation. Okay, thank you. So, good day to all, and if I may, I'd like to briefly introduce myself. I'm a naval architect with 38 years industry experience. And I've worked on a wide range of ship design and construction projects, including research ships, for which reduction of underwater radiated noise is mission critical. On the right is one that I contributed to earlier, the fisheries research vessel Charistes, which had some quite novel features and is still recognised as one of the quietest research ships. Since 2021, I've been representing the International Chamber of Shipping, or ICS, as Technical Director, including advocacy work at IMO, where I hope to have contributed to the debate on URN. I also chair the tripartite working group on underwater radiated noise, and this is an industry working group whose objectives were previously detailed within a submission to MEPC 82. So my presentation today will detail the potential economic benefits to a ship owner of URN reduction before considering 3 real-life case studies. And these studies compare the cost of adopting a noise management plan, or quiet ship class notation, with the potential rewards received from environmental incentive schemes, such as Green Award, IAPH, ESI, and the Noise Ship Index. So now let's consider whether it might be feasible for URN reduction to yield a financial benefit. So when considering our potential contributions to the experience building phase of the IMO URN guidelines, our working group noted 2 key points, i.e., firstly, the strong synergy between URN and energy efficiency gives an opportunity for a URN reduction strategy to be implemented at low cost, if considered holistically alongside energy efficiency measures. And secondly, there are various environmental incentive schemes that give, or in the near future may soon give, financial rewards for URN reduction. And to us, this raised an intriguing question. That is it possible for a ship owner to gain a net financial benefit by implementing a URN management plan or adopting a quiet ship class notation? And our working group set out to answer this question by developing 3 real-life case studies for ship owners that have implemented URN reduction measures. And detailed versions of these case studies have recently been submitted to SDC 12, so will be appearing on IMO docs very soon. So let's now look at the 3 case studies, the first of which relates to a RoPac ship operating in the Baltic. Noting the progressive nature of the IMO greenhouse gas regulations, this ship owner adopted a forward-looking approach to energy efficiency by reducing the ship speed to the extent practical within the operational constraints. However, this meant that the propeller was no longer operating within its design condition and therefore not at its optimum efficiency. Hence, the propeller manufacturer was contracted to design new propeller blades for the reduced speed, and the new blades were fitted in early September 2023. URN measurements in accordance with the ANSI ACER standard were taken immediately before and after the propeller change by the local university at a cost of €13,640. And the ship owner was very pleased to find that low-frequency URN reduced by about 16 decibels and fuel consumption reduced by about 17%. And I think this aligns very closely with the results that BCF were quoting earlier. Now, the ship owner already participates in the IAPH Environmental Ship Index scheme, and it's anticipated that URN reduction will be included in this scheme from 2027. Under IAPH's current proposals, a maximum of 20 points may be awarded for various aspects of URN reduction, and potentially as a bonus to the existing ESI score. Although the ship does not currently have a URN management plan, the propeller modifications and noise measurements could have been part of such a plan. For one of the served ports, it appears likely that the ship will achieve the next highest level of reduction in port dues, as it only needs to increase its ESI score by 3 points. And we found that the resulting annual reduction in port dues is likely to amount to about €14,700. And this summarises the net financial benefit expected to be attributed to the adoption of such a noise management plan. The calculation assumes that the cost of the measures, in this case the cost of the propellers, is attributable to energy efficiency and greenhouse gas regulatory compliance. Hence, there is no capital cost attributable to URN reduction. We also assume that drafting of the noise management plan costs about €5,000, and this is repeated every 4 years, together with new noise measurements. Therefore, as per this summary, the total annualised cost to the noise management plan and URN measurements is about €5,000, versus a potential annual reduction in port dues of €14,700. Therefore, for this case study, there does appear to be a modest financial benefit from implementing a noise management plan of about €10,000 per annum. Turning now to the second case study, Canada's Steamship Lines has implemented a noise management plan across its fleet. And for ships operating on the east coast of Canada, CSL uses the Mars Autonomous Measuring Station in the St. Lawrence Estuary, and for those operating on the west coast, the Port of Vancouver's ECHO Autonomous Measuring Facility. For the Mars facility, CSL estimates that the annual cost for each measured ship is about $1,875 Canadian dollars, and the noise measurements from Vancouver's ECHO facility are provided to ship owners free of charge. The CSL URN management plan applies to all 42 owned vessels within their fleet. And if we assume a drafting cost of $8,000 Canadian dollars every 4 years, then the annualised cost per vessel is just 42 Canadian dollars. On the east coast, none of the ships which utilise the Mars recording station qualify for URN reduction incentives from the ports served. But the IAPH ESI scheme will include URN from January 2027. And noting that Montreal Port is a member of the scheme, it's possible that some CSL ships may benefit from then onwards. And for a Laker-sized ship visiting Montreal Port, say 5 times per year, the total harbour dues payable are $5,145 Canadian dollars. Although the 2027 ESI discounts of the Port of Montreal are not yet published, it is apparent that to give a net benefit for a ship owner's URN reduction strategy, the level of discount would need to exceed about 36%. On the west coast, the ships that utilise the ECHO recording station and visit Vancouver Port will accrue reductions in harbour dues if they have undertaken various URN reduction steps. For example, ships fitting specified technologies, many of which also improve energy efficiency, will qualify for the silver reduction rate, yielding a 0.041 Canadian dollar per gross registered tonne reduction in port dues. And for a Panamax-sized ship visiting Vancouver 5 times per year, the annual reduction in port dues would amount to about 8,954 Canadian dollars per year. So this table summarises the net financial benefit expected to be attributed to the adoption of a noise management plan on the west coast of Canada. And as per this summary, the total annualised cost of the noise management plan and URN measurements is very little, versus a potential annual reduction in port dues of 9,000 Canadian dollars per annum. So again, as per the previous case study, providing a modest financial benefit. Moving now to a third case study, and I must thank Christopher for the data provided for this. Stolt Tankers operates deep sea and regional chemical tankers with 162 ships operating across Europe, Middle East, Asia Pacific, the Caribbean, the US and Latin America. And several of Stolt's ships have been awarded quiet ship class notations. For our case study ship, a ship of 9,000 gross registered ton, the necessary URN measurements, workboat hire and class survey fees to achieve such a notation amounted to about $50,000 US. Our case study ship operates in the Caribbean and Central America, and as yet there are no environmental incentive schemes within this locality that Stolt tankers participate in, and that reward URN reduction measures. But for illustrative purposes, we can use the Port of Vancouver's incentive scheme to compare against, to benchmark against. And under this scheme, a ship receiving a quiet ship class notation would benefit from a platinum level of reduction in port dues. And if a similar scheme were introduced on a regular port call, then for our 9,000 gross registered ton ship, and assuming 5 port calls per year, such a scheme could yield an overall reduction in port dues of about $2,836 US per annum. And this summarises the net financial benefit expected to be attributed to the adoption of the quiet ship class notation. The total annualised cost for the adoption of the quiet ship class notation is about $12,500 US versus a potential annual reduction in port dues of $2,836 US. Therefore, for this final case study, there is an annual net cost of about $10,000 US per annum for the adoption of the quiet ship class notation. And I think this case study highlights a potential weakness of some of the incentive schemes whose rewards are determined by gross registered tons, i.e. they are less effective for small ships. And this is because the cost of achieving the notation is dominated by the URN measurement cost, which is largely independent of ship size, but the level of reward is reduced for smaller ships. So, in conclusion, unless autonomous measuring facilities or equivalent technologies are available, the only way to establish URN baselines for a noise management plan are dedicated sea trials. The costs of such trials, particularly if ships need to redeploy or go off hire, are likely to exceed any benefits attributable to incentive schemes. Second point. Using gross registered tons as a determinant of the level of reward is not necessarily well configured. As for small ships, it is unlikely to yield benefits that equal or exceed the cost of a noise management plan or a quiet ship class notation. Nevertheless, if well configured, environmental incentive schemes can provide financial rewards equivalent or in excess of the costs of implementing a noise management plan. And if implemented on a wider scale by a greater number of ports, such schemes could be a key enabler of greater URN reduction. And it should be noted that financial gain is not the reason that some ship owners have already adopted noise management plans or quiet ship class notations. Some consider this approach as an integral part of their environmental policies and responsibilities, and others considered that early adoption of new technologies and techniques is part of their corporate culture and can yield longer-term competitive advantage. Nevertheless, shipping companies are businesses and as such are principally focused on returning profit. Hence, if the availability and accuracy of low-cost URN measuring facilities can be improved, and the rewards from incentive schemes are configured to exceed the cost of URN reduction strategies, then with further adoption of such schemes by ports, the industrial scale uptake of the IMO URN guidelines and quiet ship class notations must surely follow. IAPH ESI is one of the largest and well-known environmental schemes. However, with URN only coming into play in 2027, it will be several years before it becomes clear how effective it is. and noting that the 3-year experience building phase of the URN guidelines is due to end in 2026, it would be beneficial in this respect for MEPC to confirm the optional 2-year extension. Thank you.
Thank you, Chris. So in the same vein of incentives and indicators, we're going to have our final presentation of this group from NTDA with Green Marine Europe. Over to you.
Thank you. Thank you for the invitation. I'm Antilia Citores. I work for Green Marine Europe and part of the Green Marine International team. So happy to present here our certification, that is a voluntary certification, and all the program with a focal point on Europe, but you will see many figures on the international level. So maybe to present really briefly what we meant by a certification program and how it works. First of all, it's a tool that helps to benchmark, to see where you stand as the ship owners, at what level of performance you are. But Green Marine is not only a stamp, it's also a community. We have many members around the world that contribute to build those indicators of performance. It's not me alone or the whole team of Green Marine that are building them. It's government, NGOs, and industry that are building those indicators, and this is something really important in the way we work. We have independent verification, of course, with experts, public reporting, so everything I'll be saying to you today, it's on our website, include the results of each company, each port, each shipyard that is involved in this program. Transparency is one point of what we are doing here as a game changer to foster environmental excellence. This is a Green Marine International organization. Very briefly, there is an umbrella organization based in Canada, with 3 branches, North America, Canada, Green Marine Corporation in US, and Green Marine Europe I'm representing today. This is the figures of the number of participants. You have more than 80 companies that are ship owners that are involved in the program, with a certification that illustrates their commitment on several indicators. I will go further on those aspects. This is the figures for Europe, for you to have it briefly. And this is a place we are today with only ship owners and shipyards. But next year, we will be opening the certification to ports, adding to the map, facilitating that kind of map in 10 years as an objective. We, in North America, have already 185 participants, among them ports, terminal, ship owners, like BC Ferries, like FedNav. So there are also many in Europe, like Balearia, Stena. So this is a worldwide program, and we have already a few foot, I would say, in Australia and also in Mexico. These are performance indicators that are implemented for the shipyard and ship owners in Europe, as an example. As you see, we are not just decarb focused, and we are not just URN focused. We use every kind of commitment of each company to analyze the performance, but also to enhance it and to facilitate, when possible, some incentive. We managed to do so with the EU legislation of port reception facility new regulation, facilitating incentives on the level 2 for the waste management aspect. So this is where we work, and this is the whole indicator we have. On underwater noise, this is something that, because we're born in Canada, that we are involved with 15 years now. So we have this background to facilitate the comprehension, the work with several companies you already present here, but also to facilitate an emulation in between the whole companies, but also to talk with ports and to talk with shipyards. The way we work is an ecosystemic approach. We work with shipyards to facilitate eco-design. We work with ports to facilitate OPS, we work with the several chain and not only one sector, because we know that the effort from one sector will benefit to the other ones. And in that sense, we have a higher and higher commitment of the several companies, but also shipyards to reduce their impact. They use many, because we know that there is no just one solution. There are several parameters, slow steaming, new propellers, etc., on which you can invest to facilitate this reduction noise. Our next step for next year is to revise our indicator on underwater noise, linked to the EBP new phase, linked to the Pelagos Consortium. I will focus here, and this new chapter for a specific experience in the Pelagos Sanctuary area. If I may invite you to send the video.
est là pour protéger des dauphins, des baleines, des globicéphales, l'émerveillement du monde marin. Le sanctuaire Pelagos est un accord tripartite entre la France, Monaco et l'Italie. Et ces trois pays réunis qui aujourd'hui en prennent soin depuis maintenant une vingtaine d'années.
L'objectif est de faire de Pelagos non seulement une zone protégée, mais aussi une force d'action conjointe, fondée sur la coopération, la confiance et le sens des responsabilités partagées.
Today we are launching a consortium which is made of more than 13 partners. Green Marine Europe is providing their strong help with the stakeholders engagement and the dialogue and the certificate for shipping companies. So over the next 4 years we will be working side by side, hand by hand. Nowadays, if you reduce the speed 10%, you gain in noise emission, CO2 emission, reduction of risk of ship strikes. So by adopting this label, you do something which is very good for the environment.
Les objectifs de Green Marine Europe dans cette initiative, c'est d'amener les parties prenantes du transport maritime vers des bonnes pratiques. La première action, c'est la mobilisation des parties prenantes qui va de l'industrie du shipping, donc l'ensemble des cargos, conteneurs, ferries qui passent par ces zones-là, et puis également les yachting, les ports. Donc allez voir cette communauté d'entreprises ou territoriales pour les impliquer dans une réduction des impacts encore plus effective. So yes, you can come back to I can say a bit more in details on this kind of Blue Corridor Lab we want to launch in Pelagos. This initiative will be official in 2 days. This is a work we are assessing and we are developing with all the partners. It's about research and innovation, so ports will be involved, companies will be involved, but also local authorities. I would like to thank France, Monaco, and Italy, and also Spain a bit on this work with the PSSA, because this is something that we will be inspired to facilitate, of course, fostering of a good initiative like they are in Canada. You mentioned the Vancouver Eco Program. This is something that we want to be inspired and to want to have this territory to develop some schemes with incentive, with new protocols, and also to have an enhancement of this commitment, because when there is a commitment, there is a game change. Very briefly, if you want to know more about all the results of all the companies, we just released the annual performance reports. So this is where you can find all the details on all the indicators, including URN. And just I invite you to a new meeting. It will be next up in Nice, so our Green Shipping Day. It's our annual event in which we will be making a workshop dedicated to URN. So I hope to see you there. Thanks.
Thank you very much, and thank you to all the speakers. So we'll move into the Q&A now.
Yes. So, are there any questions in the audience? Otherwise, I have one. Michael.
Thanks very much, Eric. I was going to ask this question in the last panel, but I didn't get around to doing it. I'm intrigued to hear more about the effect of good anti-fouling measures and its relationship with underwater noise. So in the first panel today, we heard of tests that were carried out, and then the second one we heard a bit more about references to biofouling, and then there was a focus on it there just now, I think, particularly by Christopher from Stolt Tankers, focused on a pre-test and then a post-anti-fouling test. I presume you're talking about the whole vessel, and could you just explain a bit more about the measures, and also, because we all know that if a ship is not maintained, its hull very well, there's serious drag and you need extra power and so on and so forth. So perhaps you could explain a little bit more about that. Thank you very much.
No, thank you for the question. Yeah, so to answer the question, yes, the measurements were taken on a single ship before dry dock, and the installation of energy-saving devices, including the propeller boss cap fan, along with the renewed anti-fouling coatings. And then, as you can see, the dates vary a little bit. Within a year, we did second baseline measurements, and that was because of all the challenges we faced, mainly weather. With the hydrophone systems, beyond 3 to 4 foot seas, you can't put a boat out there, you can't put the hydrophones out there. So that's the difficulties we ran into. And overall, the whole fouling to address that is it's prevention and maintenance. So we do regular tests on energy efficiency, fuel consumptions on our ships, and it's making sure that the soft fouling does not build up to hard fouling, so barnacles, etc. Because the soft foulings creates the drag, which then consumes more fuel consumption. The hard foulings produce drag along with bubbles, which also produce more underwater rated noise. So a couple of measures we're actually working on is in-transit hull cleanings, like I mentioned. So we have a tethered robot type device called Chip Shave that we have on several of our ships, and we do in-transit hull cleanings from port to port. So we clean along the parallels of the ship. We still can't clean the bottoms because it's out of reach of the system itself, so we still have to put a diver in the water, which then does the rest of the cleaning. And then we're also looking into technologies like the graphene propeller coatings, which also reduces the soft foulings on the propeller themselves, which reduces drag.
Excellent. Thank you very much.
Thank you. ITPA.
Thank you. International Parcel Tankers Association, Mike Bevis. I was very interested listening to the on the green marine side of things. I know you're from Europe, but I just wondered if you could indicate, is there any plans? I really love the idea of having the ports and the shipyards involved as well. I think that's a great idea, and as well as the owners, of course. But I just wonder if there's any plans to expand that to Asia. There doesn't seem to be much going on in Asia, although it does most of the shipbuilding, as you know. So I don't know if you would know that. Being Europe, I understand that, but if there was any plans on that, I'd like to know. Thank you.
I can answer. This is a plan. We are on it. We already have some contact with Singapore. This is where we are in Malaysia. So this is a starting point. Also Japanese actors. So not already fully involved, but this is the pathway we are in.
That's good news. Thank you very much.
Thank you. Clean Shipping Coalition.
Hello, John Maggs, Clean Shipping Coalition. It's a question for Chris, I think. Chris, very interesting, and I mean the basic principle I think that you're applying here is that if a ship owner doesn't lose financially from the noise notation, they're going to do it. So if there's some compensation for what look from here at least to be relatively modest costs, that they're going to move and do that, and then it would basically cascade and would end up with everybody under that notation. You know, there's lots of kind of non-market, non-financial barriers to the uptake of various technologies that could easily be in play here too. But that's not really my question. My question actually is, would this approach that it sounds to me like you probably would also support penalties for not having class notation, because the economic effect would be exactly the same as the one that you're describing with your proposal. I mean, I'm not entirely convinced that a penalty that was the same cost as undertaking the notation would actually do the job, but it sounds from your proposal that that you're suggesting that basically it would. The economic effect of a penalty would be exactly the same as the rewards that's being suggested. So, well, yeah, just your thoughts on that. Thanks.
Yeah, thanks for the question, John. Within our tripartite working group, what we were trying to do was to support the experience building phase of the IMO URN guidelines, and supporting the incentive, and I underline the word incentive schemes, is part of that. You know, it's a section within the guidelines. So we tried to look at that, focus in on that, and see how effective those incentive schemes could be. I wouldn't support a penalty, and the reason for that is when you get into operational issues, and we've seen this very much with CII, it's so complicated that it makes it extremely difficult to make a fair system. So if we're talking about incentives, yeah, great, you know, I think that could work fine. But penalising a ship owner, I mean, I'll give you an example. You know, adverse weather. The ship's going to be noisier. It's going to have to drive the propeller harder. And that's not the fault of the ship owner. You know, I think when you get into penalties, we would have to have a very fair system. And that's very difficult to achieve with operational issues. I think, as I mentioned in the presentation, a key factor in enabling this to go forward, and I think Lloyd's mentioned it in their conclusions as well, is readily available cheap measurement. We cannot manage something that we can't measure. And at the moment, you know, ship owners for a dedicated sea trial, they're spending somewhere between $30,000 and $50,000 on each trial. Now that's okay as a once-off for establishing a quiet ship class notation. But if we're going to do this at global scale, industrial scale, and preferably frequently, you know, not just every few years, but on a frequent basis, then it's really, really important that we get some way of economically and readily doing the measurements. And I noted in the GATERS report the good work that Strathclyde University have done with drones. You know, that could be part of the solution, perhaps. But yeah, thank you. I hope that answers the question.
Thank you, Chris. If I may add, John, you have to consider as well all the people that are very creative to avoid the penalties and the cost that it is associated to that in case of penalty schemes. Whereas for incentives, it doesn't exist. They all want incentives. Michael.
Thanks, Erica. This question, I think, is also for Chris, and thanks for the really interesting presentation. I think is very helpful to begin to outline a kind of a business case. One obvious point to notice in the various case studies you presented is the absence of any additional cost for design. All the costs are related to measurement and related to the mechanics of preparing an underwater vessel noise management plan, but no costs are assumed for any kind of design need beyond what is already required or is already intended for energy efficiency purposes. But of course, there may be a design need if a vessel is to meet a particular target. So I'm interested in whether you've, or the group, the tripartite group, has considered any case studies for design costs. And these costs are likely to vary, whether you're talking about new builds, whether you're talking about retrofits, and you may need to parse out the cost from undertaking some kind of optimization effort between energy efficiency and noise. But has there been any attempt to get at the potential design costs in your case studies?
Thanks for the question. I think this is a really key philosophical point. The assumption that we made in the case studies, and we touched on it in the presentation, is that if noise reduction, for example, the drafting of a noise management plan, is considered alongside the selection of energy efficiency measures, then we can get into a win-win situation. Most of the energy efficiency measures also produce noise reduction. So the assumption that was made in the case studies is that the business case for the physical modifications to the ship is fuel saving and GHG regulatory compliance. The cost for the URN reduction can be effectively zero if you make the right choices at the right time. Now, I think the area that we have to be really careful over is propeller design. And I thought the University of Genoa and Fincantieri, their presentation was excellent. They focused in on that particular area. The idea that if you're really careful with your propeller design, you can get both good noise reduction and energy efficiency. But the rest, we saw it with the VARD report. Nearly everything else produces noise reduction. So, all we're saying is let's encourage ship owners, and increasingly they're embarking on major energy efficiency drives. Let's encourage them at the same time to consider noise. If you do it at the same time and you make the right choices, then the noise reduction can be free. We can do it off the back of the energy efficiency. I hope that answers the question. Thank you.
Thank you, Chris. Any additional question in the audience? Oh, Finland.
Thank you. This is for Mr. Coxall about the gate rudder system. So have you considered an option to use the gate rudder to create a kind of a bubble curtain around the propeller to dampen the noise? So you have a gate rudder system that's a structure around the propeller. So could it be used for this kind of purpose?
Well, thank you very much for this really very good question. To be honest with you, so I talk about the effect of this system from the underwater radiated noise point of view. But now you allow me to express or explain the reason behind that. So in a way, if you consider the effects specifically derived to this high frequency region, because we have the rudder blades aside the propeller blades, so in a way it absorbs the noise. So that's one of the reasons why we're reducing the noise. And also, we are now cooperating, one of the Dutch-based company, they're introducing their new hull surface comply mechanism to, in a way, change the noise pattern, this time acting on this type of interaction points. So yes, we're considering this. It is already working in that way that you're referring to. And on top of it, we're, in a way, trying to increase its effectiveness. Either you can introduce the leading edge of this rudder blades to inject some air to the tip vortex region, and also you can just put there something more than that. But thank you for asking this one.
Thank you. I have one question. Please.
Yeah, Mark Wood from Canada. This is for Chris Waddington. You mentioned that there's a need for affordable, ubiquitous URN measurement systems. What do you envision that to look like from your point of view?
Thanks for the question. And if I could wave a magic wand, whilst also adopting technology neutrality, one solution could be, as has been done by Vancouver and the Port of Genoa, autonomous measuring buoys. They're quite expensive, but a system of such buoys perhaps at key pinch points, say adjacent to the Panama Canal, Suez Canal, English Channel, Singapore, etc. If we put them at strategic locations, they could be available for a very high proportion of the world fleet. And because a lot of ships would be using them, the cost shared would be quite small. But there are other options, you know, and as mentioned by Strathclyde University, there's been some research and development done on drones. You know, I assume the idea would be that you have a drone on board your ship, and in the right conditions, when you're in a quiet area, you just deploy it and measure your ship. Great, virtually no cost. Other ideas, DNV, for example, have been looking at measuring the pressure pulses from the propeller inside the ship. Again, that could be a way forward. The disadvantage with that is that you're pretty much ignoring the noise from other sources like the machinery. You're just focusing in on the propeller. And it's fair to say that the propeller is the main culprit. You know, most of the noise is coming off of that. But yeah, if you're just measuring the pressure pulses, you won't hear necessarily machinery in the rest of the hull. But yeah, I think this is a really key thing. You know, if we're going to enable industrial scale URN reduction, then somehow we have to be able to measure it. It's like anything. You can't manage anything unless you can measure it. And at the moment, the options available to ship owners are just too difficult and too expensive to do it regularly at industrial scale. So, you know, I think this is a real priority going forward. And how do we get accurate, repeatable, available, economic measurement? Thank you.
In the back, madam.
Hi, Vivian here from Michael Kingston Associate. Much has been shared about strategies to reduce the URN, and I'm just curious if there has been any exploration into using AI-assisted pattern recognition to detect biological significant acoustic signals, which essentially overlap with other environmental noises. So the question is if AI could be used to detect those noise and then take just take an informed decision to whether which strategy would be taken from there.
Maybe I can answer, although I'm not a biologist. We have a few of them in the room, and it's already the case. Already AI algorithms are used and developed and refined to identify the various species and to help as well to identify where are the areas of risk with regard to species, because as you have understood from the different presentations, it's not only a level issue, it's also a frequency issue. And so that's important as well for this aspect, and it's already done by many bioacousticians and biologists. So if any in the room want to complete. Otherwise, yes.
Hello, can you hear?
Yes, so my name is Guilherme Vaz from Portugal, and I'm coming from Azores, where you may have known that there's more whales than people. So I'm from a small startup that connects maybe the two last questions. They are already real-time monitoring systems, cheap, made by a startup. We saw also some that Sagatai was showing with the drones. So I have a question for you on the drones. So, but yeah, there are already in the realm of the AI, a lot of people working on this small, cheap, scalable solution. So I think we have to look into what's there out there already from in this AI-based world. So if you want to talk, I'm available to show what we have done in the Azores, where wildlife is a big stuff, and you know there's a big marine protected area in the Azores now, where noise is going to be highly controlled. I have a question for the Strathclyde colleague of mine. So that drone is really cool. Yeah. So tell me, that drone sends the noise measurement real time to the ship?
Thank you very much, Guillermo. So if it's a simple question, yes or no, because it depends on the if you like, the distance between the ship and the drone. But somehow, what we're looking for, you know, compared to the standard measurement configurations, there you need to allocate at least one day of your ship, right? And you should call for some experts from the classification societies and rent a support boat and everything. But in our case, you know, compare it with the cost of a single drone. Fly tens of it. So if you compare the cost of them, you'll see the advantage there. So in a way, we are not afraid of losing these drones. Instead, we're afraid of losing the data. So that's the reason why this is our main aim. So we're trying to transfer the data, even if not the real time, still transmitting to type of a cloud region. Then we can take it from there.
Yeah,
that's the
point. I understand the advantage. But my question is, does it do real time or not? It's very simple.
For now, no. But this is our aim, yes. Yeah. We are working on it.
Yeah, yeah. And can you drop also the hydrophone to several depths, or it's the hydrophone close to the surface?
Well, to be honest with you, now we're working on a drone team concept. So individual of these drones will carry different hydrophones in various depths, and they will combine their measurement data and transmit the data to the main board. And in a way, they will also inform the measurement-based unit from not only the noise point of view, instead also the wave height, the temperature and the density, and also their distance to the hull itself during this measurement. So we are now looking for as a whole. Of course, this includes the real-time data transfer as well.
Okay, but it's all future work then. So, but it's a nice capability, like one of the examples of real-time systems that are out there and maybe the industry is not using because we don't know, but they are there.
Well, of course, if you don't mind, you know, this also can be related to the previous question. Nowadays, the National Environmental Research Council of the UK also recently released a call about the use of AI, this kind of stuff. So the measurement is the foundation of this validation, design, and the regulation and everything. If you don't have this consistent results, then everything above will be the weak point of view. So that's the reason why it's important to gather this type of correct data and use it to train any kind of AI unit. So that would be my comment for this point. Thank you.
Thank you. Yes, please. One last question.
Hello, I'm Noelia Ortega from CTN, the Marine Technology Center, where we support to companies and public authorities in the management of the underwater noise pollution issue. So just to complete the question that made before, the European Commission developed a catalog of noise signatures that was presented 1 year ago in Brussels, where this catalog is an open source and where you can find signature that has been processing using artificial intelligence algorithms, and where you can, it's mainly focused to noise generated by anthropological activities, but where you can also find some signatures and some noise data generated by whales and by other natural noise sources.
Thank you very much. We have one question online. Mohammed?
Hi, it's Mohammed Kasemi. I am with the Norwegian delegation. I don't have a question actually. It's a comment. There were questions about alternative measuring systems, and Chris just touched upon. I wanted to add on top of the comments that was made by Chris Waddington that he mentioned DMVs. Utilizing the simplified measurement methodology where DMV utilize pressure pulse sensors in order to measure the underwater noise emission from the propeller. And that comes with limitation of other sources, not necessarily always at all operating conditions is being dominated by propeller. Well, a continuous monitoring system, first of all, can be a very handy tool as part of a noise management system, but also you could utilize accelerometers in order to account for all other sources that may contribute to the total underwater noise emission from the vessel. Imagine that you carry out underwater noise measurements far field, utilizing hydrophone out at sea, performing the underwater noise together with a continuous monitoring system. There are different systems out there, but let's say pressure pulses together with accelerometers on the foundation of the main sources. Then you also establish a transfer function between the different sources on board the vessel and the far field underwater noise measurements. Using this continuous monitoring system, that provides you with the data also in real time to the crew that they can monitor underwater noise, so that not only they know the underwater noise emission, but they can adapt operational parameters for different limitations in sensitive areas, for instance, Port of Vancouver, California, or other places. Just wanted to add this. I think there might be a presentation on that tomorrow as well.
Yeah, indeed, with your colleague Royston. Thank you, Mohammed. Very, very, very fast, Vanessa. It's okay. Okay. So you saved the coffee break for give the floor to my colleague.
Before we run away for a coffee break. So I just wanted to thank all the panelists again for great presentations, and thank you all for the questions. So we will have a coffee break now, but if you can stay seated if you're interested for another 7 minutes. We're going to do a short presentation now on a new initiative that Canada and Panama have recently launched and would like to share, especially with member states who might be interested in staying for another 7 minutes, if you don't mind. So thank the panelists again. And if you want to get up and leave, I understand, but if you are so inclined to stay for another 7 minutes, that would be lovely, and happy to answer any questions after.
Thank you.
Yes.
Dismissed. Thank you.
Dismissed.
Michelle, I think what we can do is extend the coffee break by 5 minutes. So we're only going to dig into the coffee break by 2 minutes. Sure. So 7 minutes only now, guys.
Jeanette and Veronica, did you want to join me up here? All right, so wanted to take this opportunity where we had a relatively captive audience interested in the issue of underwater noise to share a new initiative that Panama and Canada have been leading, and now has a total of 37, I'm hearing soon to be 38 member states that have joined us. Do you have to change it? Or do you yeah. So I think we don't need to go into the details of what the impacts of underwater noise are, and that its impacts on the marine environment are significant and important and global. And I know you've heard a lot, it comes up a lot about the whales in Canada or the whales in different places, but quite honestly, there's species across the spectrum
from invertebrates to sea kelp to, depending where you are, to large marine mammals. So there's over 130 marine species globally that are affected by underwater noise, and so it's a critical component of ensuring we have healthy oceans. Next slide, which is what led Panama and Canada to launch a new initiative at the UN Oceans Conference. It's a member-driven coalition that aims to raise awareness, collaborative action, and sharing of best practice and capacity building globally on the issue of underwater noise. It's a recognition that yes, we are focusing here on shipping, obviously, but this goes beyond shipping. It's about biodiversity. It's about, the health of our oceans. And we know that one of the most critical aspects of this is ensuring awareness and knowledge of what the impacts are, and then how we can work together to address it. Next one. So at the Third United Nations Oceans Conference in June in Nice, the coalition was officially launched. We had a lovely event on a beautiful sailboat with speakers from 6 countries. The European Commission was there representing all 27 EU member states. The Secretary General was there speaking on behalf of the IMO, BIMCO, Inuit Circumpolar Council, environmental NGOs, really kind of demonstrating the kind of global support and across the both industry, environmental organizations, Inuit population, and international organizations, and the importance of this issue. Next slide. We had a total of 37 countries who signed on that day to the declaration that established the High Ambition Coalition. So in addition to Canada and Panama and the 27 EU member states, we have representation from Uruguay, Mexico, Costa Rica, Belize, Dominican Republic, Peru, Chile, and Guatemala are the kind of formal coalition members at this time. However, next slide. Oh, first I'll speak about this, then I'll do the however. The main declaration that we asked member states to sign on to, and it was signed by ministers, it's a ministerial level, high-level commitment, there's 4 pillars. The first one is related to the work of the IMO, recognizing that shipping is the main source of underwater noise in our oceans. So developing new policy to drive the design and operation of quieter ships through our work here at the IMO, which is what we're talking about today. The second is relating to the kind of role of marine protected areas and recognizing that it can be a vector within marine protected areas to address, and that where it is, this should be prioritized. And so kind of looking at the role of marine protected areas and particularly sensitive areas in restoring natural ocean soundscapes. The third pillar is around investigating and implementing effective solutions to reduce vessel impacts on sensitive ocean wildlife. So just continuing to do that research and understanding what the solutions are across the soundscape. And then finally, supporting capacity building to assess and reduce ocean noise by sharing available tools and knowledge. Sometimes it's just a matter of understanding what is out there. I mean, we're hearing a lot today about data and measurement capabilities. And we know that there is a lot out there, but sometimes we don't know where it is or how we can access it. So part of the goal of this is ensuring the availability of that information for everybody to be able to use to develop the tools and the measures that they need to address the issue within their waters and globally. Next slide. So this is an open coalition, and we are actively seeking new members to join to raise the level of awareness and level of action globally to address the issue. It's a commit to voluntary but ambitious, we like to say, actions that are outlined in the declaration, and to working to share, as I said, best practices and knowledge and raise awareness globally about the issue. So if you think your country is interested, please do reach out. So Jeanette and Veronica from Panama are based here at the IMO. My colleague Nancy, who I believe is in the room, I thought I saw her, is here for those of you who are at the IMO. But then we also have our country contacts as well. But feel free to reach out to get more information about how your country could join this coalition. Next slide. We will be, for those who are already members, if you didn't receive the email from me, there is a meeting at lunch hour tomorrow to talk about how we will move forward in terms of the governance of the coalition and kind of opportunities, particularly around the work at the IMO. And that is tomorrow at room 6 on the 5th floor. it's actually at 1 o'clock. I just realized that says 1:15. It's at 1 o'clock, not 1:15. And then finally, next slide, at Assembly coming up in November, November 24th, there will be a lunchtime event on the opening day of Assembly where it'll be an opportunity to learn more about as well as to welcome new members. So if we do have new members who want to sign on to the declaration, we will be welcoming them at that point in time as well. So final slide, I think, is just contacts. So there you go. So within the IMO context, you have Nancy from Canada, Veronica from Panama, and then we have our country level contacts as well. I'm happy to share this information. You know where to find me. You know Jeanette and Veronica as well. So please reach out to us and we'd be happy to share more information. Thank you.
Michelle.
Now you can go for coffee.
Thank you very much, Michelle, and great initiative, and well done, Jeanette and Veronica from Panama, and Nancy also from Canada. It's great to see such initiatives, and it's no coincidence that I think your role at the moment is acting head of innovation at Transport Canada, Michelle. So very good. We'll now have the coffee break, and we'll extend it until 15:50. So if we can be back here and start again at 15:50, 10 to 4. Same place.
Welcome back for the last session of the day. And we are very pleased to welcome a new set of presenters, starting with Ms. Blanche de Biolay, Mr. Emilio De Angelis, Ms. Lee Kinberg, and Mr. John Max. And I will leave the floor to Ms. Blanche de Biolay for the TNFD Marine Transportation and Cruise Line Sector Guidance. The floor is yours, Blanche.
And just a reminder that our lovely secretariat here is holding up time cards. So if you see the 2-minute and the time is up, they're just trying to keep us on track. Yes.
Thanks very much. Can you all hear me? Yes. Yeah, perfect. So my name is Blanche de Biolay, and I'm here to present on the coverage of underwater radiated noise in the TNFD's Marine Transportation and Cruise Lines Guidance. So this is just a first slide to show that environmental risks dominate the global risks landscape. So on the left, you can see the planetary boundaries, which reflect the rising risks from human pressure on 9 critical processes that regulate the resilience of our planet. And the recent planetary health check revealed that the 7th planetary boundary, so on ocean acidification, has been breached. So the Potsdam Institute for Climate Impact Research is an interesting source of continued updates. Yeah, would encourage you to have a look. But what I want to focus your attention on is the World Economic Forum's Global Risks Report on the right, which highlights biodiversity loss and ecosystem collapse as the second most critical risk across stakeholder groups. And this reflects the need for urgent action, and it also shows that the dual crisis of climate change and nature degradation are rising to the top of the global agenda. And so this is how the TNFD conceptualizes dependencies, impacts, and then risks and opportunities. So it's really important to understand dependencies and impacts that arise from nature, and then the risks and opportunities that arise for a business as a result of them. And they're all interconnected and interlinked. And we receive signals from investors that they're increasingly aware that, of the implications of nature-related risks and opportunities on the financial prospects of entities, and we see growing interest in and demand for information from their investees on this. And there's actually a growing set of case study examples. So TNFD collaborated with Bloomberg New Energy Finance on these 2 sets of case studies on the left. So the first one is on risks, and it follows basically 10 different cases of how organizations have mishandled their interactions with nature, leading to various forms of transition and physical risks, which caused $83.2 billion in financial impact, in cumulative financial impacts. And then on the right, you have case studies on opportunities as well, that I would recommend to have a look at. And actually, TNFD is publishing today another set of case studies on nature-related opportunities, so you can find it on the LinkedIn page if that's of interest. And then the engagement of investors is also clear in their role as report users. So they are driving disclosures from the companies that they invest in. And so these are 2 examples of global investor groups, so Pure Spring and Nature Action 100, that are asking for more disclosures on nature. What the TNFD has released, so for those that are not familiar with the Task Force on Nature-Related Financial Disclosures, we're a global market-led, science-based and government-backed initiative. And we've released a set of documents. So firstly, to support internal assessments, we've published our LEAP guidance, which I'll tell you about in a bit, which enables organizations to understand their nature-related dependencies, impacts, and then the risks and opportunities that arise from them. And that then enables them to take them into account internally in risk management, target setting, and strategy building before even getting to external reporting. And all of this is underpinned by metrics and data. So these are the TNFD's recommended disclosures. There are 14 in total, and they're based on the Task Force for Climate-Related Financial Disclosures, TCFD, if you're familiar with that. So it's to enable climate and nature integrated reporting. And so it's also consistent with the language and the approach of IFRS S1, and it's aligned with the Global Biodiversity Framework Target 15. It follows 4 pillars, which are governance, strategy, risk and impact management, and metrics and targets. And so these are the 14 recommended disclosures that organizations who adopt the TNFD would need to report on in their annual reports. And so this is just a slide to show the current nature-related corporate disclosure landscape as it is emerging alongside the climate one. So starting from the top, you can see that the Global Biodiversity Framework is the global policy targets, which can be compared to the Paris Agreement for climate. And then voluntary frameworks, such as TCFD and science-based targets for climate, and then TNFD and science-based targets network, are influenced by this. And then this influences further standards development and regulatory developments. So the TNFD is working closely with GRI and IFRS, for example. This is the LEAP approach that I mentioned. So it's really because early on TNFD understood that it needed to also publish guidance to help organizations understand their dependencies and impacts, and then the risks and opportunities for their organization that arise as a result of them. So this is really the how-to guidance on how to locate. Well, it has a 4-step process. First, you locate your interactions with nature. It also helps you prioritize, and then you evaluate the dependencies and impacts, and then you assess the risks and opportunities before preparing to then report, set a strategy, etc. So it's an internal framework. And this is the TNFD's metrics architecture. So as part of the TNFD's recommended disclosures, organizations are recommended to disclose on the metrics that they used to assess their nature-related issues. And so at the bottom, you have the core global metrics. There are 14 in total, and they're comparable across sectors. And this really enables then report users to compare and assess, say, investors, for example, across sectors. And then we also have a set of core sector metrics that are, so both those 2 pillars are recommended to be disclosed on a comply or explain basis. And the core sector metrics are really metrics that we think are very important at the sector level that are not covered by the core global metrics. And these are supported by a large number of additional metrics at the top, which are really to be used or disclosed on based on the organization's individual circumstances. That is an update from the TNFD's status reports released in the summer. And actually, as of yesterday, the numbers have increased in terms of adopters, but it was just to show the momentum. So this summer, there were 620 confirmed adopters with over 500 reports already published. And as of yesterday, there are 730 plus adopters. So yeah, and an interesting statistic is 78% have integrated climate and nature reporting. So in terms of the TNFD's publications focused on the ocean, the TNFD framework and guidance covers the ocean as part of the 4 realms of nature, but we just wanted to draw your attention on the more specific documents. So on the left, we published a discussion paper that just sets the scene and provides an overview of the availability of nature-related data, and also explains how the TNFD framework covers the ocean. And then on the right, we've also released sector-specific guidance, and they contain two main things. The first is additional considerations based on LEAP for sectors, because the TNFD got feedback early on that it was really important to know what happens in a sector based on LEAP. And so we have that's where we have the Marine Transportation and Cruise Lines guidance. Another interesting publication is the case study. So Wallenius Wilhelmsen actually has published a case study based on their TNFD LEAP assessment. This is just a quick slide to show, can't really read from here. Yeah, but to show how URN is covered in the TNFD Marine Transportation and Cruise Lines guidance. So it's highlighted at the beginning, so in prioritizing assessments, and then also recognized as an impact driver of nature. So because recognizing that ship noise frequencies overlap with marine mammal communications. It's also interestingly highlighted as a potential form of transition risk. So if URN were to be more regulated, and then also as an additional sector disclosure metrics to support external reporting, which I'll show you in a bit. So this is the additional disclosure metric, and it's really based on the ISO standards. And it's so organizations who choose to disclose on this additional metric would basically disclose on underwater radiated noise measurements based on the ISO standard. And this is just a quick slide on the Wallenius Wilhelmsen case study. And interestingly, the one key takeaway is actually that they recognize underwater radiated noise as a key impact driver on nature, and also as an elevated transition risk if it were to become more well regulated. Yeah, that's it.
Thank you very much, Blanche. Now I leave the floor to Emilio De Angelis from Cetena.
Thank you, Eric. Thank you for the invitation. My name is Emilio De Angelis. I am in charge of the Environment, Signatures and Monitoring business unit within Maritime Engineering and Research Department of Cetena. That is the research center of the Fincantieri Group. Today, I will talk to you about the main results of the project Saturn. That is a project funded under Horizon 2020, which ended last June. In the first slide, you can see a draft of the project structure and the list of partners. I don't want to go too much into details of that, but what I would like to point out is that this was quite a wide consortium with expertise ranging from biological sciences to engineering, and so allowing for a very comprehensive approach to the problem. The goal of this project was to study the underwater radiated noise, of course, radiated from ships. And today we focus on the work package 4, which aimed to demonstrate and assess a certain number of technical solutions for the mitigation of the effect of ship noise. Today I will only give you a very brief overview of these mitigation solutions. In particular because many of them will be presented in greater detail tomorrow by Mr. Johan Boschers, that will have a presentation tomorrow. And in the end of my presentation, I'll focus mainly on the cost-benefit analysis that we developed to start defining an objective approach for the evaluation and comparison among this solution and other solutions, not only in terms of underwater radiated noise, but also taking into account the energy efficiency and cost aspects. So, as you can see in the slide, we had two different reference ships in the project, a twin screw ferry, that in fact is a ship owned by BC Ferries, that is represented today here, and was commitment on the topic of URN is being crystal clear today, and a single screw tanker. So the first solution that I am presenting have been studied and applied to the twin screw ferries, and others have been studied for the tanker. So the mitigation solutions are a pump jet, a vertical axis propeller, also called the trochoidal propeller, the redesign of the propeller, and two different solutions based on air bubble injection. The first solution, the pump jet, was studied by Cetena together with CNR, Italian Research Council, and with the support of University of Genoa. The solution, in principle, consists in replacing a traditional propeller with a pump jet that is a sort of ducted propeller with the addition of stator blades. Obviously, everything designed and then sized correctly. The naval architect will forgive me if I keep it so simple, but so it was a multidisciplinary study based on one hand on a numerical simulation and other hand on a model scale test that have been carried out at the CNR experimental facility in Rome. The study has shown very good results in terms of noise reduction at medium frequency, up to about 10 dB, and also significant benefit in terms of propulsive efficiency and power consumption. This improvement varying depending on the operating condition. As you can see, there is a range in the slide, but at least 7% of improvement. That is really good results. The second solution studied by the project was studied by Naval Group together with its subsidiary Suriname, and is the trochoidal propeller, a particular type of propulsor in which the rotational axis of the propeller is, let me say, pseudo-vertical instead of longitudinal. Also in this case, it was an experimental numerical study with a model scale measurement that in this case has been carried out in a natural lake environment. In this case, let me say the technological maturity is a little bit lower with respect to other study solutions. I say that from the point of view of optimization to find the best compromise between efficiency and noise reduction. However, very good results have been obtained both from the point of view of efficiency and from the point of view of noise. Then we come to the mitigation solution studied by Marine. I'll discuss even quicker since, as I mentioned, they will be presented tomorrow. This solution includes a complete redesign of the propeller, of course, while still maintaining a traditional propeller, and two solutions based on air bubble injection, the so-called masker system, where air is injected around the hull to reduce noise coming from the machinery, and a prior system where air is injected into propeller disc to reduce cavitation noise. So I refer to tomorrow's presentation for these details, and I move on to describe the approach we followed for the cost-benefit analysis. The purpose was to evaluate and compare these and other solutions, and not only taking into account underwater radiated noise performance, but also taking into account energy efficiency and costs. So we start from the methodology for underwater radiated noise. First of all the radiated noise level have been calculated by each partner that study each mitigation solution. So once defined this reference operating condition, we obtain a spectrum for the baseline for the ship, for the baseline ship, and a spectrum for the, let me say, mitigated ship. And these underwater radiated noise data have been compared both as a spectra and as an overall value. As you can see in the slide, we calculated the difference among these values, and this difference has been assumed as a measure of the obtained improvement. We also applied a weighting function to these numbers, weighting function corresponding to different sensitivities of different marine species in order to take into account also this aspect. Then coming to energy efficiency, the approach was quite simple. In fact, we adopted the traditional indicators, energy efficiency design index and the carbon intensity indicator, and we calculated these values for the different configuration and compared. Okay, then we come to cost analysis. We started from a rough estimation of the shipbuilding cost that we set as baseline. And then we estimated the delta cost for the implementation of each mitigation solution. We also estimated the life cycle cost in terms of start investment, operating cost, like for instance maintenance and so on, operating costs related to fuel, and important also monetization of pollutant emissions. Then for each mitigation solution, we calculated, we compared with the baseline in terms of capex, of life cycle cost, and also in terms of net present value of life cycle cost, so the discounted cash flow of the life cycle cost. As a general comment, I'd say that these results are affected by let me say, non-negligible uncertainty due to some very rough estimation that we have to do, in particular on the evaluation of the industrialization cost of the mitigation solution. But we think that the obtained results are still significant. First, because we defined a methodology and we can use immediately this methodology as soon as accurate data from owner maybe becomes available. And second, because however we added the possibility to identify some significant trend. As you can see in this slide, you have the results of the calculation applied to the actual case study in the project. Let me say, what we see are two main things. The first thing is that it's possible to design a mitigation solution that combine underwater radiated noise reduction with efficiency improvement. And the second important thing is that we can reach the payback of the investment within the life of the ship. Of course, there is no a solution that is optimal. Each case has its best solution, but I think this is a really important first step in the direction of evaluate different solutions. So for more details, you can find everything in the website of the project, and in case you need to enter in contact with a specific partner, I'm more than happy to keep you in contact, put you in contact. Thank you.
Thank you, Emilio. Now, please welcome Dr. Lee Kingberg for the next presentation. Lee, the floor is yours.
Thank you, and thanks for this opportunity to meet with you all again and to talk to you. I'm not wearing my usual hat today. I'm actually presenting on behalf of the International Association of Ports and Harbors and their technical committee that is doing work on the Environmental Ship Index. So, no longer a ship operator or owner, but speaking on behalf of that committee. And we are developing an underwater radiated noise module for the ESI program. Now, how many of you are familiar with ESI? It's about half. Okay, I'll give you just a very brief tutorial on that. ESI has become the industry benchmark, the global data system. You enroll, the ship owner or operator enrolls their vessel once and puts in their data every 6 months or whatever the current periodicity is, and does not have to enroll with every single port's program. So that's the strength of ESI. It was started in 2011. It has now been recognized as that global center of expertise and that global rating system for the environmental performance. It really started initially with air emissions. So let's take a look at ESI at a glance. It is a voluntary system. You choose to enroll your vessels, and then ports choose whether or not to base some sort of program, recognition of some sort, or other programs based on ESI scores. But the scores are identical across the world. Now, they may be used very differently by different ports, and some ports may combine ESI with a vessel speed reduction program or with other types of programs. It's flexible for those incentive providers, and it is free of charge to those ports who are members of IAPH. And there is a data tool for taking in all of this data and managing it and handling it. Now and this slide was made a few months ago, at which point there were 6,132 ships enrolled in ESI. As of the 1st of October, it was 6,400 individual ships enrolled and 75 incentive providers. So many of them are port authorities, but there may be other kinds of incentive providers. So again, it is the industry benchmark, and as you can see, there are very active incentive providers around the world. And here's the distribution of the participating ships. It's heavily weighted towards container ships, but you also have good representation by tankers, bulk carriers, oil tankers, and other general cargo ships. Now let's talk about how ESI has evolved. As I mentioned, it started out with a core of air emissions, NOx and SOx in particular. There was an above-water noise module developed for ESI, and there was an ESI at berth. Now, after January 1st, 2027, asterisk date to be finalized after the board sees all of this, so this is a work in progress, but after January 1st of 2027, the plan is to add an ESI noise, underwater radiated noise module. Now, what does that module look like? And we're trying to keep this thing very straightforward because there's enough complexity in all the other indices that we're having to calculate and deal with these days. So let me go through that. It's got 4 components. There's a quiet vessel class notation. And by the way, the total points that you can score on ESI is 100 points. Even if you score more than that, or could have scored more than that with the total of the different ones, 100 is the max. And if you have a quiet vessel class notation, you get 50 points. A participation in vessel speed reduction programs, like some of the ones we've heard discussed earlier today, 15 points. Technologies that reduce underwater radiated noise, and there's a range, but 25 points maximum possible. And then underwater radiated noise reduction plan aligned with the circular provided by IMO is another 20 points. And yes, those do not add up to 100 points, but it's capped at 100 points. And it'd be a very rare vessel that would actually have more than all of this. So let me look at each of these and how they've tried to structure this. First of all, does the vessel have class notation? This is a pretty simple yes-no question. And if you have yes, you get 50 points towards your score. And as you know, there are a number of different class notations out there, all of them different. And I won't go down that pathway since I know there are people in this room who are more expert than I am about how that works. But think about a ship owner that has multiple classes and how they manage that. Now, the second one is the underwater radiated noise. Did the vessel participate in any voluntary vessel speed reduction programs? Again, yes or no, but they've got points depending on how many calls you make or how many activities you actually have where you actually slowed your vessel down because of the Blue Whales and Blue Skies program or because of the ECHO program. So you can actually get scores accumulating if you call Vancouver and call, say, the Quiet Sound program when they start participating, or other things like the Blue Whales and Blue Skies program in Southern California. And there's a list shown there of some of the voluntary VSR programs that are out there, and that list, of course, is growing. One thing that's going to be a challenge there again for the ship owners is how do you keep track of all the different things you're participating in if you're really committed to this kind of thing? Now the next is, does the vessel have technologies that improve wake flow or reduce cavitation? And this list of example technologies was provided by the Vancouver Fraser Port Authority and the ECHO program, since they already do have points in some of their programs, or already have scoring in some of their programs that give you discounts on harbor dues related to whether or not you have some of these technologies. And the total here is capped at 25 points. So if you put all of that stuff on there, you wouldn't get more than 25 points. Okay, then you have the underwater radiated noise reduction management plan aligned with the IMO guidelines. Again, yes, no, do you have the plan? Is it in place? 20 points if yes. So that one's pretty straightforward. Okay, so that's how they're planning to put it together. They have agreed on what this looks like. For a while, they tried to actually incorporate it into the main ESI index, and it just got too complicated. So they've set it up as a separate module. It's going to the board later this month for approval. So again, this is a work in progress, and this is, you're getting a latest breaking news update here on the program. But if you want to know more about ESI, there are all kinds of publications here on the IAPH website. You can also contact Manfred Lebmeyer of Hamburg, Port of Hamburg, is on the ESI transition team, which is working to upgrade the whole ESI program. And so he's a great contact, or you can contact the ESI administration or visit the website. And thank you for your attention.
Thank you very much, Dr. Kinbeck. John, the floor is yours. Slide less.
Middle. It's different up here. Okay. Yeah, I got the odd mic. Okay. Well, look, thank you, Michelle, Eric, and Michael for the invitation, and I'm very pleased to be here. And it's it's great to see so many familiar and friendly faces. I haven't got any slides. You know, the last lot of training I did on presentations, they said, you know, like people, I don't know whether this applies to you, but they said people, they can't read slides and listen to you at the same time. So if you want them to listen, it's better you have no slides. I don't know whether that's true or not, but anyway, I've been giving it a go. So anyway, so thank you. I came to the IMO for the first time, just so a little bit of context. I came to the IMO for the first time in 1990 as a student, and then I came back a couple of years later as a delegate, and I've been coming ever since. You maybe think, surely he has better things to do, but it actually hasn't been that bad. But it's a long perspective, which I think does help because things move quite slowly here. So anyway, I have not really worked extensively on underwater radiated noise, but I've worked a lot, particularly in the last 15 years, on the greenhouse gas side of things, and in particular, the energy efficiency side of things. And of course, this workshop is set up the way it is because there's a clear link between the two. And that link is really down to the fact that, if you make ships more efficient, and in particular, if you slow them down, that's a potent way of reducing underwater radiated noise. And this is, of course, a theme from all of the presentations so far, and I'm sure will continue to be one tomorrow. So that's really the link. That's why the two things are being looked at together. And I'm going to talk a little bit about the energy efficiency side of it, what's happening with the CII, but also, the climate discussions more broadly and how they bear on energy efficiency and therefore on underwater radiated noise. So what's at stake? Well, There's been a couple of recent studies, within the last sort of few weeks. One from the World Bank that shows that there are, between now and 2030, so this is the IMO's, the IMO's closest goal for climate issues. Between now and 2030, there are energy efficiency measures that are are negative, zero, or low cost that could deliver a 40% reduction in emissions by 2030. So that's not the 40% that we heard earlier from Roel, which was an improvement in the carbon intensity of shipping. And you remember that you saw his graphs, that was improving, but the emissions were still going up. But the World Bank study shows that by 2030, there are energy efficiency measures out there that would reduce absolute emissions by 40% by 2030. That's a big number and a big goal. The other study is from UCL, and it's a very clever one. It used the AIS data to look at ships that were arriving too early and sitting outside their ports. It took the amount of time that they sat at anchor and reallocated it to the journey, slowing the ships down, and did the calculation to work out what emission reductions would be. So this is just getting ships to the port at the right moment for them to go straight in instead of sitting outside. So don't steam fast and wait, steam at the right speed and go straight in. And, well, depending on ship type, between 10 and 25% reduction in emissions for those vessels. Something as simple as that. So this, these benefits, of course, the second study, that's all about speed. The first study, it's a large part about speed. So the CII, it's all about removing non-market barriers. So it's about incentivizing the kind of activities that aren't happening that are resulting in these emission reductions, these emission reductions that aren't being realized either through speed or other measures. So it's about realizing the low-hanging fruit. It's about realizing low and zero cost changes in activity that will bring about these emissions. It's also about, it's not just about the ship. I think this is absolutely critical. It's about the ship in its system. There's a lot of, complaints from various quarters that, my ship's got a terrible CII score, but I know it's really efficient. The intention of the CII was never to allow that kind of comparison between vessels. What it does allow you to do is compare two vessels that are operating on the same trade. So in the same part of the world doing roughly the same job. You can compare those and it works perfectly well in doing that. So we've got all of these these potential reduction emissions, but they're not being delivered. So these are, we've got all of the IMO measures in place, but we still have these massive unrealized emission reductions. Now, the CII probably the only option that we have for realizing a lot of these. But before I go to the CII, I want to say a few things, and I'm sorry about this because it's a little bit like a death in the family, I think, but there is the net zero framework to consider as well. What happened a couple of weeks ago, deeply regrettable. Everything will be affected by it, including the CII, and it's introduced the level of uncertainty, I think, into the whole, into the industry and the IMO's response to climate issues. And it kind of has an impact on, well, it will certainly have an impact on energy efficiency, and therefore will also likely have an impact on underwater radiated noise. There's a tremendous uncertainty, but we don't know whether the net zero framework will be adopted in the autumn of next year or whether it will be delayed again. It's a huge question mark over all of this. It's important because the proposals for reform of the CII around making it an energy metric assumed that fuels would be handled by a GFS under the net zero framework. So that's one area where it's created uncertainty. It's also, the net zero framework is also the way in which we were dealing with the issues of just and equitable transition. And if you look at, input to the discussions on the CII at the moment, there are parts of the world that are very concerned about the CII and how it might negatively impact them. And of course, you know, the fund for under the net zero framework was one way in which that could have been addressed, and that, you know, that uncertainty, we don't know whether it's going to be there or not. It's very difficult. There's another area around wind, actually, which of course, you know, is also in the game for reducing underwater noise. Wind, the intention, of course, is that wind will be treated a bit like fuels. So the lack of a net zero framework, you know, helping to incentivize wind as a primary source of, you know, not an energy efficiency tool, but as a primary source of power, that's also, you know, been delayed and is another area of uncertainty. So the other thing that's happened since you last met, as this, you know, the first workshop, is the kind of the changing of the arrangements for the review of the CII. So you know, when we last spoke, it was supposed to be completed pretty much, or at least by the 1st of January 2026. That didn't happen. The CII has been split into two phases. The first part of it is now complete, although the amendments associated with it are sat in that bundle of amendments that didn't get adopted at the last, at the extraordinary session, you know, a few weeks ago. But in there, you know, some progress was made. There was some new targets for the years out to 2030 that didn't exist previously. But those targets are weak. Very similar to the business as usual creep in improvements in energy efficiency that we've been seeing, you know, pretty much, you know, all along. There was no improvement in the enforcement situation, and of course it still has a fuels component in it, rather than moving purely to energy. So, you know, generally speaking, phase one of the CII review has not really delivered for energy efficiency. It hasn't really delivered for underwater radiated noise. But there are some good things. Some of the proposals for reducing the scope of it were rejected. Although in phase two, which starts at MEPC 84 and finishes, well, in theory, a maximum of 2 years later, we're going to be returning to some of these issues. And, you know, we still have those potential emission reductions that I was talking about from those studies at the beginning, you know, and we need to, you know, at phase two, we need to revise the CII to make it the kind of energy efficiency powerhouse that can make those emission reductions real. But to do that, it needs to be much, much more ambitious. So we need reduction factors that are much more in line with the IMO targets. We still need that shift to an energy metric rather than a grams of CO2 per tonne nautical mile metric. And of course, this is a little bit uncertain because, as I said, the net zero framework, you know, the delay in the net zero framework means we don't really know whether fuels is going to be dealt with there, or, well, you know, whether it's going to be dealt with in the autumn of next year or later. So there's a kind of, you know, there's, as I say, there's lots of uncertainty. We also, so there's a kind of, I think the net zero framework is, a kind of fog has descended, you know, over the CII revision process as well, because we're not quite sure what it is acting, you know, it's a companion piece to the net zero framework, but we don't really know what the net zero framework is going to look like or when it's going to be there now. So there is some uncertainty about phase two. But to sum up, you know, there is, as I say, there's still a massive opportunity for emission reductions demonstrated by those studies. The CII is our best bet. There's also going to be, you know, I think one of the things that's happened with the confusion around the net zero framework is that people are looking to see where they might get emission reductions, other places that they might get emission reductions. And at a global level, there aren't many other options. So there's going to be, I think, increasing attention on the CII for that. But it needs to, the levels of ambition need to be up, transparency needs to be improved, and we have to fix the kind of enforcement problem. And my last comment, really, sorry, I'm probably a minute over or two, is that, well, the CII is extremely important. At the moment, there's no other way of delivering those massive emission reductions that we both need and that the studies show are possible. But there are lots of uncertainties. And I think, you know, that fog is not going to clear soon. And I think it also raises a question, and I'll finish with this, about whether or not those who are concerned and want to make progress on underwater radiated noise, whether or not they are wise relying too much on that other energy efficiency process to deliver their underwater noise reductions. Thank you.
Thank you. Thank you, John, and thank you to all the presenters for your excellent presentation. Thank you very much. And a big round of applause for our last presenters of the day. Before the questions, please. And now it's time for you to interact with these presenters. Yes?
So just to clarify, so we're going to do a quick our 20-minute Q&A on this panel specifically, and then we're going to go into a broader plenary. So just to give you the context of how this will flow for the rest of the day.
Thank you. After. Yes, sir.
Hello, my name is Daniel Andres. I am the fleet manager of Navios South American Logistics based in Argentina. My question is to John, please. Regarding the CIE, do you think it would be better to take into account the cargo carried out by the ship to calculation the CII? Is your opinion?
Yeah. Do you mean the actual cargo?
Yes.
Rather than using a proxy like tonnage.
Yes.
Well, yeah. I mean, this is it would make a lot of sense. It would give you something more accurate. Of course, that information has always been held quite closely to the industry's chest, so it's not been available. But yes, yeah, why not?
Yes, please.
Name is Kevin Reynolds with Gloston, Naval Architects out of the U.S. Ms. Kindberg, I always appreciate your presentations, and you have such a broad perspective, and you think about these things so deeply. If I'm a ship owner and I get my 100 points, how do we as an industry leverage that 100 points the most effectively to make the best difference? How do we motivate my peers to also get that 100 points? What incentive structures do you think will be most effective?
And this is asking me to speak in my past history as well. Again, programs that are clear and where the incentives are clearly tied to the behaviors are those most likely to succeed. The more complex they get, the harder it is to make a case to even participate. So that's why things like this, the ESI modification for URN that I just talked about, I think that's why I like the simplicity of what they're doing. But remember, they're also talking about having to get that class notation. And that class notation does vary by every body issuing that notation. So I think there's an opportunity there that we could come up with some alignment there. ESI, I think, is a terrific. When I first heard about it, I thought they were dreaming. You know, we've got to sign up for this and this and this and this. But once we started seeing more ports starting to adopt it, then it became easier to make a case to have someone put in the data, gather that data and put it in. So again, you can see where I'm going with this, the keep it simple principle, but have it be something that is unified globally. So if I move a vessel from here to here, I don't have to go through all kinds of new registrations and so forth, but it's a global system. And I think there's some lessons to be learned there. Hopefully I answered your question. Sort of. Okay.
Thank you very much. Yes, sir.
Hi, Dave Williams at FedNav. I'm a naval architect working for a ship owner, so excuse my perhaps some ignorance of the commercial impact, although I have an idea. The question's for John. You said 40% of shipping emissions could be reduced by the just-in-time arrival. Was it a big number?
Yeah, sorry, I was two studies. The World Bank study shows a 40% reduction in absolute emissions by 2030 possible through all energy efficiency measures at low or zero cost. So that's all measures, both speed and technical stuff. The UCL study, which was just focused on speed and what is often referred to as just-in-time arrival, that was 10 to 25% just for those vessels, depending on the type of vessel. I mean, for some they spend more time hanging around outside port than others.
Which is a huge number. So what do you think, because as the ship owner, we have no control over the time at which the ship is required to arrive at the port. That is dictated by the cargo interest, and if we're late, we have to pay demurrage. So as the ship owner has to arrive at that port maybe 2 weeks before it's required. And so the entire supply chain needs to take some responsibility in this, the cargo interest, the ports. So if there is a 10 to 20 something % reduction possibility, whilst the naval architects are busy trying to squeeze a few percentages of energy efficiency out of their ships with wind assist and other measures, what measures can the IMO take, or perhaps another UN organisation, to sort out this structural issue with the supply chain?
Well, it's funny, I've got the answer to that. It needs a fully functioning, ambitious CII that's transparent and has proper penalties when you breach the CII. And you're right, it's not. The thing is that I think the problem with the CII is people imagine it's all about the ship, and it's not. The non-market barriers, the failures that the CII is trying to address, but is hobbled because it doesn't have the right ambition and it doesn't have the right penalties. But what it's trying to address are exactly those contractual arrangements between ships and ports, between ships and charterers, and all the others, that web of interconnections. And of course, you have to bear down at some point in that system. And if the penalties are there, then the ship owners will, they will be forced to enter into talks with all the other players in order to make that system work. I mean, it's not rocket science.
But the cargo interests, certainly in the bulk industry, the vast majority don't even know what CII is.
I'm sure they'd find out quite quickly if it was costing them not to know what CII is and not to abide by the requirements of the CII to reduce emissions.
But surely there's a mechanism outside of CII to address the full supply chain. So your expectation is that the ship owner has to, by means of some escalated CII with more teeth, is going to fix the entire supply chain problem.
I think it's a much more nuanced approach than that. I mean, we see it. I think this is where it comes down to what is the role of member states, of the countries, what is the role of port state control, what is the role of the ports, what is the role of the companies, right? I mean, I know I can only speak to obviously what we're doing in Canada, but we've established a whole supply chain office within our transport department to look at these exact kinds of questions. How do we address the larger supply chain from the ship to the port to the rail to the, and where it's going. And so an integrated approach is important. I think you're hitting on a very important point. And, establishing the right tables and raising these issues so that you have the right people around the table. I know we encountered this a lot on the east coast of Canada, where we put in place slowdowns for the purposes of ship strike, to address ship strike. And there became a need to have that conversation with the cargo owners, because the shippers were saying, well, if I slow down, I'm going to get, dinged because I'm going to miss my port of call, and then I'm going to miss this one window of opportunity that we have to, provide resupply for this entire community, right? So we had to have those conversations. So I think it's an important point to be aware of kind of what is the role that all the different players play within this, but also for them to take some responsibility. So how do we do that? I think it's a really good question, and but I think it's one that we have to be aware of and think about.
Yeah, maybe we'll
Can I just,
go on.
Yeah, no. Well, just very briefly, I hope you didn't think I was being dismissive of the complexity of it, because that is the whole point. If we had to go after every single one of those, with a bespoke measure or prompt or incentive, we would never get there. So the point is that the ship owner, who are very, very well represented in the IMO, are our entry point for affecting through the CII, you know, if it's functioning properly and it has the right incentives and the right penalties and all the rest, is the entry point to that whole system. And you know, if it it would immediately make financial sense for them to knuckle down, have conversations, develop new approaches. Because you know, if we're going to crack this problem, you know, climate change, it's pretty serious. Things are going to have, business is going to have to be done differently. It's not just going to be a kind of just like the same thing. You know,
sorry, but again, the ports. Can there not be some regulation to de-incentivize ports from having empty berths or from clogging up anchorages? It has to work on. You can't have all on the ship owner. There should be a focus on the ports and on the supply chain as a whole, surely.
So I think the main point is it's an opportunity to engage with the ship owners and the cargo holders and the port. I don't think anyone's saying it's your job alone. It's not your job, David. Don't worry. I think it's an opportunity to explore how do we better integrate that whole conversation. Yeah.
Thank you, Gent. Chris.
Thank you, Chair. First, I agree absolutely with the points of the delegate on my right. Just-in-time systems potentially are very complex because of the value chain. And if you think about it, the stakeholders in the port, the pilot authority, the cargo handlers, the rail system, etc., it's a very complicated mix. And there's a very difficult contractual issue as well. But there is another solution on the horizon. There's a research project called Blue Visby, blue as in the colour, second name VISBY. And they've got their own website. And what they have done, it's quite a novel approach to just-in-time. To a large extent, they've ignored the ports. And they've just said, what we'll try and do is come up with a system which will produce a flow of ships into these ports which matches their historical capacity. And we will also configure the contracts to share the costs and the benefits of that system. And you know, they've done their own projections of fuel saving and underwater radiated noise reduction. I think Russell behind us, he did that assessment on the underwater radiated noise. And it is very impressive. But the project is different because it grasps those two nettles. Firstly, it deals with the problem of the stakeholders in the ports by effectively ignoring them. And it deals with the problem of the contracts. One thing which gives me confidence that this project is different to others is that it has BIMCO within the consortium. And of course, BIMCO, their forte is writing contracts for shipping, contract pro formas. So you know, anyone with an interest in just-in-time, I would recommend having a look at Blue Visby. On the wider issue of speed reduction, I would urge caution. There is a safety issue there. If we depower and slow ships down too much, then in bad weather it becomes a safety issue. And also, taken to an extreme, it can be a capacity issue as well. If we slow down too much, we need to build additional ships to cover that loss in capacity. So there is a limit. But thank you.
I mean, on that point, I mean, there's no, you know, we're a long way off getting to that stage. And of course, the UCL study I was talking about, there were no capacity issues there. That was just about utilising the time, you know, most efficiently. But the Blue Visby, that's exactly the kind of initiative. And, you know, that's happening with fairly modest pressure from the CII. If that pressure was greater, initiatives like that would proliferate and the problem would, you know, in the end, it would solve itself. So it's a kind of, you're sort of making my point for me. You know, these kind of solutions to what are complicated problems, you know, at the moment, there's no incentive to fix it. You know, we have all of these kind of zero and low cost options that are just sat there not being exploited. There needs to be a regulatory pressure that makes stakeholders get together, you know, BIMCO and others, to go, okay, actually, this is a problem that needs fixing. Let's do it. But you know, without a strong CII bearing down in a regulatory way, you know, that will not happen, and it won't happen. You know, there'll be niche, there'll be little. You know, it needs to happen at an industry-wide level because that's where you get those, you know, those big emission reductions that we see in the World Bank study.
Thank you.
Just for assurance, I don't think we would ever do a measure that was unsafe. And I think that's underlying anything on any measure that we're talking about in shipping. There's always the assessment of the safety and navigational safety and the risks. Just want to make sure that you know that, Chris.
That's not even discussed.
That's not even discussed.
Antilia, and you have
Yeah, thank you. Just a few comments about this integrated approach. Of course, this is, I think it's the key. And as you mentioned, there is this VSB solution, but in fact, there is two projects, Horizon Europe project, two sister projects that are already funded by the EU on the just-in-time implementation with COSCO, with many actors on this, with ports like Antwerp, Bruges, etc., the leaders of the market. And this is also something that we will be integrated in our new indicator on ports as a good practices. So the commitment to do, I say, the good sense, it's something that is also a way to avoid expenses. So we talk about just-in-time efficiency for the car, but it's also a cost-effective measure. And I know that you are really attentive to that. Thanks.
Indeed. A very last question to the presenters, and then we will have a break for some technical issues before the plenary discussion.
By the way, I'm not Saudi Arabia, but this question for Lee Kahnberg, and about the ESI. So just recently, I spoke with an environmental officer of a big port. I won't mention which port it was, and then among others, asked about noise measures. And then this person said, yeah, that's what we do, because for the people living in the port area, that's a nuisance. I said, no, I mean underwater noise. Underwater noise. Oh, well, yes, well, oh, tell me more about that. So then I thought, well, maybe there's some awareness raising to do among the port communities. And but I was just wondering if this is really sort of already starting to get embedded in the ports, or is it still at a higher level with the IAPH?
Well, the IAPH is made up of those ports. But I think if you look back 10 years and taking the long view, we've really come a long way in terms of both just the awareness and the understanding of the technical factors underlying underwater noise. But there's still a long way to go. So you made my last question easy. Thank you.
Thank you. I have to close this Q&A session for the presenter and to thank again those presenters.
So we're just going to take 2 minutes for technical issue, but if we can also ask all of the panelists from today, between this front row, would everybody fit, you think?
Yeah.
For the plenary? To come to the front row? So those who have presented, just because we're going to, for the plenary discussion, we're going to lob some questions at all the panelists.
So you want us to just...
Yeah, there's enough time. There's enough time for a toilet break. To turn the mics off. There's enough time for a toilet break, so we'll reconvene at. We'll take 10 minutes at 5:05. Thank you.
All right. Now we get to talk more, but get to hear from you. Let's bring this all together. I'm going to turn it over to Eric to start. We thought what we'd do is we'd give a little bit of kind of what our takeaways, what we've heard, throw a question or two at our panelists from a theme 1 and theme 2 perspective, and then open the floor to questions and comments and discussion with the rest of the participants.
Thank you, Michelle. So first, a statement where I think we won't have any debate. We have had amazing presentations today. And not only today, but if we look back to the first workshop, it's amazing progress as well. We have had presentations that have covered these 2 themes that we were talking about, and 2 of the 4 themes that drive our workshop, the technical solutions and their evaluation with regard to energy efficiency and their co-benefit on URN, and various integrated URN management approaches and incentives schemes. And we have also much appreciated that quantitative model and full-scale assessment have been presented, and I would say more broadly carried out, because before it was a question of, I should do a model test, and I hope I would do a full-scale. And now we have had 6 or 7 case studies with more than that. Some of the presentation included more case studies in it. Full-scale quantitative results. So we are not anymore at the stage of asking ourselves, how can I do this assessment? We are at the stage of discussing still the cost. This is one of the points, and optimizing that cost. But overall, it's very promising. And nevertheless, I'm not a ship owner, but seeing 5 to 40% fuel savings together with 2, 3 to 16 decibel gains reduction. What would prevent me, if I were a ship owner, to replicate what I have seen? Just, it's so obvious that the first immediate action would be to replicate before maybe thinking about combining these solutions that we have seen sometimes separated. To improve even more the efficiency, and so the fuel savings, and so my return on investment. So this is my first question to the audience, to you and to the panelists. What would you say would prevent this uptake with these figures that are, to me, very self-explanatory to replicate and to engage?
I can start. Policies. If you put a slow down everywhere, ALS is not going on, and basically it doesn't make sense for me to invest on that solution, right? As a ship owner, I'm not a ship owner again, but putting the ALS system that I put in the screen means a lot of investment, and it needs to operate only at certain conditions. So if we put a slowdown everywhere, for the benefit of ship strikes, which is a great thing, obviously there's no question about it, then my system doesn't work, and then I don't take that on. So definitely, I think that's a very important thing to discuss, because it really depends on the type of vessel and service that is doing, and policies that different parts of the world may implement.
And before anyone else jumps in, I think I would just, kind of add to this and a little bit to Eric's reflection is, I mean, you raise a good point, right? But I think what we've heard today, though, is various perspectives from various perspectives, from different types of operators, right? So we've heard that in some places, okay, we know that slowing down is a really good approach. But we also know that you can't slow down everywhere. You just can't. There's some places where we can't slow down, right? But you might still have sensitive ecosystems in those places. So from a safety perspective, to Chris's point, you can't slow down. So we do need to look at the technical, right? So it's a valid point. We're not slowing down everywhere. We use technology. We've heard from some research. Everyone's research is looking at it from a certain perspective and a certain lens.
But I think we're beyond that, yes or no. It's not this or that, right? It's what are the nuances in what we're hearing, and how do we kind of integrate that into kind of figuring out a way forward that optimizes, to use that word, right? The co-benefits, because it's not that there's no co-benefits. There's certain situations where there's not a co-benefit. There's certain situations where there's a trade-off. We've heard that, but that doesn't mean that there aren't situations where there are co-benefits. So what are those, and how do we, incentivize those? And we've heard some of those ideas, right? So how do we kind of take everything we've heard and try to piece this together into a, where are those opportunities, and what would you need to kind of continue to invest in those ideas and that work? Where do we still see those holes, and where do we see those opportunities? And Tia?
I'm not a ship owner either, but many times you say return of investment, but first there is investment. And we know that in that period, I think, some ship owners have trouble with economy, and we know that there is much more concentration, of course. Also, so I think that the first type is investment, and under what knowing, and I look at you, Blanche, and investment, there is a need of raising awareness on this topic. You mean about ports, ILCO? But I think that we also need to raise awareness towards investors, banks, that is not only, green is not only the carb, it's also other topics. And there is on other topics co-benefits on the carbs. I think that I'm already on solution, but I think that here there is a point to raise on the fact that URN, we all know together here what it means. But if we go outside of this room, I'm not sure that everybody knows about it. Second aspect is about ferry sectors. You can slow down, but when you have a daily route and many travels in the same day, if you're going slow, maybe you are not able to make like 5 travel per day between Marseille and Corsica. You make 4 because they are longer. So there is here something to manage on the way you decide to make longer travel, and maybe one travel less, and how you make it in your own business model. And maybe a last opportunity, it's green corridor. We all talk about green corridors, but when we mean green corridors, we mean decarb, EU fluid alternatives, and most of the time we don't talk about slow steaming, or we don't talk about acoustic aspect or strike. So I think that when we mean green corridor, this acceptance of this concept, or maybe we should use blue corridor as another concept, but is very restrictive at the end, because it's really focused on just decarbonization. That's my 2 cents, I would say.
Chris?
Oh, sorry. Thank you, Chair. I'm going to Eric's question first. What would stop ship owners achieving similar things? For me, I think really key is the measurement. At the moment, it's really difficult and expensive for a ship owner to measure the baseline, the URN baseline of a ship, unless you've got a local autonomous facility. So, I think developing the technology, developing the standards. I think ISO are in the very early stages of looking at developing a standard for autonomous URN facilities. That could be key. But, let's remain technology neutral as well. The idea of the drones and the onboard measurement, perhaps that could be part of the solution as well. But we, like anything in life, we can only manage it if we can measure it. And at the moment, it's just too difficult and too expensive to measure at industrial scale globally. And then turning the question around, what could we do to facilitate these gains? I would go back to the VARD report, the excellent table in the back of the VARD report. We quote from that so many times, when we're trying to demonstrate the co-benefits. And I would simply suggest, let's have a living copy of that. Let's keep updating it adding to it. And there's some excellent data today from Lloyd's. And I know the Port of Vancouver recently, they've done some work updating their incentive scheme, and they've got some more accurate data for energy efficiency devices and what they do to noise. So yeah, I would suggest let's keep that live and update it and use it.
Can I ask a follow-up?
Yeah.
Quickly. And just on your point of measurement, because I think what we also heard is that you have different measurement needs depending on different decision points. So you're speaking specifically about baseline, but it seems that we also have opportunities to look at those different measurement techniques for, if you're you already have the ship, you've implemented a new technology, there might be a different way to be able to measure those things. So kind of also understanding what those needs are and what we've kind of heard a little bit today about the drone, about right? There seems to be different, there's different ways of approaching that maybe we can think about more, not creatively, is that maybe not the right word, but more wholesomely or holistically about, what those different tools might be that we need for the different decision points when we're doing the measurement.
Yeah, thanks, Michelle. I think I would agree with you. I think previously we've thought of baselining as something we do every few years, but ideally if we could do it much more frequently than that, at low cost, easily, without diverting the ship, that would be great. Yeah, thank you.
You give me the ball, so I take it, Chris, but it exists. It's not worldwide spread, but it exists, as you mentioned, in Vancouver, with a lot of ships that have a lot of configuration tested, speed, loading conditions, and it exists from the Payako project offshore Genoa, Fos-sur-Mer, where 700 ships signature have been validated, but still we are waiting for more ship owners to say, oh, what has been measured? By the way, can you inform me? And we have some people here responsible of this part of the project that you can discuss with. And still looks like there is a buyer, because we are not talking about the availability. It is available. We are not talking about the cost. There is a Vanessa nodding. There is the script measurement station as well. So there is still maybe one thing that is not admitted or shared that is still a barrier that we may not have identified. Raising awareness might be that one again and again. Maybe we are too much biased because we are in the topic on a daily basis and we don't realize that enough. But you and BIMCO and others have so broadly disseminated the word, I can't conclude that it's not known in the ship owner world anymore. But maybe I'm too optimistic, and we will carry on raising awareness, but it exists already, and we will multiply. Vanessa?
Can you hear me? Okay, hi, I'm Vanessa from Scripps, and just echoing that from Eric, that I think that there are so many autonomous instruments in the water that I'm not even sure if everyone here knows about, and it's our fault too for not maybe sharing where those currently deployed stations are so that ship owners can go drive over them, and they might not have to divert their paths with where they are already. So having some entity compile those data sets for an international data set, and I know that it would maybe have to be anonymized so that not everyone can see everyone's information if they don't want that, but having like an international database or even just a map of what's currently deployed might be helpful so that operators or captains can reach out if they want their data, but there are so many instruments out there.
Per, you wanted to...
Yeah, Per Andersen from Lloyd's Register. I'm just going back to the topic of slowdown, because it's been a big topic. Now I understand there was huge gains to be obtained, but just from listening to your presentation, John, it seems like the problem is it's not in your own control. You're depending on a lot of parties if you want to gain those really big things or big energy savings. So that is one complicating thing of this. But I just want to highlight something about slowdowns, because it seems to be kind of a miracle solution to underwater noise. But I know there are several voluntary slowdown principles or schemes going on. And I know also the EU is now enforcing mandatory rules. And one of the things that I know people are looking at is having a slowdown as one of the measures to control these limits. But the problem is if you make it mandatory slowdown for all ships, then you risk taking away the incentive of ship owners of making their ships quiet. Because why should a ship owner spend money on quieting their ships if everyone is slowed down to the same speed? So I think the important thing is that there should be an incentive for people with quieter ships when you make a slowdown scheme or something like that. Because otherwise we risk taking away the motivation from ship owners to mitigate noise from ships technically. So I don't know. I mean, we are working on it in the low noise project together with BV and so on. But I don't have the clear idea of this. But I just see a serious risk in using slowdown as the main thing, because we really risk moving this motivation for making ships technically quieter. So my idea would be we have to have some kind of incentive for quiet ships when we do this kind of thing, if we do it.
And I think, the whole impetus of coming to the IMO was to talk about the design, right? We can all implement slowdowns in our own waters. Like, we don't have to come to the IMO for that. We can talk about it and talk about how important it is and how effective it is. But at the end of the day, we can't do slowdowns everywhere, and not only for that reason, but it literally is not possible in some places from the safety perspective, or you can't get the benefits you would normally. So I think we have to look at the design aspects of it. It's got to be both. There's operational approaches, but there are design. We've heard them. We've heard some amazing, developments in terms of, design features that are already being implemented. I mean, 16 dB from BC Ferries, that's just remarkable, right? So I think we have to be looking at all of the options, because it's not a one-size-fits-all. Sorry, John.
Yeah, no, that's fine. I mean, but I agree entirely. And I'm not, we don't want to disincentivize that technical stuff at all. But also, I'm not talking about, rather oddly, when the CII was originally negotiated, the civil society group, NGO, environmental NGOs, they had an alternative proposal, which was regulated speed limits. And of course, it didn't win out. And now we have the CII. So, what I'm proposing is the CII, because it's designed, for as an energy efficiency tool to drive down CO2 emissions. Of course, the noise side of it is a co-benefit, and it's also an operational tool, not a design one. So it still leaves plenty open. And the intention is certainly not to stifle the development of quieter ships. It's just like, okay, I'm making a lot of the speed because there's such a close connection between speed and emission reductions, CO2 emission reductions, and noise. And we've got this tool, and it's being revised right now. So it's kind of like, that's where the motivation is coming from. But it's like Michelle says, it's a package of things.
Gavin and Goran, and then Matteos.
Yeah, thank you. So Gavin Allwright, the Secretary General of the International Windship Association. I just want to make a couple of points. One is that you don't necessarily have to slow down. If you put wind onto a vessel, you can maintain your speed. You can even go faster with far, far less power going through your propellers. So that's one thing. And when you do plug a free, zero emissions, zero cost energy source and zero noise energy source into this matrix, that starts to change some of the dynamics that we're talking about. One other thing, I've just come from the World Ocean Council Sustainable Ocean Summit over in Barcelona, and yesterday we're talking about sequestering carbon into the ocean, and a lot of finance, a lot of investment is going into that, or credits. One thing that I haven't heard here is about the contribution of noise into the disruption of the phytoplankton and zooplankton life cycle, which is a massive, massive way that the ocean sequesters carbon for millennia. We often talk about the large fauna in the oceans, but we're not hearing about this cycle. Now, what they're trying to do with these sequestering programs, these artificial sequestering programs, is they're creating a price for that carbon sequestering. Now, if we can quantify the amount of disruption that underwater radiated noise and, of course, acidity is causing, stopping those zooplankton from producing their lime-scale shells, etc., and sequestering that carbon, that would be a way to actually monetize this. And I'm wondering, is there any work going on in that, in the underwater radiated noise? And if not, this could be an area that we could see as a way to actually incentivize ship owners to claim carbon credits from their action too.
Thank you, Gavin. We were supposed in the Saturn project to include zooplankton studies. I'm not sure. I have my colleagues here. Federica, maybe you.
We're not involved in such studies, but I know there are a few studies going on in Norway and other Scandinavian countries that are looking at impacts of zooplankton and phytoplankton. Yeah.
And Tom?
Yeah, just years ago, experiment with the air guns exposure kill the zooplankton, but it's quite limited range, within like 1 kilometer, something like that.
So more to ask to the marine biologists and bioacousticians. I invite you to come to Ocean Noise next May 2026. You will have the right people there. Goran? It's not good. Or where was it? Matteos. Then.
Thank you. Matteos Andersson from Swedish Defence Research Agency. Even though we are a defence research agency, we do civil studies as well. And coming back from hearing all the talk today about need for easy measurements, we are doing a national project on that topic especially. But going from individual measurements further up the chain to noise levels at a fleet scale or a regional scale, we see from the air emission side that you have this kind of index, how you measure on a global scale, on a regional scale. When we do the Marine Strategy Framework Directive assessment in Europe, we do soundscape maps. We're looking at source level models, radiated sounds. Today, I don't know any model actually that can capture any of these measures that we propose here today. So I really call for assessment methods that can capture the individual ships that actually do this kind of noise reduction efforts. But today, to my awareness, we don't have that method, that model that will capture that. So how can we capture the fleet's increase or decreased noise emissions in the future? If they spend thousands of dollars to be less noise, how do we capture that in the assessments we do, and to say if we have good environmental status or not in our seas? There are some issues, there are some examples of global noise efficiency index that's, I know a colleague from Finland is doing, but I think that's something to look into. Thank you.
So I think you're hitting on the issue of metrics and how do we better enable, like what are the proper metrics to enable incentives or other type of action, right? What are we measuring it against? And I think we've heard a little bit about that today, but again, there's not a global, I guess what the question is do we need that global standard? Is that a little bit what you're getting at?
A little bit. It's going to be a feedback loop to the managers.
Yep.
That they actually can see in their assessments that something's happening. The soundscape maps we produce today will not catch that, to my understanding. The source level models we use for underwater radiated noise has only a few parameters in there. There are some that is more complex, but are we measuring the right thing?
I think you have triggered some hands. So, Leila.
Good.
Well, I think this is very important. I think it's a nice way of maybe, I would love to point back at Emilio, so you get more of your panel involved in this, because I think some of the calculations that you were starting to do to try to bring some of the input parameters for CII and EEDI together with some of our input parameters for URN are going to be very important. And I hope we start thinking about that a little bit more. We have a lot of information content going into the metrics we have at IMO, and a lot of overlap in those input metrics with generating source levels. And as we continue to build out how to have a more holistic URN profile for a vessel out of those metrics, it will be really important to marry that really tightly with the type of calculations we're doing for other things. We'll be in a much better position to advise all of these incentive schemes in a holistic way. So I know it would be great to have you sort of talk about that status, Emilio, for you doing the math, where you thought it, and I think there's some talks tomorrow that Matteos, I think, will speak to this as well, and we'll get into this in panel 4. It's a big part of theme 4.
Thomas, you'd like to answer Matteos as well?
Yes. I pretty much agree with you on the more on the monitoring point of view. But the good news is that, and indeed this will be presented tomorrow, there are tools on the predictive. So we can run scenarios with architectural mitigation solutions, and we did that with our friends from Marine in the Saturn project. So on the predictive point of view, this can be done, but indeed in more in the annual monitoring or whatever, this is a missing data because the databases are not sufficiently populated.
Johan?
Yeah, I also like to come back, let's say, to the question on the predictive models. Actually, we were involved in a project together with Jasko on exactly developing a predictive model that could, let's say, forecast future noise levels taking into account technical mitigation measures. It's a piano model, it's not perfect, but at least we're working on such models, and I guess tomorrow we'll be hearing more about it.
Thank you, Johan. Sami?
Yes, Matteos, I think this is one of the reasons why it's so important to get together in workshops like this, because tomorrow during Leila's session, so session 4, we will be touching on many elements that you say are missing, and, you know, having a discussion on how exactly to fill those gaps that you believe are there with some existing tools or how we need to work together in order to fill those gaps. But there are answers to your questions. Yeah, just have to have some patience for session 4 tomorrow.
What a teaser. Charte.
Thank you very much. So I just wanted to talk about this prediction and predictive models. If you may recall, our colleagues from BC Ferries, they highlighted that nowadays they're also asking for their shipbuilders to put their tenders in a way the limitation for the URN limits, so which is good. So at that point, shipyard, they will rely on their designers. So what's the way to improve the, if you like, the prediction of these designers? They need data. So at that point, I think if somehow this database representing the real-life condition in various configurations could be really very beneficial, and also maybe a sort of technicalization group includes, but not limited to, maybe the representative from IMO, ITTC, and also some sensor suppliers, ship owners. They can just come together and inform themselves. So I just wanted to include that point. Thank you.
Chanwoo.
Okay, so just regarding to that thing, like you know, the currently working together is a fantastic thing. However, the big hurdle to do that is that actually the intellectual property of the propeller design and the hull form design. So we know that we need to work together, but the propeller makers will not give you the propeller design information because that's their bread and butter. So, but I cannot blame them. But again, like basically, the working together is the definitely a way to go to tackle down this issue. And if I can, like, I would like to explain a little bit of a background of that coastal class, because Eric, you asked why the other ship owners don't do this, because my simple answer is that it all due to that specialty of the ship vessel operation. Like I always said, the ferry is the very small portion of the world fleet, and especially so it is almost impossible to find such a nice example of like a maximum 2-hour sailing, and the off-design condition is 30% of the total sailing. So we need to tackle down many conditions to achieve that kind of a big drop in the underwater radio noise level, because for example, like a big ocean-going vessel, they spend their lifetime 99% in the design condition, and just very little at the port. So for them, when they design the hull and propeller, it is well matched with their operation. So they don't feel any further improvement to decrease the URN. But for this coastal class case, we thought about that during the building stage in 2008, but at the time, the VFD technology was not matured enough. The efficiency was more than 10% already. We lost. So we knew that at the time, like, oh, this ship is going to be in trouble, but no choice. But now, due to that new technology, we adopted that technology. Okay, this time, let's do that. Because we know that by changing to the VFD and the new propeller, we know that it is going to be beneficial for everything. But I understand that there are not many cases, such cases exist in this world fleet. And I don't know whether I can say that's fortunate or unfortunate, but we have to understand the vessel's owner's operation first, and whether my operation is a good candidate for this kind of upgrade or not. So that's the key issue, which is the understanding first about our fleet and then move ahead.
That's a very good point, but I have always found you too modest. Because if only the ferry sector is also following you, it will be a very good step. In Mediterranean, we talk about Pelagos, where we have a lot of ferries. In the English Channel, we have a lot of ferries. It will be already a very nice progress to touch base with those ship owners. And also, you raised a very important point, is that in the spec, it's not a design, one design configuration that is important. And I discussed with your Mr. from the sir from Nakashima behind you. It's that we have to, ship owners have to be clear on the as far as possible on the operational profile that they will use. And if it appears that they will change it, for sure there will be very fast consequences on noise. And not to say fuel efficiency, and we all know that, and we also, all the massive, including Maersk at that time, massive bulbous bow and propeller retrofit, because the ship were designed at 25, 24 knots and were operated much lower because of the fuel price at this stage. And it's the same, the operation profile is as more important than the contractual speed, not legally and not in terms of contract, and that's where there is maybe an issue, because then it's only legal people with purchasing people that are discussing. But
even from the last workshop is, whereas it was kind of everything was kind of incidental during our last workshop 2 years ago. Now it's purposeful. It's about everything was kind of incidental during our last workshop 2 years ago. Now it's purposeful. It's about purposefully, like, thinking about what is the operation of your fleet, where it goes, how it operates, under what conditions. And then what are the opportunities within that for both energy efficiency and underwater noise? Because it's going, and we've heard it from those many different perspectives, right? But it has to be purposeful. And I think we're starting to see that. And I think that's one of the really interesting progress just that, from today already, is seeing that. And I think that's the change that needs to happen from a design perspective, from a fleet owner.
Sure.
have my peers, a vessel that looks just like mine, installed this? And sometimes the answer is, well, not yet, but look at the data that we've generated through models. But they're like, but there's a technical risk there. How do I know it's actually going to work? And then they say, well, which shipyard is going to install this? And when we kind of say, oh, shoot, we'll scratch off those three. Those two might do it. And how do they know they're going to get the right competitive bid from the right yard who can actually implement whatever this technology is? What's the supply chain for making sure that it gets installed, it gets delivered on time? On a bulker, it doesn't work that way. You can't. So why isn't this being taken up for this these fantastic benefits? Of course, I fully support this. If you can't measure it, you can't make appropriate changes for it. There's another side too, which is that essentially that supply chain and that technical risk aspect. Sure, now we can measure it, but who's paved the way that's brought down the risk so I know that I'm not losing time, that I'm not installing things that can't be maintained, that I'm not complicating my retrofit schedule or my rebuild schedule. So just sharing that's part of this overall conversation.
I mean, I think, it's not possible to regulate at that level most of the fleet, and that if they were exploited, the emission reductions would be huge. So, what the problem is that that's not happening. And the reason that we've got the CII is because actually, that wasn't happening 10 years ago either. There were these barriers to the uptake of these technologies. And the CII was the regulatory tool that was developed quite deliberately by the IMO, and its scope and the way it's structured was quite deliberate. It's not sort of, accidentally the way it is, to try and, introduce a point of regulatory pressure that forces everybody to look in greater detail and to search out and find these options that will reduce their emissions and, bring them into compliance. I mean, it's probably had an effect. It's not had a great effect, but then that's because the requirements aren't very strict and there's no real method for enforcing it. So, there isn't actually that much pressure there. And that's, of course, why all of this low-hanging fruit, all of these emission reductions are still there on the table. Nobody's taken advantage of them because there isn't that regulatory push. So, but it has to be, you can always pick holes in these things because it inevitably has to be quite a blunt instrument because you can't go over every, you can't regulate for every individual ship and trade. You need something that's kind of, that bears pressure, and forces everybody, to make changes that we know they can do without spending lots of money because, lots of things like speed, for example, low or even zero cost.
Yeah, very much appreciated. Just clarifying that the point's not that, hugely appreciated that the point wasn't the IMO should do any more regulation. The point is wonderful demonstrations like what BC Ferries have done pave the way by reducing the risk so that other vessel owners, for ones that look like them, are able to walk in the footsteps. Someone like me can come forward and say, hey, this has been proven over here. We think it'll work for you too. Here's the supply chain. Here's the proof that the technology works. Here's the pieces. So I'm not pushing for regulation. I'm pushing for demonstrations and proof. Thank you.
And I think that would be great. And what I'm saying is that if you've got regulation there putting pressure on the industry to do the right thing, more companies like that will investigate more options, identify the right ones, and then, that gets that message gets spread. And the effect that you're asking for is exactly what, the result is.
We'll take one more. Oh.
Chris wanted to answer quickly, and then one very last question to Sam.
Yeah, thanks, Eric. Just very quickly. On the question, going back to your original question, Eric, I would argue it is already happening. We had mentioned this morning of the annual IMO carbon intensity report of the world fleet, which indicates, depending on which metric you use, the carbon intensity from 2008 to 2024, on average, has dropped by a third. And CII had virtually nothing to do with that. CII came into effect 1st of January 2023. EEDI, yes, for new ships, that had an impact on that statistic. But noting the strong synergy between energy efficiency and underwater radiated noise, it could well be that that has also impacted on underwater radiated noise. Thanks.
Thank you, Chris. Sahan.
Thanks, Eric. I might try to finish with a more positive note. Sahan Bae from representing IACS, but I think I probably have my other hat in this discussion. So I represent Global Industry Alliance for Marine Biosafety, previously known as GLOFouling Partnership. So it's really encouraging to see the uptake of biofouling and the hull fouling and the reduction of URN, which is, I don't think, something we have studied during our GLOFouling state. And we have done many studies understanding the synergy between the energy efficiency and the prevention of biofouling. Maybe next year workshop could be the synergy between energy efficiency, biofouling, and underwater reduction. But I think we also need to be keeping an open mind that synergy would not always possible. So we hear the example of marine growth prevention system using ultrasonic. The reason is that, like, even though we have isolated regulation for EDI and even for the biofouling now coming in the mandatory regulation, at the end of the day, all these technologies are used on shape in tandem. And then if you take, for example, the ultrasonic device, it could be more effective in prevention of biofouling in a niche area. So it's a very valid equipment that has to be installed on a ship. If it has a negative impact, what are we going to do? I think that's where perhaps the glow noise program and now the test biofouling can come in together. Start a project, develop a study to understand what is the impact of hull fouling to underwater noise. If in future, with a mandatory instrument, if there's not going to be a macro fouling, if that reduces underwater noise, great. But if there are technologies and procedures that have a negative impact, this data is important for those technology developers to make adjustment. Maybe they might change sweeping frequencies rather than one sweep. Maybe we try to switch it off in a sensitive area. I don't know what the solution is, but these are the ones that we can actually find out. So it's a suggestion for SafeTap over here to work with probably the test biofouling and try to understand how we really find the synergies, turning this negativity into resolving some solution. Thank you.
Thank you so much. And that is a great note to end it on. And I think that's a little bit, it was the impetus behind a lot of these conversations is we know that there are some technologies that they work together, but we also know there are some where it actually increases noise, but improves energy efficiency or vice versa, right? So how do we identify what those are and encourage ship owners not to use those ones so that we are actually addressing both issues and not exacerbating one at the expense of the other, or improving one at the expense of the other. So then it's the same with biofouling, right? And admittedly, I think the ultrasonic fouling is one that we've kind of been like, let's not talk about it yet, because we know that it's becoming more prevalent. We heard two presentations today that both showed those spikes, and it was like, oh, yeah, okay. So how do we address that as well?
And so there is a JASCO paper on that as well.
And there's a JASCO paper, of course there is. So it's a very good point. So SafeTap's taking notes. I see it. Take note.
No, but it's a very nice takeaway as well to see that convergence of interest and the change of mindset by taking precaution of whatever we do.
It's just one word, please. I mean, I don't want to be late also, but I think that's a very good point, and thank you for this contribution. And I'm sure that many of the delegates, maybe not experts, are aware of it, but also TCID is going through a structuring process at the moment, where we have seen these synergies. So we're bringing together the biodiversity and ocean, that is a kind of thematic approach we can maybe call. So we will be much more having closer relations with the biofouling project and the noise project as well. And one last point, that under the GLONOIS partnership project, many of the colleagues also here know that we are also exploring the potential of the creation of a global industry alliance, a very similar structure with the marine biosafety. But due to the limited timeline of the project, we couldn't, but we have the interested partners here who are already supporting us, and we hope to also create it in the follow-up phase of the project, which we are designing. Promising. Thank you.
Excellent. Thank you, Sevtap. So I think this is actually a good, I mean, a lot of the comments today, I think, really set us up really nicely for tomorrow's discussion, which is, why the fabulous organizers set out these themes this way, I think, knowing that they kind of flow into each other. So very well done, Aurélie and Lila, on that one. So tomorrow, our themes are looking at integrated design standards for energy efficiency and URN, and predictive models to evaluate co-benefits relative to energy efficiency and URN objectives. So you can kind of see how, looking at what is the state of technology that we have, what are the incentives for doing this, and now we're looking at, okay, how do we look at this integrated designs? How do we look at, what are those predictive models to help? So this is kind of intended to carry the discussion from today forward to tomorrow. We have another full day, but first we have an amazing reception. I don't know, Michael, did you want to talk about it? I will turn the mic over to you, but maybe before, just to thank everybody for the contributions today, the active discussion. I think we see already the maturity, for those of you who were here 2 years ago, the maturity of the questions and the discussion and the conversations and the presentations is really reflective, I think, of, again, a little bit more of that purposeful consideration of the interaction as opposed to the, well, look at that, we hadn't thought about the noise aspect of it. I think, Gavin, that was your best, the very first workshop, you're like, I never realized it, but wind, of course, it's zero emission and zero noise, so how are we not talking about this more? But now we're actually talking about it. So just a thank you. I don't know if any, thank you to Eric, my co-moderator. You're fabulous. And over to you, Michael.
Thank you very much, Michelle. Just to wrap up for the day and let you know what's going to happen next, I think it was a truly interactive day, really fantastic. There was more involvement by the audience on a constant basis, rather than just hearing presentations, and brilliant interaction by those who are presenting with the audience. So thank you very much for that to all of you. Really masterfully orchestrated by two very dedicated people, quite obviously completely immersed in this topic, Michelle Sanders and Eric Baudin. So thank you very much to everyone for your fantastic contribution today. Tomorrow we're going to start at 9:30 sharp. But before that, and there's been a lot of talk about low-hanging fruit, and I'm pleased that Sevtap Osgadon was the last person to speak this evening, because the Glow Noise Partnership are providing well-fermented low-hanging fruit for us downstairs straight after we close here. So if everyone goes down to the Delegates Lounge, and I'm sure we're going to have a very enjoyable time. And to remind you that there are experts doing poster presentations, really interesting poster presentations. So make your way around the room and look at those poster presentations and speak to the experts, which you're going to find extremely interesting. Thank you very much for everyone. That closes the workshop for today, and we'll see you in the morning. Thank you.